My name is Theodore Spiropoulos, and I have the pleasure of basically welcoming everybody to what I hope is 2 days of very engaged conversation around the problems of architecture, urbanism, making, thinking, conceptualizing, all of the good stuff that we labor over to kind of develop, let's say, and prototype the future. We are always very kind of enthusiastic about this moment in time because it's really the culmination of a year's hard work. And the students are coming here, I think, with a lot of ambition to kind of work on problems that are very challenging and in an unapologetic way believe that design is very important and meaningful and that people deserve better. So I think the work that you're going to be seeing today is thematized around 4 strands, and those are led by different components in the studio. And you'll be looking at issues of gamification and how that somehow engages in a way to somehow open up conversations about how we can plan and develop our cities together. We're going to be looking at explorations of the metaverse and the cyber-physical and trying to engage in conversations about what that conversation could look like, what user experience within the realm of architecture and urbanism can enable. We have a studio that's exploring the issues around mobility and trying to look at architecture not as something fixed and finite, but something that is fundamentally looking at the ways that we somehow live, the ways that we explore, and the ways that we can kind of situate the world in a almost product design kind of sensitivity to design. And the studio looking at issues around the environment and the elemental, exploring phenomenon as a form of technology. The way that we've organized the day is a little bit of history, 1 hour per team, conversation around the thematics. Each studio group is going to be presenting their sort of take on these kind of research agendas. And at the conclusion of 20 minutes of their presentation, they will walk through some of the physical prototypes and artifacts, some of the demonstrations of VR and AR and other kinds of elements. And then we'll open it up for conversation. I'd like to thank all of the critics who are joining us. Of course, this event is conversational, but it's very much enabled by the feedback that we have, not only from the invited guests that are with us here, but the community both here and abroad, as this is live streamed and shared in a kind of continued effort to make things accessible for people that can be here with us and not. So with that, I'm not going to give any more of a speech. I'm going to let the work speak for itself and the conversation kind of unfold. We hope that you can join. There is a website that has been shared, and I'll ask the guys to share it on the YouTube stream, that does justice to, I think, all of our critics and their bios and their work, to give a context to the conversation as well. So with that, and no further ado, I'm going to ask the first team to present from Pierce Studio. Thank you.
Hello everyone, I'm Cemre, and this is my teammates, Shrestha, Meher, Su, and Bensu, and we are group Amphibious choreography. This year at NG Studio, we explored Diana Friedman's vision of a mobile architecture and revisited existence minimum concept on a near projection of future. The research gravitates around programmatic overlays and amphibious environments as a testing ground for extreme adaptive and transformational qualities. Humans have long been drawn to the coastal areas for a variety of reasons, including their abundance of resources and logistical importance as points of access. A large portion of humanity is concentrated along or near coast, and about 40% of the world population lives close to the coastal areas. And settling on water is not something new, and it has been done along the centuries, and it has many ways of doing that. Given the condensed population in coastal areas at high risk of rising sea levels and 71% of Earth's surface is water covered, above water and amphibious settlements poses a great potential to extend human existence and address the issues of climate change, floods, overpopulation, land scarcity, and unplanned urbanization. Amphibious choreography aims to introduce water as a new blueprint and propose an alternative life oscillating between the land and the water as opposed to fighting challenges that water poses. To adapt, challenge, and take advantage of the problems, we redefined a hybrid, mobile, space-efficient, and self-sustainable living driven by ergonomics and proxemics. Through these conditions, the majority of existing will remain above water, with mobility at the core to support this dynamic life. Besides making a living that shifts between the two mediums possible, the mobility aspect will respond to the diverse challenges that each environment will poses as well.
So here at this part, we will be presenting the present-day problem research that we made about the thesis background. So starting with the coastal erosion, due to the action of natural effects like waves, current tides, wind-driven water, or other impacts of storm and man-made factors, soil erosion is resulting in the loss of land. East Yorkshire has the fastest eroding coastline in Northern Europe. Along history, seawalls have provided a high degree of protection against coastal flooding and erosion. In terms of durability and ecological performance, as mentioned in our thesis, a soft system could answer coastal erosion problems in a better way. As a background research, wave variability along the world's contention shelves and the coast has been analyzed, and the major swell events have been highlighted in these maps. Here we will be presenting our research about the wind waves' potential coastal effects. The number of swell events generated in Northern Hemisphere is considerably smaller. The most important generation region in Northern Hemisphere is observed in the North Pacific Ocean. We also highlighted the shoreline alterations from most altered to least altered. About the environmental pollution, we expressed our research on water pollution, land pollution, and air pollution. Here, these coastal cities subject to significant environmental pollution cases. And here we talk about the carbon pollution next in sea level rise for centuries. This is a prediction map that we got from Google Earth data, which is expressing the expectation how fate of coastal cities depends on cutting emissions. These are the 8 universities that will be underwater first and the developed seawall protections. About our site analysis, we are dwelling on the Thames history and in Canvey Island. Canvey Island is a town, a civil parish in the Thames history. And it is famous with its historical background and the flood events and the seawall barriers. Here are the case studies about the amphibious floating housing projects on Canvey Island and the Thames history. And about our case studies, we wanted to express the Canvey floods and the historical weather simulation archives.
We then made some background studies for a hybridized life between two environments. We looked at the rowing motion of boats and we looked at the manta ray, which not only swims but also goes in the air. We looked at the motion that it follows in order to achieve both kinds of mobility, both on water and above it. And we learned that the sinusoidal motion that happens with the wave and with the fins of the manta ray enables it for that. We were also inspired by some of these references that we found, this robot that uses a single mechanism, a mantle skirt, to both swim and to walk on land, and uses the contraction and relaxation just as in amphibious animals. We made some CFD studies with some primitive shapes for our form finding. And following these studies, we arrive at our unit design, which consists of a monocoque or an exoshell, which is the main habitable space of our unit, which is further subdivided by a floor plate, which splits the overall volumetrics into two. And then there is a secondary layer of rotating floor plates which slide out, activating the expansion of our semi-rigid walls, which consequently expand our flexible roof and increase the spatial occupancy of the interior of the units. This entire system forms our core habitable space, and this is then skirted by a set of fins or the mantle skirt, which helps in mobility. And then lastly, there is an air cushion which inflates to resist the friction when it moves on land caused by the terrain or the topography. And here we can see the assembly or how the entire unit comes together. This rotational expansion that we have talked about not only increases the interior spaces, but also enables the unit to shape-shift for different conditions. And like as we can see, when the unit is in motion on water, it is at its most compact state and is in a bullet-like form, which helps with the fluid dynamics for the motion. Then when it's static on water, it is fully expanded because that is when it needs to be the most self-sufficient. And when it's on land, it is in a more rectangular or a linear form to be in coherence with the grid-like urban fabric existing on land. These are the visualizations for how this expansion is taking place in the unit. And we also did some prototypical analysis to study this expansion, and we used a curving method for expansion of the walls and a pre-programmed fabric for our flexible roof.
The monocoque is the structural core of our essential unit that interfaces with different components of material and stiffness properties. We studied closely its size, weight, and geometrical form to achieve a design that is strong enough to hold the structure and the connecting components intact, but light enough to float when situated on water. To integrate each of these properties and optimize the design, we explored several models and cataloged them to compare in terms of fluid dynamics, buoyancy, and transformation capabilities. And after these studies, we have landed on a design that we moved forward since it provided the adaptability and flexibility to the parts that move and orchestrate shape-shifting under different environmental conditions.
We then have the mobility aspect, which comes with the mantle skirt. And in the structural assembly, you can see the fins are made from strips, which also have solar panels integrated to it. And then we have the flexible membrane that covers it and creates a smooth surface for the motion to happen. And then we have the inflation underneath, which is needed under certain conditions. Here you can see the assembly of how the fins are located at both sides, which was inspired from the manta ray itself. And here we can see the motions that in each condition that has in the fins. As we know, as we have said, when it's in water, it is fully in the sinusoidal motion at its sides, and when it's on land, it's again doing the sinusoidal motion, but this time it's doing a crawling sinusoidal motion because the fins are tilted 30 degrees downward. And when it's static on land or in water, the fins are either horizontally at the side, so it can be used as exterior terraces, or downwards, which can be used as canopy. So from environment to environment, the form and the usage of the fins changes. Here are some renders. You can see how the fins are being used on different environments. And this is how it is swimming. And to aggregate, they have female-male connections to join one unit to another, whether it's on water or it's on land. Depending on their motion, when in terms of catastrophic conditions, they can gather around and move together when they're aggregated, as seen in the visuals. And this is how it is being used when it's on land and in water, as the terraces. And since it has solar panels integrated, it makes the unit self-sufficient more. And depending on the condition of the environment that is in, the frequency of the fins are changing. It can speed up, and the sinusoidal motion is changing depending on the amplitude and the frequency. These are some studies that we've made, testing how the frequency and amplitude is creating a different trail in different conditions. This is the highest frequency, which means it's moving really fast. In case of high tides and difficult conditions, these frequencies can come in handy. And in order to make the unit more self-sufficient, we have decided to integrate solar panels to the fins and make use of the tidal energy so that we can help the environment and make this unit be self-sufficient on its own. When we think of the interior of the design, we have a ground floor and the bottom floor, where the bottom floor is being used as the ground floor when it's on land, and when it's on water, the ground floor itself is where the thing is. And inside these places, we have a navigation space to control, along with 2 private spaces that can be used by the users as bedrooms, and the communal social space that can be used when other people are joining the unit. And at the ground floor, we have more static things, such as the kitchen, the recreational area, and food harvesting area to make the unit more self-sustainable. We have used ergonomics and minimal space to create this design. Here you can see the transformations. We have 2 main transformations. Interior transformations, which happens when the interior walls are moving. This is regardless of what environment the unit is in. Depending on where the usage is mostly happening, the interior walls of the private space can expand and shrink and change the usage of the unit. We then have the exterior envelope changing, transforming, depending on where the unit is in the environment. This is the ground floor, which is the most transformable part, and bottom floor, which is the most static. And when it's water in motion, as we've said, it's in its most compact form, and it's water static, it's most in its expanded form, because on land we have enough hard space to use, but when we're on water, we need hard space. That's why the unit expands most when it's in water static. These are some of the sections, and you can see how the activity changes when it's on land, and how the usages. We have an entrance at the bottom. And when it's water in motion, different parts of the unit are changing and transforming, adapting to the usage of the environment. And yes, when it's water static, the fins are used as terraces, as habitable spaces, and we have the elevations of the unit showing each motion, and technical drawings to support how we're thinking of these transformations, which are mostly rails inside, and curving soft systems around. We want this unit to be a soft system to respect the environment that it is in.
In our previous research, performance, use of space, and body movements in interaction are analyzed. According to our ergonomic studies, experience and interaction between body and space are illustrated in these videos. In the land scenario, we mostly designed retractable and In a land scenario, we mostly design retractable and rotating furnitures that are designed to maximize the user space and in a minimal space. It's not moving. Okay. So according to our ergonomic studies, user experience and body interaction between space are illustrated in these videos. In the land scenario, we mostly preferred retractable and rotating furnitures that are designed to maximize the user experience in a minimal space. Here we highlighted how these furnitures are activated according to user needs. This is the upper floor and the furniture design studies according to ergonomic research studies that we made. Following that, we will be showing the bottom floor, which is designed for food harvesting area and social interaction studies. Here we are providing some retractable, expandable shelves for maximize the food harvesting space, and compact furnitures which can maximize the space for user needs. Here we wanted to express the daily cycle and interior ergonomic research. So from a night to 24-hour scenario, you can see the daily cycle of a person on the water scenario. This is the upper floor bedroom view, and here we can see that how furnitures are expanding for one user to two people needs in this bedroom. Here we are showing the back parts of the upper floor, and we highlighted the social interaction area. So in a 24 hours daily cycle in a minimal space, we try to maximize the space for the user experience. And here we highlighted the bedroom from a night to morning, which is used by one person and expand for multiple purpose and people usage. These are the retractable and compact furniture designs, which is fitting the customized space perfectly. Following that, we will be showing a noon scenario when the back part of the bottom floor is used by multiple people during the day. Here we highlighted our ergonomic studies and the compact retractable seating areas. And moving furnitures which can be deployed or collected in different corners of the units. For different body movement activities, this space can be used in different purposes. And this is the bottom floor with the food harvesting area. In a daily cycle, on the water scenario, people keep themselves busy with food harvesting and protecting their own stuff. And these are the renders from our unit design on water. Here we highlighted the entrance of the units. To find the most optimal floating form, we made several particle simulations with our final render and final unit and the previous studies that we made. These are the buoyancy studies that we made on water, from deep to shallow water. And through changing the wavelength and the wave stiffness and several parameters, we saw how our unit is activated in different water studies. Here we highlighted water-to-land transformation. In different frames, we showed that the compact unit form on water, expanded unit form, while the transitions phase in motion to land, and the land form. This is the water-to-land transformation from the section, and here in water motion, and the fin transition in phase, air cushion activation, and unit change.
In this section, we will talk about how our units act when they are in a community mode. Our proposal could be considered as a tactical taxonomy of unit genotypes and phenotypes having distinctive characteristics and functionalities. When these individual and task-specified units are combined with various interlocking and merging strategies, a self-sustained and collaborative living that is able to adapt to dynamic environments emerges with the presence of a twofold nature. And the unit types can be classified as the essential unit that is accommodating to residents and other supporting units such as the hubs and the food harvesting units. The units that we have introduced can represent a collective in different scales, such as microcluster, macrocluster, and then megacluster. In this proposal, we have only getting to the point of macroclusters, but it has the potential to reach the megacluster, which has different programmed units connected to hubs of different sizes. Here we see also a breakdown of how they assign different tasks in the whole system, so that we see how these phenotypes and genotypes are acting together. And we can say that the connecting hubs are the main social interaction space that allows units to dock and extend their program. And it provides a soft infrastructure for the needs of an amphibious community. Since the smaller units are designed with minimal space and have a limited program, hubs play an essential role in generating an expanded program. Here we see an illustration of how this microcluster and macrocluster could take place.
Here we see the illustration of aggregation types on water and on land. On water, we mostly face with the grid-based organization and hexagonal grid-based organization. And on water, on land, we see the linear and the branching organizations. This is an expression of aggregation on water. Our units can aggregate through following a linear path, or they are smart enough to follow some flow paths that are not predefined. And this is the aggregation scenario on land. Here we express multiple units or a macro cluster aggregating and the fin aggregation types. This is the social interaction on water scenario. So as we imagined, on the water, people can use this space, which is collected by pheno and genotypes units, and they can create different scenarios. These fins integrated can create some decks for different user experiences and multi-purposes.
Yes, other shots from that perspective. And here we have the prototyping part.
We also develop our design through physical prototyping. In the initial stage, we test some initial form through a floating test. And we also put our final geometry into the floating test to see the collective behavior in the water. After that, we have our contact model, which showing the behavior on both collective behavior strategy on both water and land. And we also aim to achieve the transformability through physical model. This is our first trial with the piano wire model, which tells us that it's important to have a transformable envelope. According to that, we start to research on expanding skin, which is printed by resin. We were also inspired by this context card. We learned that we can achieve the transformation through using the aesthetic curving on semi-rigid material. And we also stick the semi-rigid pattern onto a pre-stretched fabric. And we try to 3D print it on that, which can better control the pattern. We did several tests with different patterns. And we also try to achieve our sinus motion through controlling the fin strips. This is the manual control one model. And this is the Arduino actuated ones. And at this stage, we want to assemble our physical study together. We have the curving semi-rigid material expanding on the side. We have the pre-stretched fabric on the top, and we have the fin strip doing the sinusoidal motion in the middle of the model. And this is the final behavior of our transformation model. And this is the end of our, sorry, wait.
We'll be showing our physical model and design studies that we made during the design process. These are the first CNC and plastic molded studies that we made to test the best floating performance and the curving studies. Here are the fin motion studies. This is a preliminary Arduino activated sinusoidal fin motion study. These are the skin studies, and here we express the pretension fabric studies, which are the 3D printed models on the fabric. And this is our curving study and another curving studies. Here we wanted to express the unit aggregation in different phenotypes and genotypes on a topography model, which is CNC cut. And this is our manually activated Cinewave and fin motion study. To express better the interior studies, we made a unit section cut model in 1:20 scale. And here is our Arduino activated unit transformation model. And finally, we wanted to express the 3D printed units floating on the water. Thank you.
We have two microphones. One is on that side here, Andrea, and one's over here. Costas, you're not obliged to. Costas. need to share. Because it's not hot.
I have a couple of questions about power. Where's everyone? There you are, sorry. Hi, I'm Molly Steenson. How are the fins powered? Where does the power come from to provide the movement, whether on land or on sea?
Sorry. When we're on water, we're using the tidal motion to actually initiate, but in case if it doesn't work, we do have a motor system that integrated it, but mostly we're trying to use the tidal movements to move the unit when it's needed, and when it's on land, we're using wind and solar power solar power is the main power we use on land, and in water, it's the tidal power.
I realize over the course of a year you've focused so much on many different things. If you were going to take this forward, I'd wonder what kinds of power generation strategies you might find, whether the kinetics of the fin structure might, I'm seeing a lot of people nodding, so I think this is something you've probably talked about, might generate energy as well as produce motion. With this sinusoidal motion, are these structures able to respond to the movements in conjunction, the forces of the water and the water back against the fins? Because what you've shown here is just the continued kind of movement. Can they correspond to each other?
Yes, absolutely. As we have also shown before in our presentation, like the fins can respond to the waves and to the water, changing the frequency and the amplitude as and when needed. Not just the waves, but also the wind, like all sorts of environmental factors that might affect the overall motion or the stability of the unit. So, yes.
And we've also added an inflation system underneath, inflatable system, to help become a high-pressure air cushion so that when it's on land, the friction will allow it to move and stand on its own. So we also have an integrated air cushion underneath it with the fin system. So also when it's on water, to remain static, it will inflate and lift it upwards so that the tidal waves are no longer in contact with the units itself, but only with the fins. So fins are adapting to every kind of environment and condition. In this.
So I've got, if that's okay, quite a few questions, but I'll ask two to start with. So I was just wondering, who is this for? If you have thought about, like, on what level are you kind of pitching this on? Like, is this for like a mass production? Because you start off with this condition of coastal erosion, and you're looking at very big scales, like urban scales, and like whole regions and all of that, which to me would imply that you're trying to design this for a lot of people. So the question is that true, or is it more for like a smaller amount of people? And then number two is, the other question is, because you showed quite a lot of things in your presentation, you did all of these different studies. My other question would be, what kind of discussion do you want to have on the project? Is the discussion on how well it performs in the water, or is it how well it creates a community? Is it how well you design this internally, or which one of these, or is it something else?
Actually, the core discussion here is to create an amphibious living, and therefore we wanted to show on different scales how this amphibious living that oscillates between land and the water can happen. For example, the units can cluster, the accommodation units can cluster, only the four of them in terms of their fins that interlocks. But in a broader scale, it is possible that we extend this as the site allows and form a greater community in case of the environmental conditions get even worse, and we have the opportunity to extend because water makes up more surface on Earth, and it proposes many potentials, such as food harvesting and the tidal movements and so on. So the conversation we wanted to have here is that this proposal is doable in many scales. I hope that considers.
And we also want to add, we want to, up until now, the problems we've said was about flooding and stuff, and people have been trying to create not long-lasting solutions. So we wanted to create not just being against the nature, but adapting to the nature, accepting the fact that, oh, there is flooding happening, but our solution is we will adapt to this condition and create a settlement that will be able to move between land and water when needed in different contexts. It could be Thames, it could be anywhere which faces the same problem, but the idea is to approach this problem with a soft infrastructure rather than a hard infrastructure, and protect the environment and adapt to the conditions that it brings to us.
Thank you. And would this be like now, or are you anticipating this to be like in the near future, or like?
In near future.
Near future, okay. Okay.
To say the most.
So the reason why I'm asking this is, I think first of all, congratulations. I think it's a very interesting project. It's very well designed.
Thank you.
And you arguably must be very happy to get to this stage with the project. But there are some things there that I think maybe is worth questioning and like thinking about, like for afterwards. I mean, you're at the final stage now, but maybe to delve on later on. So number one is, if this is for what you just said, that it is for like a large kind of conditions where there's flooding, there's movement of populations, migration, all of that. Mm-hmm. What's going to happen is that in that scenario, you're going to have many, many, many people. You know, like you're going to have hundreds of thousands of people displaced. Mm-hmm. And therefore, number one, your system would need to play it out in very, very large quantities. So you would, like most of your like panels here, they have a few of these like modules. But in this scenario that you're describing, we're talking about hundreds of thousands. So that becomes a very complex logistical problem of how do you organize this. You know, you showed that in some of these you harvest things, you grow things. But, you know, like if you do that, that's fine. But then the big question is, like, what area are we talking about? And to harvest something, to feed how many people? Because you might find that, you know, to feed 2 people, you need, I don't know, like a square kilometer of kind of produce or something like that. So the scale is very, very important in the project. And then the other thing is, that is, for me, is very important as well, is the cost. Because if you're saying this is for mass production, at the moment, it looks a bit like it's more for like a millionaire kind of club of people that, you know, for Elon Musk and his mace, but which is okay. But, you know, you can even say that potentially, you know, although it's so well designed and it could be very expensive at the moment, with technologies that might evolve in the future, the cost might be much cheaper, etc. But it is a question, you know, cost, especially because you touched on fabrication. And then the other last part is that you have this obsession, which is positive in my opinion, with the flaps and this kind of sinusoidal movement at the side, which is abstracted from the manta ray. But then the first big question always with this is the scale and translation. If you take something from the manta ray and scale it up by 100 times, would that work equally well? And then the other thing is, I mean, it's a bit of a basic question, but you know, you could have an engine there making this move. You don't need this kind of movement of the sine curves and all that. So the question is, does this do something more than movement, and therefore you need the sinusoidal kind of flaps at the end, at the side? Or in other words, you know, you could easily replace this with an engine. It could work equally well. So if you're so obsessed with this, then in my opinion, again, it should offer you more things. Like you saw this moment where 2 of these meet and the flaps become flat, and that creates often an in-between space. That gives it more reasoning then. But I would think that then you would have to develop that a bit further and show what kinds of spaces, how many of these do you need to create a larger kind of plaza-like space, etc. And then last thing would be like, you've done a lot of little kind of researches, but I think it would have been beneficial for the project to focus on one thing and do it over and over and over again, trying to test, you know, the ideas recursively. Right now, it feels a bit more kind of jumpy on different things. But other than that, again, yeah, thank you very much and congratulations.
Hi. I don't really want to get into anything that's negative at all here. I don't, because, you know, when you deal with design, how can I say, you have a dream, you know, you set up a vision, but you also have to challenge your own vision. You know, you get to a point where you have to say, you know, is it really working or is it not? You know, I love all the idea of biomimicry and taking our leads from nature. I think it's absolutely wonderful, and that will come, absolutely. So as a project, it's really well presented, I have to say, even if maybe some of the things for me I could challenge. I like the presentation, I like the in-depth quality at every level, but when I say that you need to sort of revisit, you know, this dream that you set up, I think it's completely right. You know, this luxury object, you know, on water it has least resistance. So in fact, there's a condition on the water which is very different than the land. And so, you know, why did you not look at, say, trying to harness hydrogen from the water, you know, using solar? So you have an integrated system. That would have been nice. Or magnesium. The oceans are full of magnesium. You could have taken that as a power source. So there's a number of little contradictions here, which I think if you ask yourself the question, you know, is it really working? You go, not really. But then I don't want to kill the spirit of what you're trying to achieve. And, you know, if this was created in volume, then fine. I don't think it's that luxurious, because even cars today are becoming incredibly luxurious at a low level, because it's just the way that systems are laid out now. But things I like, and I think you could go on and develop, are the idea of deployment and adaptation of form. And I'm working on a super yacht at the moment. I'm looking at how the hell you dock it in a narrow space, but then when you're on the ocean, you're not restricted in scale. And that's a really interesting idea. The idea expands out and can be whatever it needs to be on the ocean. And when it comes into a sort of harbor environment, you know, where you need to take supply and dock, you know, it becomes contracted. So there's a few things in here which I think if they'd have been talked about several months ago, I think it could have really helped you, you know. But you know, you're having a go at something, and you can't possibly understand or have all that information, you know, than us lots sitting here now, which do have a lot of that information. But on the whole, I like this subject. I know that Theo has been looking at this idea of, you know, oceanic habitation and harvesting for a long time, and it will reach a conclusion at some point. But thank you for your lovely work.
Thank you.
I just find this a delight, and thank you very much. Obviously, rising tides are huge. They're obviously a huge problem, the rising tides. I guess I just wonder one thing, and you've partly addressed it. I'm interested in the behavior of this under extreme conditions and the kind of hydroponics that you might be thinking of. So you've chosen wisely, but there are other possibilities, and this is not critical. This is an invitation, as my distinguished colleagues have said. You've chosen a soft landing and a soft base for it, but under extreme conditions, it's helpful to have a hull. And when a lot of them would be docking, I mean, imagine big tides, the things we're seeing all over the place. So these extreme conditions are going to be happening more often. They could crawl to land maybe, and maybe they'll choose that. But if they're out at sea, big wave comes, how does the assembly behave under a big wave? So that puts a level of stress on not just the connectivity, but the behavior of any individual one. A hull might be, not a hull as much as, or a keel, I mean, but something that drops down, provides the opportunity for hydroponics, comes up when you don't need that or don't want that. You could try to figure out your own growing. You could get some cooling from that as well. And, but to simulate the behavior of the aggregate and the individual when the waves are getting nasty. I mean, big is bad. So have you thought about that a little bit, maybe?
So, yeah. About it, we suggested some different clustering styles on water and on the land, and the grid-based hexagonal study is designed according to extreme wave conditions. So we suggested an hexagonal fin edge, which can allow units to aggregate in different sites. Through that, our units can create some barrier when they are clustered on water for extreme water conditions. And in our simulations, we also expressed that these units can be collected around some main food harvesting or bigger hubs that can survive better in these extreme wave conditions.
I would like to add also that the reason why we mostly focus on not so intense environmental conditions is that our testing ground was Thames Estuary, which is a great ground to explore the movement, the crawling of the units. And it's a very closely situated area that doesn't have very intense wave conditions. That's why we focus morely on that, but we left a little potential to develop how they would act under like severe conditions.
I would challenge you. Have you looked at how manta rays, so to go back to the biomimetic example, how they respond to extreme conditions, how they cluster? I mean, I think your answers are there, right?
Yeah. When they we suggested that the interlockings and the fin connections are what's making them together, but under the severe conditions we're talking about, we will be introducing additional strategies for that. That comes from the same principle.
I guess my question would be, go back to that biomimetic example, how do they come together? I mean, I've certainly come across many rays camouflaged on beaches individually, but how do they coexist? How do they mate? All these sorts of things. It would be interesting to extend that biomimetic example.
When we were looking to the manta rays, actually we saw that depending on the water condition, they can go more in depth. Actually, they kind of overcome these conditions by changing their depths most of the time. So because when you're underwater, the motion is less compared to the above surface condition. So rather than coming too much together as clusters, they tend to change the depth of water. So they respond more like that. And what we researched on was mostly like that. But yes, that's I don't want to further say anything wrong. That was the part we mostly went in depth.
I mean, first of all, congratulations, beautiful project, very suggestive, very plausible, and I think the manta ray movement is a big part of the aesthetic. And also, it's this character that robot you showed means it is feasible, and I can see the amphibious potential of that. So, and I do find it interesting that it has these additional functions, the terraces, the docking together, the harvesting of energy, tidal and wave energy, and so on. So all of that, I think, is an essential part. So to take that off and put a propeller and an engine in there is not going to be, will take a lot away from the project. So I do love that, and I think the design is very convincing. I love these renderings. The estuary setting is I think quite convincing, and although even if it can be imagined to scale up, it may scale up more in terms of multiplying smaller communities, a bit along the kind of new urbanism vision of villages and small towns which spread across the landscape and have a community sense and a center and a series of shared activities and so on. I've just been rereading new urbanism, so it is part of that. And of course, initially it's going to be a pioneer community, and you have kind of early adopters and pioneer consumers who are those who have the time, passion, and resources. But I do find it credible, and I find it quite convincing. Now, as a designer, stepping back, I do want to say a few things where I would come in and do more. On the one hand, on the interior, we have all these examples of microhouses and cars and boat design, and there's not sufficient compactness and tightness and rigidity, and you see some of these furniture a bit loose. It's too much space, perhaps, as well. So it's not bad. Don't get me wrong, right? But I can imagine quite a bit more refinement, sophistication, investment in that. And the second one, I think I do love the aggregation in these groupings and so on, and the concept sketch of these public spaces, but they're also a little bit kind of very loose. So there's kind of monocoque type structure on the individual unit, and then the big collective structure is a little bit, I mean, it's highly sketchy. So there's another area in the division of labor of a team where we would like to see a bit more tangibility, but overall it's really stunning, and big congratulations, I love it.
Thank you.
I would add, I think the ways that you are less successful are at the micro scale and the living scale. And you use the terms user experience, but not living. And when I look at this, these videos of these cyborgs dancing at high noon in an enclosed space, I think, my God, they're going to die. So there are questions here about what kind of living. We all do a lot of living and learning on screens, and even if you're talking the near future, how would people use a screen in so bright an environment? How would people come together? I feel less convinced about some of your models about ergonomics and proxemics, as you put it, around the industrial design and the furniture design. So lots of opportunities for growth. I was struck by the macro, mega, micro, and I think that you've actually been quite successful at the meso scale. And so there might be opportunities to think of how you move, not just stepwise from one to the other, but how they glide from one to the other, quite literally speaking.
Thank you for the presentation. It was great work, and also really nice design proposal at the end. I just want to maybe add one view in relation with the scenario, no? Because of course, like when we design, we speculate a scenario, and then we design a tool or an object or an artifact. But then I think when we have it on the table, we can just then imagine which other scenario we might start to project on it. So like in my case, I feel like what is nice, what you're proposing, is this idea of nomadic individual lifestyle. So of course, when we have this kind of like extreme condition, maybe the units can aggregate, it become just a part of like a collective type of environment. But I think what is nice is also to imagine what does it mean to actually have this kind of pot that become our kind of condenser of all our function, all of object, all our belonging, and we can just live there in isolation. So I was wondering, like, for example, do you have an idea how long it might take to go from London to, let's say, New York, for instance? If I want to live, if truly I want to live a nomadic lifestyle, now I think that is what is nice. It's not all constantly thinking about, okay, I have a unit and the unit need to aggregate and we have to meet up with other people. I think it's nice to also think what is the isolation, or what is actually, I mean, we live online anyway, like, so physically we don't really need people. So like, what is actually the behavior or the sustainability of the unit by itself?
So the idea was to begin with design for an off-grid lifestyle.
Guys, could I make a little, if we're going to have this back and forth tennis match, we're never going to get all the critics to give you guys some feedback, and we're going to be here for like 5 days. So my feeling is, if there are specific questions that the critics need for you guys to answer, you do that in a tight way so that you get as much conversation going about where the potentials are. I think the purpose of today is to explore the work that you guys have been doing, see potential territories that maybe you haven't investigated in, just to give a bracket. You guys are, submitting a thesis. So I think the conversation here is really about speaking about the complexity of design, and all the questions I think are just really things for you guys to consider. And I'm only mentioning that because as the day evolves and the studio conversations evolve, I think that opportunity is a very important part of why we make this a public event, and the conversations around that obviously are really beyond an individual project. I think that they set up certain kinds of terms of engagement, which I think are very important for all of us. I don't mean to steal anybody's thunder, but I do want to kind of sort of suggests that the discussions of the complexity of design are many. The opportunities prototypically suggest that there are also many potential ways for you to think about the project, and this is the opportunity to discuss them. Philippe, please.
Yeah. Yes, congratulations for this project. I also believe it's a very interesting proposal. The only thing is that I believe it lacks a bit of radicality regarding the best ideas you have. For example, these unfolding platforms. For me, this is the most interesting part of the project. Here, because you connected this concept of platform with a sinusoidal movement, that would provide movement, is a bit. I'm not sure that probably those things should have been decoupled, according to me, because of this multifunctionality, you cannot really push the potential of those two concepts. I mean, the one of energy and power, and the one that would be, in a sense, much more architectural, which is this, the potential of the platforms. So I really believe that at some point your project is full of very interesting things, but probably you focused a bit too much on the design, which is fine. I mean, it's ultimately a very attractive object. It makes it probably saleable if you want to find investors. But I think the potential in this project is not in the design. It's really in those. In one main thing, which is the unfolding platform and the way those modules get together. Here, when I look at this image, I only see two options, like the one on the sea and the one on Earth, on ground. By the way, I really wonder why there is such a distinction. I don't really see the necessity of that. I think it's a bit of an arbitrary decision, according to me. And also, again, for example, this unfolding platform, we could perfectly imagine that it's not just for connection, it's not just for putting a table and a couple of chairs to have a drink, but it could be used as a surface for growing food, etc., etc. So, I mean, this would have really made your project much more convincing towards the idea of a completely autonomous life and a completely let's say, sustaining entity. So, but still, it's a very interesting project.
What I would add to this is you mentioned your motivation being amphibious. So the question I have here is, can we push more the idea of interface? We approach this a lot with the idea of shelter and actually how this can exist both on land and water, independent from its environment. However, I think you've tackled really well a lot of design questions on kinetics and motion. Then it's interesting to think about interface with the environment, with the land, with the water. You talk about cities that are going to get immersed. This is a very atypical water level, the ecosystem that will be created of these immersed ex-urban environments. So it's interesting to consider what the interface would be between the ecosystem that's going to be existing in these different environments. For example, the grid and the hexagon arrangement, you didn't justify it as such, but there are opportunities of how do you actually navigate between these modules, and actually on land you could take advantage of spaces in between and green space, and what does that create for community. You mentioned the food harvesting as sort of a umbrella for resource management, yet there are very specific opportunities in terms of how do you generate clean water when you're drinking water when you're at sea, and for how long. And then the interface has another aspect to it, is the interface of the habit, the humans within this. So You tackled a lot of space as a design challenge. It may be an interesting question to start considering a lot of the materiality of these spaces, very smooth. Yeah, considerations of friction, being at different gradients. How do you navigate when actually there's the motion and actually dealing with constant motion within these spaces? And so there's this overall an idea of interface when you think about Amphibious, even more than shelter, I would say.
Thank you very much to all the comments. Very spot on, and I think you know, it's they kind of give somehow like topics to think about for the future if you want to kind of develop further this idea. I have to say it's a great way to start the 2 days of juries. I really love your project. You have been really proactive in responding into a brief that was kind of exploratory, and I have to say also like it's building up very nicely on history, on a very long-standing history of the way like nomadic life and the way temporality has been used to inhabit, for instance, the Thames waterways or canals. So it's actually something that is not new, as you mentioned, and it's something that deals with soft infrastructuring instead of hard infrastructuring, as you mentioned as well, which I think is very, very strong as an idea for as a complementary way to approach urbanism. I like very much the way you approach the idea of transformation and adaptability. I agree with Philippe as well on the fact that the key element, the key player is actually your fins, multifunctional fins. What I like about it is the fact that there is some technicality embedded in it, which you know, helps you to deal with mobility, with energy harnessing, but it's also like an architectural device, and that's very important. And the fact that it can transform and adapt to different architectural interfacing conditions with other units, or simply like architectural devices, they, you know, differentiating from land to water and having this sort of really multipotent capability. I think that's quite strong in my opinion. Also the idea of working with, let's say, mass production, and going back to the idea of luxury. I mean, nowadays any product is luxury, you know. So we need to think about a future where, you know, 10 billions of people will have to share what is the resource available on this planet. So any product will be actually potentially not available for everybody. You know? So we need to think about that too. But it's important to understand that you know, if we can mass produce certain things, if we can simplify the construction methods as a counterpart to what is happening right now, for instance, in architecture, where everything is somehow like a one-off design, I think that could be an interesting complementary approach to what we do as architects. So, but in general, thank you very much. I really commend you for a big effort, and also like to really trying to address you know, many aspects on the project which are not easy to address in an year. Okay, so thank you.
Okay, as we're going to move on, I'm just going to suggest two things to keep in mind. We have a colleague, David Green, that would say the future is a very 60s thing. So I would basically suggest that the future is now. And if you believe in that, and I really do think that everybody needs to kind of wear this and sort of feel the burden of it. There are many challenges out there. And I think one benefit for working prototypically is that your work potentially can be deployed in different ways for different communities. And I think that that's the power of research and design research and the limit of design. Design research gives that potential, and that potential is burdened with use cases and scenarios that have to be deployed, and you have a career ahead of you that you may want to entertain those things. And I think you should rise up to those challenges because they're very real and they're very of the day. So I think like there's a lot to be commended. I think there's a lot to be challenged. I just want to challenge the word future because I think, to be honest with you, at the end of the day, I don't want to think about a future. I want to see it now. I think we all do. And I think the questions, for example, that Kostas asked you, for who and for what, Those are things that are part of the responsibility of thinking about design and how it can really contribute meaningfully. And I'm saying that because, yes, I may agree with Pierre that we have limited resources. That's a constraint that wasn't put on the table in the presentation. It could be. It could be your preoccupation for the next 50 years, and to think about the experiment the way that Buckminster Fuller would. An experiment is not a one-off. An experiment is going to be your future in terms of the things that you choose to do. But the work is really timely, and I think it's something to be considered. It's a conversation that's going to evolve over the 2 days, and I'm sure the conversation will as well. So with that, thank you very much. It's a good start to the day. We're going to try to kind of do the dress rehearsal with the next project, kind of this comes down, models go away, new panels on the wall, models on the table, and we're going to do that about 18 times. So with that, thanks.
Thank you so much.
Hello everyone, we are Team Sentient Rock. I'm Leo.
I'm Diksha.
I'm Zuigu.
I'm Warner. The thematic for this year's studio is elemental. We have projects involving a wide range of materiality from sand to cellulose to seaweed and salt. This year, it is all about exploring what it would mean to us and our surroundings if we thought of nature as technology which shouldn't be dealt with but rather collaborated with.
According to our statistics, the current area of the desert accounts for about 21% of the total land area of the world. There are rich natural resources like solar energy, wind energy, oil, and other mineral resources. At the same time, the desert is also full of dangers, huge temperature difference in the day and night, land shortage of water and drought, strong wind, sandstorm, and so on. But there will still be humans in the desert, local people, tourists, and researchers. So we need to create a shelter for them. This is context of our project about
Yes. The microphone doesn't need so much attention. Leave the microphone and just talk.
Sorry.
No, that's perfect. But don't be nervous. Everybody's a friend here.
Thank you. This is the context of our project about 4 parts. Yeah. And there are some typical examples of space created by inflatable materials. Soft materials create a sense of volume. The collection of the flexible materials and hard stone walls brings the possibility to deck growth. The different wind directions and the strengths create different types of sand pile. And this also the interface for controlling the streamline scan. Based on these 2 factors, it provides the base for the distribution and adjustment of our agent system. In order to use this technology, we also do some research about it, and we work on the sand solidified strategy to create space. We test 3 methods to solidify the sand. Glue mixed with water have the property of liquid and allow the solidified depths become bigger, and the water gradually dissolves the solidified sand. Also, the determination of the time of appearance and the dissolution of building sediments according to the seasonal precipitation of the site. During experiment, the distribution of the simulated agent of the robot inflatable material was used to simulate the process of being covered by realistic sand dune. Next, please. And in the process of we got the model of the physical experiments. And also there are some simulation about different state of inflatable film in the desert. There are some physical models of agent cluster before inflation, after inflation, and some detail of physical models. Thank you. They are the results of previous study and the spatial form that we can be generated. We will use agent to implement this construction strategy.
Yeah, so for our project, we think our agent should create the voids and should solidify the sand, and except that our agent should collect the water from the air in the desert. And after trying to add other ways to move on the desert, we think using created voids to draw overs is the best way for us.
Since we wanted to use air as formwork, we decided to design an inflatable pod unit. The design of the pod unit began with material research. We tested latex composites by embedding both stretchable and non-stretchable textile. We also tested silicone embedded with thread and fabric patterns as reinforcement and as a way to control the percentage and direction of stretch. The material we finally chose is a composite called polyester CSM, which is a similar composite made of polyester and fabric. This material has a high resistance to abrasion and heat and is also waterproof. We moved on to patterning research. Since the geometry most naturally associated with inflation is the sphere, the thought process for this part of the research began by assuming the sphere as a unit of space. We began by exploring many different ways that a sphere can be divided. We have two main approaches, namely ridged patterning and panel patterning. Ridged patterning is especially suited to the context of this project, as it means that the ridges would allow the sand to settle in between them and allow for a better shell structure. Furthermore, for the sake of efficient designing, it would be better to have a paneled approach to patterning as well, to ensure that the amount of disturbance or distortion is kept to a minimum whenever there are any changes at any point on the surface of the inflatable, either due to design changes or on-site modifications, or simply because of the ever-changing undulating surface qualities of the desert. The final design of the pod considers a hybrid approach by combining the strengths of both panel and ridge and creating a sort of panel ridge design. Delving further into some design details, the difference between, a little bit nervous. This is the final design where we kind of combine both the approaches of ridge and panel, and we kind of got a ridged panel. Delving further into some design details, the difference between a double-walled inflatable versus a single-layer inflatable with an outer constrained structure was observed, and the latter was chosen in order to obtain maximum usable space. Other details include an option for doors that allow cross-sectional circulation when other pods are not directly connected by the main doors, and also incorporation of bumps and scallops that perform similar functions as that of the ridges. Finally, iterations of window panels were explored to have control over light exposure whenever the units could be exposed to sunlight.
Based on the convenience of the obtain the sand and the air from the desert, so we just designed some tube spaces inside our agent. But for the solids and the waters, except that we added the storage space in our agent. And in this GIF, you can see from the center to the outside, this is the air pumped part and the sand spirit diverse and the water storage space, solid storage space, and our support structures and the electromagnetic. After that, the last is the displays of the openings, the sand spirit device. So here we show the locations of the solar panels, batteries, and our collecting water panels. And a big part of our clusters is the agent which can just create the void. It can be lived after buildings. It can be lived in space to be the door or windows. Of course, it can carry the thought toward the builder. And for the collecting the waters, after referencing some of the case, we find this using the changes of temperatures will be better. So we find good materials named the VIPS. His physical parameter will effective the whole process. So this is the process of we opens the collecting the water panels. And the last picture, last GIF is showing the way designs ribbons to turn off and to turn on it. And also, our agents can inflatables in different surface. We need to control it, and it can be decided by its neighborhood. This is our 11 different kinds of models. Next, yes, and. We can find that in the cells of the graders there is the 4 different situations. The one is the empty, the second one is the cube, the third one is the void, and the first one is the cubes with the voids on it. And we showed parts of the simulation results, and inside this there is the big 3 kinds of create some classical building space, and. We want to prepare a better environment for life in the space, so we choose the temperatures be our start point because the temperatures can take the changes of the air pressure. Air pressure can take the waters connected in air changes, and after the simulations we find this increases the numbers of the empties and reduce the volumes of empties will be better for us. Next, and this is because we think about this, the sand will move, and the sand also will bury our spaces one day. So the first thing we created the higher samples of our space to be the big doll, and the second GIF shows when the cube creates big builders, how they move on the desert. And the third one we showed us how they live from the space, because the solidified sand on them will stop them to continuous roll over. So they will inflatable the bottom surface, and then will provide the enough space for rollovers for the next builder's plan. Okay.
Please. This is a sand burying agent process. In the first step, the robot pumps the first layer of sand around the agent. After the sand accumulates here, the robot starts spraying the salt water. Afterward, the sand solidifies and becomes hard. When the first layer of sand is fully solidified, the second layer of sand starts spraying, and the process is repeated to solidify the whole sand dune layer by layer. This is the special form that our agent can create, and then we bring these agents to the specific site.
After we get the agency of this kind of strategy, we start to interpolate this system in collective level. Basically, we have like a 5 stage. First, we start from single agent behavior to collective behavior to make sure the connectivity of the space agent, which we control the agent sensor area and the inflates area. In this case, we choose different configuration of the agent. See how its column expansion takes the space. After this stage, we start to embed the landscape data to make the agent response to the environment. So in this slide, they take the information from the landscape and response to the landscape slope and wind direction to build up the stud colonies. And this is the behavior when they start to nomadic from one point to another point. After this stage, we start to interpolate the aggregation when they find the location. So based on the aggregation, we need to make sure the connectivity of the agent, so we have certain different density of the plane connectivity rule set for them to circulate. Here you can see there are three basic behavior to control the expansion and the stable iterate aggregation state. Then we start to using this kind of system in three different scenarios to create some possibility. And there is a catalog of this kind of agent behavior response to the environment. So the environment response behavior give us the system's ability to adapt to the landscape. Then we start to thinking about how the system adapt to human. So in this perspective, since the scenario at small scale nomadic space provide for human and animals to iterate the system to adaptive to different use case, we define density as a criteria for aggregation simulation. High density public space and the low density represent the private space. And there are few different density for the system to iterate to get 4 types of prototypic system. After this stage, we start to interpolate our inflation system on site. Based on the circulation we get just by change the different surface inflate, we can take the multiple results of the system. So, the autonomy of the system is hundreds of the options by same data from the environment, but we can get hundreds of results. To choose the specific result from the hundreds of results, we start to look back, and in this case we choose the 30% public space, which is high density space for them to iterate. And this is the result. The totally target area is like here is 115, and they iterate to results like this, which can provide a prototypic system like a space like a research lab. This is a station, a stage where the agent come to the on-site of the landscape. Then we start to try to interpolate multiple simulation result of the inflation. Then we get like 3 types of inflation level for us to choose the option. Then it comes to agent. They spread the sand and solidify the material to form the space, and then we from here we control like the covered area and the entrance to take 6 iterations. After that, we start to analyze the space inside. Here is the cross section sequence of the space we create. Here we get the plan of the agent. After this stage, we also need to leave the agent inside the colony to remain an autonomy system like this. Thanks.
Thank you.
Yes.
grab one of the microphones if there's something you want to explain about the models, and we'll open it up for conversation, okay? Guys, one of you, if you would like, you can take the microphone if it's necessary. If it's not, don't worry about it. There's a microphone next to Philippe.
Those four cross-section of the model shows the scale and how it's combined with the landscape and finally become a part of the landscape. And those small agents are the builder to create the space.
Do these four stack together again then?
Yeah, they are connected, and then we split it to show the space in the landscape. And the landscape will change with the environment, so our building are sometimes like covered by the landscape, sometimes disappear, sometimes like show up in the environment.
If I can maybe start by asking a question. You probably mentioned this in the beginning, but I didn't catch it. So this would be in a specific desert somewhere, or it's just kind of more of an open hypothetical desert condition? And who would live there? Who would this be for?
For this page, they lived in desert, and the scenario is all desert because we're using on-site material, which is sand, which we're using the property of the sand, which can combine by the salt, which is the binding method we use to create this kind of solid space in desert.
But the spaces that you're designing, are they for somebody, a group of people in specific, or a community?
Yes, because in the beginnings we showed us every year so many people died in the desert, and the desert becomes more and more big, so left the space suitable for life become less and less. So we want to create a new landscapes in the desert, and in the space the environment will be more suitable for the life. So maybe the spaces will help us the travelers in the desert, or some the little or some other the sensor who go to the desert to do some of the research. Our space can help them.
So I think, first of all, thank you very much for the presentation. There are some very nice moments in the project, I think, and you seem to have very good control over how these inflatable modules aggregate, and all of these different moves that you do to create space, I think, are well communicated and well kind of illustrated as well. There is one or two main things in the project that I think would have really helped you to ground this a bit more. And these have to do with how do you actually put criteria in order to evaluate what it is that you're doing. The fundamental thing would be the material part, which I think is missing in the project. Because right now you're basing everything on this idea that these would inflate, you would put sand on them, then you would deflate, and then you would have space. But of course, to do this with sand is impossible because it doesn't have any structural integrity whatsoever. So what you would need to do is you would need to, even actually if you try to use concrete to, there are these, you might have come across, I think they're called Bini shells of this Italian engineer who used to create inflatables, put concrete around, deflate it, and you would have these spheres of concrete that would be inhabitable and all of that. So even if you put concrete on top of this, I think you would still need to reinforce it and be very specific about the consistency of the concrete and like how does that combine with the spans that you have, because the larger the span, the bigger the depth and all of that. So let alone to do this with sand. So I think, one piece of criteria that you would actually apply in the project would be after you do all of this deployment of the inflatables to try to analyze it and achieve a purely compressive structure. So you can actually start to think about, using sand with a binder to create like a cover over it. Because otherwise, I think, it's like the moment that you have any type of tension there whatsoever, then this would just not kind of support itself. So to me, there's this material investigation that is missing, and also kind of scaling this up as well, and trying to do almost like a proof of concept, basically on a large scale, to show what you would have to put actually specifically in the sand to make this work structurally. Then the other thing, number 2, would be just like the basic criteria of light. So because right now you're putting all of these aggregations there that create all of these complex spaces. But the limitation always when building underground in these types of scenarios is how much light goes into the spaces. So if you had these 2 things, I think it would just ground the project much more and make it a bit more believable. But other than that, again, I think there are moments to it that are quite compelling as designs and processes.
I want to congratulate you for this project. I very much enjoy it, let's say. I think it's very smart. The general idea is very interesting. But yes, I have also a couple of questions. Let's say maybe you won't answer those questions right now, but it's not a problem. I believe that first, I slightly disagree with Kostas regarding the structural capabilities of sand. If you mix it, and this is what the student said, if you mix it with salt, and then you can have this complex compound, then it can become extremely strong, mechanically speaking. It can even have some interesting properties in tension. Probably, good enough for the validity of the project. So I don't think we need concrete or any other things here. You probably have went to some beaches where you have pure sand, shores, or and then you see how strong is that. It becomes like concrete. But the problem at some point is the temporality of the project. It can become almost as strong as concrete, just sand and salt, but it takes time. And the problem here in your project is that you don't really speak the temporality. About the temporality, we don't know how long it takes, because it's nice to have this, but if you need to wait 50 years or maybe a couple of hundreds of years underground, so that the structure gets strong enough, then the whole idea of this project, which is also very much based on some nomadic lifestyle, is a bit, is killed. You see what I mean? So I think here, this is the first problem. The second one, it's a more technical problem. It's not, probably it's an easy thing to solve, is that when you inflate and deflate your module so that it can roll to make it move, basically, at a very small scale, and this exists also already in soft robotics scenarios and all of that, it works well. But here, if you want to inflate and deflate an extremely big volume of, a big balloon with an extremely big volume of air, you would need absolutely crazy pump just to deflating is fine, but inflating, you cannot just take the air of one, putting it in the other, because you need to bring extra energy for that, you know, because otherwise the resistance is the same in both. I mean, in all the balloons, and if you don't bring quite a lot of extra energy, I think, technically speaking, it cannot work. So the scalability of your project here and the moving system, which is based on these rolling modules, I would say at the very moment I don't believe this is a fully solved issue. But for the rest, I think the project is extremely interesting.
Yeah, I agree with Philippe there. On my mind here, I'm thinking always about time. It's the big issue. Or the gestation period to install something like this. But then I've got other things on my mind, like why on earth would anybody want to go there in the first place, you know, given the conditions of the desert. So it's really an engineering issue. I think this is a structural engineering project. There's not really any design. And there's a moment where you question whether there's any benefit to using the sand at all, because you're also deploying structures which, in their right condition, would do that job anyway, in a sense. So that relates to time. So I'm a little confused with this program. I want to enjoy it and like it, but well, Theo obviously described what it could be used for, and I like the idea of some maybe temporal archaeological space, or, you know, research orientated, which obviously has links to, you know, what we're trying to do by going to, you know, the planets and so on. So there is a relationship there, but if you want to make it work, it's really a materials science, physics, engineering issue. And it's a lot of effort for something which might not be sustainable. I don't know. That's just my instinctive feeling. Although the imagery and the physicality is very, very interesting for me.
So it's complicated. It's complicated, and I'd like to like it. I just don't quite understand the success conditions of space construction. So here is a mechanism for creating space. Yes, it takes time. They don't make fully formed shells all the time and so on, and there'd be quite a cost structure connected to that. But when you get these vacant spaces, how fit is it with respect to infrastructural needs for sewage or for other requirements that people have, bringing in water and things? So I'm not criticizing, I just think it's partial because when you begin to look at how it would be used, then you say, well, is this a good method for a use like that? So you need a lot of use cases to make it compelling, I think, because that ties it to a cost structure and all the things that come. So I'm thinking about infrastructure, which is also what I was thinking about the previous project afterward, about infrastructure, the needs of diversity and all that come into aggregates.
I have a question.
Yes.
Why is it called sentient rock?
Well, well, we began by thinking of collaborating with nature, and we wanted it to have a life of its own, which is what we strived for in the project. And we tried our best to give it the ephemeral quality, and I guess to an extent we have succeeded, but yeah. The aim was to give it its own life and autonomy, so yeah.
Yeah, I want to say some things about why we name our project this. because we created a space. It can do some things for the environment outside the space. You know, desert is very bad for the life. So we start from the temperature, and we want to use the temperature to take small water connectors in the air, in the space, because we think the temperature, because we have the space, so the space can make the temperature lower, and the low temperature will create the low air pressure. The low air pressure and the high pressure can create the wind. So if we have the wind in the space, the water connectors in the air will change. So we think if we do some things for this kind of the environmental element, it will be nice for the life, and it will do some things for the bad temperature or something.
I find myself wondering if those are maybe definitions of autonomous design or autonomous response and responsive environment and responsiveness to ephemeral conditions more than sentience. With that in mind, how would you just define the word sentient? What does that mean? You've talked about how the environment might respond, but when I think of something being a sentient being or a conscious being, which is a different thing, right? Noting those are two different things. I don't know that I typically define sentient as responsive and autonomous. I tend to think of it as something next level that knows of its own existence. So with that in mind, I'm going to throw it back at you and ask you very quickly, one of you, maybe one of you who hasn't answered the question yet, how do you define sentient now through the lens of this project?
You mean how to sentence what our scientists for the environment?
Can you repeat that?
Sorry. I mean, what you're asking is how we want to do to finish the sightings for...
No,
yes?
I'm asking you to define the word sentient, because your project is called Sentient Rock. And
yes.
So I am wondering what this project means in its name, because it is not a rock, it is sand that you've created. And you might be saying that this is rock. And you're using the word sentient, which is a pretty loaded term. Yeah,
because in the beginnings, we think the desert is not solidified because the sand, they are moving, and the sand dunes, they are moving. So they are not solidified things. So we want to solidify them, and they will become something like the rock. So we think we can call we can call what we have done is a rock, and the space is in the rock. So this is what we think, and why we call it the scientist, because we think the rocks can reflect to the changes of the environment. This is why we call this name.
I might argue that that's more responsive than sentient, but it's something to consider moving forward, and as we thread a needle of a conversation that'll go over 2 days, maybe that's something that we can keep up in our conversations about intelligence and environment and elementality.
I'm really enjoying the conversation about temporality, and also it's an engineering project, but for me it's really exciting to see the chemical engineering possibilities, and I'm lucky enough to work in some projects where the chemical engineers walk into the room and suddenly things change, right? This thing we're sort of working on desalination issues and solid state mining and these sorts of things. So I think there's sort of potential to really keep exploring that field of chemistry in design as we move forward. But I think for me the big challenge here is just the communication one. I mean, I think you're wrestling with control here, but we sort of got this aspiration to be ephemeral, but we sort of get these models here in the middle, and a lot of these things that are very sort of solid and permanent. And the most compelling piece is down the end of the table for me, this sort of dunes that are carved out. And I'd really like to see, rather than a single state of this, what does it look like month by month over, over a duration of time, and really sort of explore that temporality much more explicitly.
I think to add to that, I think the most interesting part of this project, to me at least, is the notion of a closed-loop system, where the building material and its abundance of sand, the builder and the structure, the architecture, are an evolving system. And to think about that over time, you've done some really nice studies about the different modes of operation of the agents, how they respond to the landscape. What is interesting is to actually take this in a longer time frame and actually consider that within that system, how does the overall, what is the role of the builder as the landscape evolves, and what could be the possibilities and opportunities of impact in quite a large scale on the landscape across time, in this ability to constantly continue to build, to erode, to evolve, and to keep building. So I think it'd be interesting to stretch it out and to really push what could be the extreme of these systems which can keep on building.
I might just pick up on that point. It's a fantastic one, and I think that the ephemerality of the desert is an extraordinary opportunity, and it also has a kind of a placelessness which enables you to, I suppose, speculate within a context that might not be entirely real. And I think that's important probably for all the projects. What is the context for your problem? In the previous project, tackled something highly specific, and in some ways, it attempted to resolve all aspects of a problem. I think in your case, it's more about a speculation about the possibility of a material that then you would want to be very precise about what you're trying to answer. Because I think some of the questions having to do with the nature of the community or the solidity of the material, you're sitting somewhere in between. And I think the possibility of examining this project over time, what becomes like rock, what becomes eroded, to what extent, because you're responding to a topographical condition, you're responding to a climatic condition in terms of orientation and exposure and wind speeds and wind direction, there's a possibility for you to construct something and then to allow this new topography to create its own condition over time. And therefore, I think it's worth examining, first of all, what this is over the course of a year and then what it is over the course of 100 years. But then in order to do so, I think there was a little moment in your presentation where you talked about the seams that you'd examined and the possibility of those seams creating, I suppose, rib-like structures. And I think that needs description. Because we get these extraordinary ideas of a space, but actually the precision through which you begin to examine the interiority that has been created by the condition that you've produced is slightly random. And I think actually you want to be much more controlled about that so that when erosion, topographic change, the evolution over kind of 100 years occurs, there's a differentiation between what you controlled and what is controlled by the environment around you. And then it can become really a thesis about the exploration of the relationship between sand and salt, rather than kind of, I suppose, burdening you with the responsibility of creating a community in the desert. Because that might not be the answer that you're trying to provide. But I think just be very careful about what it is you're trying to respond to. And I think really enjoy the mysteriousness of this extraordinary kind of desert condition.
Thank you.
I mean, I think that this point is important, but I also think that everything that's been said, I think, is well-meaning in a sense. The things that I would challenge is kind of two forms of language, since it's been brought up. One is the notion of style, like lifestyle, and one is the notion of purpose, in terms of like how we situate design research and how that somehow migrates into kind of plausible scenarios. Because I think the issue that was set up from the studio's perspective was to challenge the students thinking about things not as engineering but as elemental, trying to understand the intelligence of also this abundance of resources that at the moment is not necessarily being utilized, and trying to extract, let's say, the intelligence of nature in a way to somehow problematize not space making like for human inhabitation, but really to sort of extract those as kind of prototypical conditions. So, for example, this is a hostile environment, and we may say why people go there. This isn't about trying to create some new form of tourism. It is in some way, though, to build on a kind of language. Let's, for example, termites build these extravagant kind of systems. They do have infrastructural implications, but they are environmental. How do they extract the air to basically create the moisture, to break down the things? And it is also a model that's slightly different, which is not really being talked about in terms of how you guys are organizing your cellular and your resolution space, which I think is a missed opportunity to talk about how those things actually are really extracting resources around us. And to be honest with you, how it's used is really premised with what can it do, how it can do it. The time frame and ephemerality is an open question. It doesn't have a very specific thing. If there's a little bit of humidity, then this thing falls apart, right? That's the critical agent in some sense. Well, that's also the balance of how it's formed. So I think the sensitivity to how you exhibit control is not in its formation explicitly, it's in its process of forming. And that's the difference between a project being limited in a certain way in these moments of time, and you guys somehow really speaking to the complexity of the problem, which I think you can do more directly. I would also encourage the students not to sit there reading and to speak about the challenges that you've had. There have been questions about its materiality. You guys have tested certain things. There's been a lot of failure. But I also think that that's very important to somehow put on the table because, for example, the use of your material is to generate friction. You know, the difference between your balloons and keeping these sand particles on a surface for misting criteria is super critical. But the animation that you show is kind of like, literally like the dumping of particles, like we're burying something, like Robert Smithson. And I think the sensitivity to that detail is very important, especially if you're trying to move in a direction where you're trying to challenge things. There's a lot of projects talking about life on Mars. At the end of the day, to be honest with you, I'm not sure that that's a really interesting problem, or to create a shell on Mars, but there are strategies of terraforming, there are strategies of living. There are a lot of things that could be, so I think this idea of speculating on potential, but based on actually the way that you index your own work, I think is super important. It's the difference between science fiction and fact. We have to somehow really operate quite closely to the things that you guys are doing. And I think a lot of the material experiments that aren't here and weren't part of the presentation are doing a disservice to this, because I think those are the challenges that I think can open up questions that potentially, for example, Costa says, doesn't work. Your job is to tell him, you know what, you're wrong. And these are historically what Fray Otto did, and this is what other people did. And I'm saying this with a lot of love and affection for Costas, but I'm just saying it's not a black and white subject, and I think that that's the complexity that we want to discuss with an amazing group of critics who I think have given you a lot of things to think about. Philippe, I'm going to let you do the closing conversation, which is never closing anything.
Okay.
But,
Yeah,
and then we'll move on if that's okay.
No, you know, when I look at the BR headquarters by the architect in Sharjah, which is a building which personally I really love. I mean, I really believe it's one of the best. I mean, this project gives a solution to it in a sense. I mean, you can do it, you can put some balloons in the desert, and if you wait long enough, then you can get it for free almost. You know, I mean, I don't know how much this project costs, but for sure it's going to be much more economical, so much cheaper. But saying this, I mean, there's two competing ideas in this project, one of ephemerality and one on the geological scale. And I believe that this project only makes sense at the geological scale, in a sense. And this is why you should probably have focused on that, looked at cave dwellings examples. I mean, it's a bit weird. I don't see any reference regarding cave dwellings or troglodytic construction. While there are so many that are super interesting, there's no real investigation into the chemical nature of the soil where these cave dwellings do exist, etc., etc. So I think the project has an amazing potential, including on a purely architectural and tectonic level. But it competes with another idea, which is the one of these moving modules, almost like soft robots. And I think this second idea is not that relevant in this context. So you should have made let's say, a much more radical choice.
I mean, it's an unusual project because it's so just pure tectonic formation systems. It doesn't have much use case speculation, but I still subscribe to this. We've been starting form to program, system to program, and that's the next stage. But I have a lot of sympathy for the project and this beautiful interplay of these inflatables engaging, clustering, and the sand. We don't know yet how it comes in, whether this is going into sandstorms and they blow against it would be one type of formation, whether it's kind of drone sprinkling alternating with sand, or here where you've poured. You can also imagine a crane coming and pouring points, which then generates these intersecting cones. And there's different morphologies. Here you did a kind of cloth onto these undulating bubbles. And I don't know how sand would do that, maybe if it's in these kind of layers. But I think there hasn't been enough, and I give Costa right, of explicit sets of constraints which drive the system information and how they relate to different techniques of forming the sand. And I have the one thing intuitively, so I love the whole idea, and that you have the topography and the way these bubbles kind of aggregate their relative to this. You have density and less density. You have very, very basic first initiation, larger public shells versus more granular private spaces. But my main problem with this is that object you spend a lot of time with, that frame with the bubbles coming out of the sides. And somehow I feel if these bubbles were more by themselves, they were also more plastic. If you have a large bubble rolling, they aggregate and push. Maybe they have an object inside which climbs around and rolls over. So I feel there should be more animate, soft, and also then different sizes. So there's something about the over-mechanical and over-elaborate piece which somehow I revolted. Not that it's necessarily wrong when you build we have all these trucks and cranes, but still, in terms of the spirit of the project, this elemental, maybe these bubbles should be another, and air, it should be another sort of set of elemental, semi-self-actuating, but also a lot of passive material computation aspects, and then the sand rolling over, coming in, or being sprayed over. Anyway, I still love the project. I mean, there are certain things missing. It's not the ticking all the boxes, but in terms of a vision, we always loved it, and so I'm sure they will have another iteration with that.
Just one thing that might help you, because I think you've got the wrong key. And that wrong key is this focus on the salt and the sand. There's a second key, which is you're doing this in a relatively low-tech way. Forget it. Go super high-tech. Like it's a project for a major energy company. And they're drilling for oil, okay? And they put these vast solar arrays out there because there's so much energy out in the desert. And then you fuse the sand into glass. Why don't you just do that? Then you've kind of taken it wherever you want to go. I mean, it's too low-tech because you're sucked into sort of what we consider this geological low-tech environment, that it needs a blast of incredible, technology. That's what I think. Sorry.
I love the conversation, and this is what kind of unfolds over the 2 days, which is why all of these guests are here with us. I'm going to say, Ross, that the thought is phenomena is technology. So if that's high-tech or low-tech, it remains to be seen at this stage. We do have some glass in the future.
So can I say one thing?
Yes.
Well, two words. The erosion and sand shifting. So if you're left with partially enclosed bubbles, they won't last very long before the sand decides to reclaim them. And if you build something that isn't glass, it's going to erode quite quickly, as will glass. The conditions of the desert itself must be quite ferocious. So it's moving all the time and it's ripping things apart. It's a tough place, but fun for that.
Okay.
You're talking about water, aren't you? It's a liquid, so you just made it all float. Yeah, absolutely. There we go.
Yes, just not because I don't enjoy this or everybody doesn't enjoy this. It's just for, seeing the rest of the nine teams that we have today. Anyway, thank you guys. Can we try to make a quick changeover? Thank you so much.
Hi everyone, we are team SimCity from Bushan Studio, and I'm Liu Chenfan. This is Sihui Li, Pei Wenwu, Dima, and Yangfan Li. We're gonna start. Today we present here a transit-oriented development urban strategy to densify London. Central London, as a major financial and cultural center, works as a daily commuting destination for people living in the Greater London area. More than 3 million Londoners use public transport to commute in the capital every day. Londoners have the longest commute time in the UK, with the average journey to work being 1 hour and 21 minutes. And that's because of the overwhelming house price and the lack of housing in central London. But London is actually polycentric and being well connected by public transportation system. So here we propose a transit-oriented urban network to develop London. Currently, there's only 10% rail track related land was put into use. We believe that the opportunity of rail overbuilt as a construction method. Building above the rail tracks doesn't need new lands, which could reduce the shortage of land use in central London. Cases are already appearing in London, like London Bridge Station and newly released Euston Plan. They both have a hybrid program to make a massive hub supporting daily needs for both locals and commuters. To build an urban network, we started with looking for stations that are not fully developed yet, but have the potential to be a massive hub. Our prototype site is Vauxhall Station, which has more than 30 million entries and exits annually, and it also contains different interchange modes. But the current status of the station is single-functioned, so we introduced spatial tech to offer customizable modules and fabrication technologies for people to design and construct a mixed-use transport hub they need. And while the urban planning system was complex and take a long time to process, we introduced a governance technology to build consensus and a game platform for users to negotiate for complex problem. Our proposal, SimCity, aims to densify London station neighborhoods that can be designed with the participation of local users through both virtual and physical computer-aided design technologies.
So when it comes to the GovTech, because Vauxhall is identified in the Mayor's London plan as an opportunity area with a potential for 18,500 new homes and also the same number for new jobs by 2041. However, due to Vauxhall size and also the height limit, we have designed 350 co-living modules and 295 co-working modules for 1,000 people living and 3,000 people working. And to achieve this, first we identified the modules we needed: co-living, co-working, and public. And after designing on the module type, we need to design how the modules are connected. We did not want the co-living and the co-working to be too closely connected on the same level, which would lead the disruption of the function on the spatial space of the building. So we set the co-living and the co-working to be directly connected only on the upper and lower levels, and to rely on the public modules to connect them on the same level. And after we completing the registration as well as the character selection process, the player will enter the phase 1 of the game, selecting the plot. We have 3 different plots, each requiring a different number of the modules in different proportions, and the game ends when the target number of the modules in the plot is reached. And players can choose the different plots according to the preference. And once the players in the plot, the players can select the different geometries and penetrate them. When the players place the module, the system will display the price and of the site and the profit to help players make a judgment. Or they can switch modes to see the exact land value and the profit. Once the player has chosen a site, they will automatically enter the bidding system, and the highest bidder will win the site and also the rights to place the module at the second price. And we mentioned before the land value and the profit. The factors that have an impact on the base price of the land value and the profit on our side are, firstly, the different levels of the transport system, including the distance of the grid from the underground entrance and also the distance from the plot's circulation core. The second is the size of the grid, and the third is the noise level. The louder noise, the lower price. And finally, the accessibility of the grid to the podium. And what's more, the number of the public modules around the grid and the distance to the public modules will also have an ongoing effect on the land value of the site. And at the same time, type of the modules and numbers also have an ongoing impact on the profit. As each module has 6 sites that can be connected to each module, the rule is that the groups of the same type with the public space have the highest profit, and the groups with the mix of the co-living and the co-working have the lowest price profit. So the order of the profit will the profit will be as shown in this diagram. So that means the land value and the profit is changeable based on the player's actions. And what's more, during the game, the players can view the owners of the surrounding venues and the bids also. And when the target of the plot is reached, the game will end automatically, and based on the game result, the facade will generate correspondingly.
We have designed a highly participatory, multi-person, collaborative online platform for end users to purchase, vote, and exchange resources. When entering the platform, the user first selects the preferred user mode, which corresponds to the 3 types of geometry that they can place: co-working, co-living, and public. Afterwards, the user enters the block selection interface and clicks on the blocks to see its size and average voxel bidding price. After selecting the block to join, users can see how the area looked like at that moment when it was generated by other users. When multiple users have selected the same block within 48 hours, the block can enter the bidding level. The users will enter the price to bid. After selecting the plot sets, the user can select the number of floors they want to build. For one floor, the user can choose to replace the voxels with a height of 1. Users can click the yellow cube and select their preferred geometry matching the selecting sets. And for 4 floors, the users can choose a larger structure and a voxel depending on their functional requirements. The highest single structure is 22224 in size. Before confirming the purchase, the player can select and bid any voxel in orange grid that can be purchased and replace it with the geometry of their choice. Each ground level grid has a different floor limit. When the current plot floor limit is reached, the user can bid the roof structure on the uppermost level. Rooftop structures can be selected and purchased in a similar way to the structure selection. The user can customize the furniture on the voxel structure already selected. Choose where you want to place the furniture on the final grid. It is also possible to replace the format of the furniture. Sometimes the system will suggest to the user a more extensive but more affordable furniture pattern. Click Yes to accept system assistance advice. After the above process, users can become citizens and also enable resource exchanging with other users. When working through the scene as a virtual person, passing the commercial and public streets, the user can reach the virtual lobby and get information about the various events taking place through the display boards in the middle of the lobby. Users can organize events by accumulating a certain number of tickets, or they can buy tickets to participate in events that are taking place, such as this dancing event on the rooftop stage. Users can expand their ownerships and reduce their rent by merging with another voxel. Both parties in merging voxels will see the corresponding information and a preview of the merged result before it is confirmed. Click on the exclamation mark to confirm the intention to merge. Voxels that are already owned can be released to rent by owners by bidding time for exchanging tokens. In the case of lecture hall, for example, the owners of the voxel is presenting the information and use the voxel at the ongoing bidding event. Similarly to grid, users can enter a bid to a price to win the voxel.
Here's our spatial tech to support the platform. Let's start with the overall site. The site was cut by several roads, and there's arched structure underneath, which bring the rail tracks to 10 meters higher than the street level. So we introduced a podium to build on top of the rail tracks according to the gameplay-based grid. It connects the street, pedestrian, and the housing that are going to be built above, and activate the podium with landscape on the interface and commercial level beneath. Here's the possible activity scenarios on the podium. The podium needs a mixed material structure system. System option 1 is made of concrete base and timber. The large span concrete base works as a transformation level, which could transfer the load from the timber structure built above. And the timber structure is made of customizable modules and is able to fit into the same grid with the concrete base. In this way, we are able to change the concrete space into a mass concrete space into a more livable timber structure-based scale.
And this is the second option of our grade. As you can see, there are many bus stop and tube station around the railway station where people come from all sides and convert on a station, and people from the other side of the river also convert near the site. So we want to increase the accessibility of the site and close the gap between the two sides of the track. And we add hexagon element to make it easy to connect the neighboring blocks and to create a street or a miniature city. Rotated the grid, 45-degree is also a way to enrich the street experience. And in response to the hexagon element, we have made some related geometry. And the first is the bottom structure made by steel and second is the station. People descend from the street to the platform by this structure. And the third is the hexagon ramp, where people can go from the ground to the street on the track through this geometry, and it also have potential to meet variety situation.
We used a total of 3 methods for fabrication. Firstly, we used mass timber as a main load-bearing structure, then wood bending for interior customization, and wood twisting is in between for both light structure and interiors.
So the timber modules are based on 6 by 6 meter voxels, which is defined by the material property of wood. We've developed customizable structure modules to offer different types of combination to form a volume variation.
Based on our proposal, we generated 4 different sizes of our timber structure to suit our co-living, co-working, and public modules. We used 4 columns as a basic structure, and as area grew, we reinforced the whole structure by thickening the columns and increasing the number of columns, and use bent wood as beams. For the co-living and co-working modules, we mainly choose the small modules, which the size is 6 by 6 by 5.4 meters. At the same time, we have predicted a number of possible connections based on the number of different modules chosen by the users and their placement. And here are the columns forms of the lobby and some of the public space. And we have also combined the different combination as a user selectable module. And we also add variations in the connections that occur when large and small spaces are combined. We use 2 main ways to connect the posts and beams. We're using bent wood for reinforcement. Left one is the process of assembling the support columns, and on the right is the details of the view of connection between columns. And here is our physical model in 1 by 20 scale.
We also have the interior assets we provide as for co-living, co-working, and communal use. For co-living modules, we offer choices of different space arrangements for sharing or family use. And the co-working modules provide both private and collaborate working opportunity along with other working assets to support.
there are some interior models for lobby, and we want to use the wood bending fabrication method to achieve that goal, like what we did in Hook Park, like divide a whole shape into many pieces, and each pieces is made into 3 layers so that they can fit together nicely.
Depending on the twisting characteristics of the wood, we can flexibly change the direction and bending angle of the wood. On the right side is our experiment with twisting of wood cube sliced with 5 pieces. And here is one of our interior customization according to our experiment of wood twisting. Here shows the different structure grades, the connection of the timber structure to the window frame and the balcony, and the inclusion of interior customization made of bent wood and hexagon traffic staircase.
And we also have adaptive spatial modules to support the gameplay. This is a scenario during the gameplay. When 2 voxels meets together, they will automatically merge into a new configuration with similar program.
This is our roof structure, which is available in 2 genotypes. The large one is being 24 by 24 meters, and the small one is 12 by 12 meters. And they can be used individually or combined together as a phenotype. And they can be combined in 3 ways with different combination to meet the different needs, such as exhibition, stage, or cafe. And also 2 of the same size can be combined as well. The small one is usually used for prevalent, and the larger one is more suitable for multifunction space. And it can also be combined with more than 2 monomers. And this is the detailed view of one of the phenotypes.
So here, after the gameplay, this is one of the aggregation we have from gameplay, and the possible different spatial outcomes when we change the factors such as grid. Here's iteration 1, and the second. That's all. Thanks for your listening. Thank you. Sorry. Thank you. So here.
Here are our physical models. At the first, we only try to use wood bending as our fabrication, and we made some easily assembly pieces, so we can take out easily. But you can see it's not strong, so we optimized our fabrication with mass timber as a columns. It can be more stronger, and this is our dollhouse, and this is our interior customization. After that, we, based on our user acceptable choice, so we made a lot of combinations to connect different sides of the columns. Here are our genotypes. In the middle is our 4 genotypes, and on the bottom is some. Is some combinations, and on the top is our roof structure.
You guys did great. Maybe go up there and we can ask you guys questions if they need to, or we just start the conversation. It's okay?
Okay.
Or you want to continue?
Okay. And we tried some steam timber for the wood twisting. We only use the straight wood cube to make this formation. And you can see this is not too precise, so we can only use it as our interior customization.
Okay, thank you.
Thank you. Thank you for the presentation. Nice project. I think also you're putting forward a quite refreshing topic, which is that the architect does the design at the beginning, and then developer and the client at the end, they just have to play with the game. So in a way, almost they don't really give the brief. So I think that's quite nice to really think what does it mean when, in this case, you're putting forward something as a product, and then the developer or the user need in a way just to work with the element or adapt it. Maybe I would question that your input is more the work on one specific site. So in this case, this specific station versus maybe for other stations there are then different architects. So you act more kind of like a master planner. And then you have like these different architects for different sites. So for me, I think that is what is quite nice. That is quite, let's say, design as a priori instead of reacting to the condition of user or developer.
How do we evaluate the quality of the spaces in an urban scale, the quality of the spaces in terms of habitation? You're setting up a game, setting up a system. Of course, that can be gamed, right? I mean, people can manipulate that system to particular ends. Have you really explored what good would look like in specific scales? And I guess back to the question: how do we evaluate these spatial outcomes within the system?
We have for the game rules based on the city planning, and we have a goal to achieve certain number of living or working modules in this area, because now our aim is to densify London, and transportation hub is actually already have the opportunity, like the commuters are going here, and so we have a base number for the densification in the terms of this to create a productive dense environment for local people, but in the terms of spatial experience, it's a customizable gameplay. So So I think the module, the number, we have like the adaptive modules for users to choose, and the customizable scale of the structure and the interior space.
Well, I mean, there's the answer. In a way, when you work like this, when it comes to the final configuration and we're saying this is the outcome of a series of individual choices, that is kind of self-validating as optimal with respect to the utility of those who have been making choices, and they can also readjust the choices through a secondary market and keep going and exchanging and flipping units and merging units until it is like this. And then we can look at it, and what we then ascribe qualities to it is in a sort of irrelevant. What we have to, in a sense, it's kind of a stepping back from the final result. And then we can maybe compare different systems, but it's sort of giving away the final, the evaluation already in the design process, which usually is what the market then does to you, which he is kind of anticipated because the market process is part of the design, which I find fascinating. And with this respect, I mean, I find, of course, how you've simulated that is a big open question always, because we don't have that market process. So you have to try to anticipate it, and then the way to do it is perhaps to explore different outcomes, potential outcomes. And you have two on the wall where I've thought that, and I'm quite curious. The first one, right here, it seems to me as if you had pre-established a master plan and said 3 volumes, and then it's only a matter of choosing internal units and who to be next to. And that's a bit of a disappointing, because then the urban configuration isn't an outcome of a gamified system, but it's prescribed, and then it's only internal elements. So I think somehow to see this is more credible as something. And by the way, I love this when you have those visuals and space are very suggestive. I could say I have an intuition about, yes, this has a lot of qualities, would be desirable, but the particular outcome we don't know. You stand away from. But I think this one is more of a credible, because it seems to me more contingent outcome of a process rather than something a priori set. So, and I think there's a lot of qualities in that. By the way, I want to say one more thing about these roofs, which I quite love. It's a new idea in this kind of group of projects where it's not only the modules start to aggregate in certain things, but then that's my understanding, once certain modules are placed, there's a kind of fusion or nuclear reaction or something, which is quite a strong idea. Obviously, but at the moment it's only playing a very subsidiary part on, you can see it right now, on the roof, little pavilions that don't impact. But if that was more, a very strong new, fresh idea for making more impact, that the gameplay isn't just placing things, and that there's something which transforms, which somehow makes sense of of that adjacency.
Yeah, I mean, I think if I can comment on the back of the 2 questions. First of all, congratulations on making tremendous progress in the last month from where you were to what you have here, even very credible, very plausible scenarios and spaces, which I find, is in itself some kind of recognition of the value of your system, that, or that it holds up to some amount of scrutiny. And so, having said all of that, some of the contributions of the project, I think, are to highlight, first of all, the the topic of transport-oriented densification, which I felt that perhaps you could have spent a bit more time elaborating on the value that brings to cities like London, and how there is currently such a strong opposition to densifying around tube stations, around railway stations, and even if you had presented a few currently extremely low dense developments around what could be very high dense potentials. And the second, the choice of the site itself, I think is very pertinent and relevant, because there's lots of things happening in that area right now in the same realm, like AHHM and other architects are developing functional solutions, and this sits quite well, that it is quite plausible that it can be the next evolution of that. So it's not extremely blue sky thinking, and so that is also, I think, one of the contributions that you made. And also on the spatial tech side, as Patrick mentioned, this idea of when two things combine, what happens when they combine from left to right, top to bottom, so that could have been more distributed across the rest of the modules, not just the roof ones. So all of these aspects, I think, I find refreshing, but at the same time, one of the things that perhaps I would have hoped for more is the gameplay itself, clarity on who the players are, why you chose those players, and some of the outcomes, even if some of the outcomes were not fully resolved, what did you do as architects and as experts to resolve those conflicts? So because the whole idea is that the game is a discovery engine, right? And so we should also discover things that don't work, and also things that work better than others, and so on. So that part, I would hope you could bring that out a bit more. But other than that, I'm very positively enthused by many of the ideas that you're putting forward, and diligently been working on for the last year. So congratulations on that.
I wanted to say that question of gameplay seems to be the least explored and sophisticated. It's almost, you could imagine an individual on their mobile phone making yes-no decisions that a Windows 95 machine might ask them to make, where what's really thrilling is exactly what you've just heard, the idea of coming together and experiencing in space what your intervention might be. And I think the possibilities of that for participatory design in shared virtual space is really interesting. It's a lot more interesting than the kind of WeWork modules that get plugged into space and that WeWork had developed, 6-7 years ago. What you start to see then, if you take the ideas that you've developed further, are ways to challenge and to take into account what we've all learned about hybrid environments and what we've all learned about coming together and being a part, and our ability to reshape and be flexible with environments within these structures you've created. I do think that if you were looking at government tech and negotiation taking place, there are even more possibilities that could come to life. What does it look like if you have market models and bidding and people forming collaborations or partnerships or controversial relationships with one another and pushing them out? What happens to the space then? How weird does it get, and how awesome does it get? So you might have some interesting possibilities to take forward, looking at your favorite, most sophisticated, and definitely weirdest games that are out there that everyone is playing right now.
I think I'll just add to that quickly, is that in order to actually enrich the gameplay, to contextualize it, so actually consider what are the motivations of the stakeholders in this particular context of being in the location that you are, the urban environments on both sides of the track that previously have been segmented and now get connected, to start really building scenarios of what the motivations of these players are, and sort of maybe create more types rather than the 3 basic types, and play out these scenarios, and also to consider learning in the process of participation. Again, the temporal effect here is I don't know whether we've pushed it to its extreme. It's the idea that the game is played and then it is built. And you've really touched upon really nice ideas of going from it just being a game of assembly to a game of forming, a process of forming when things come together, and the result could be differentiated. However, then it's also interesting to see if you think about it more in stages where more can be built, and there's learning in the process of the participants and the choices that they make. How could that also affect the game and the output?
Great, a lot of fun, exciting possibilities, and like everybody else, I think I will fixate on exploring again this revised design process. So if you're going virtual or metaverse, I think you have a fantastic opportunity to crowdsource it, to try it out with hundreds of teams of people who are playing different roles. And you can assign them roles and then see how that plays out, because the goal is to encounter early on the unexpected emergent consequences when different people are specifying whatever they want, and then you pack it all together and what happens. So I'm sure there was going to be a lot of odd consequences that you could play out early and then begin to streamline before you have to go real. I think also it would be so nice to know that how in the future this is going to play out with virtual exploration of the consequences. So I know it's really hard to get people. I mean, I'm looking at the size of these spaces here, and you know, they're really big. And maybe that's okay in the virtual world, but I'm not sure that people want that high space all the time when they're coming home. So, you know, one wants to kind of understand, well, this looked to me really good virtually. How's it going to play out really? So the next step would be to somehow find games, not games, but opportunities to try other people's place, try your place, try all the different places, and see if you can get a greater commitment. Because buying it in the end is going to be expensive and they're going to have to want it. So.
Yeah, thanks for this presentation. I agree with, I mean, you spoke about this way of playing the game and then it's built. I think, in a sense, it's a real issue in this project, because you can play only once, you know. So we really wonder at some point, then what is the real role of this game? I mean, it could be like just helping the developers and the clients to take decisions, because they don't manage to really figure out what the architectural space is about, and they can also explore many different scenarios. But I think this should be clearly stated, because you know, in SimCity, I mean the original one, you can play as many times as you want, and in a sense here, it's just a kind of decision-making tool. You know, it helps to maybe, again, to take the right decision. But if you believe that this interior structure, which are at some point also not interior, I mean, it's what you are showing here, it's not interior design. I mean, it's structure, you know. And even yourself, you are also speaking about this as structures. If you believe that this can be dismantled and reassembled, etc., in a manageable way, I think you are wrong. I mean, it can't be done. And even, I mean, look at the size. Look at the size of all of this. It's the size of the Centre Pompidou Metz Museum by by Shigeru Ban, you know. And if you look at the wood structure there, you see that this is not a kind of structure you can easily dismantle and reassemble just like in a few hours or even in a few days. So here there is really an ambiguity in your project, because according to me this is not solved. We don't know if it's a game. We don't know if it's a flexible building. According to me, it's not a flexible building at all. And I see this game only as a decision-making tool. I mean, but that's probably what it is. But that's what it is. But it's.
Of like which two spaces go together, and like once it is done, like it just moves on to the next stage.
Yeah.
And so it doesn't need to be a perpetual game on one side. Like it could then mutate and learn from like this one and move to the next potential side.
I agree. This would be enough to make it a really good project, and it's a very interesting project. But there's an ambiguity in the way they present it, because they speak about assembling, disassembling, like soft. I mean, almost like a soft structure, etc., or temporary structure, interior design, while it's obviously not interior design. So, yeah, it's maybe a matter of presentation.
I just wanted to say that I see it as a site-specific project, and I like the way the table is just laid out and dislocating the transport from the architecture above. I think that is so simple, it's kind of genius. And but I'm sitting here wondering for all this time why I find it all so elegant, because I know this type of project. I know this is an ongoing project with the DRL, but the result here is incredibly sophisticated, and I'm trying to work out why. And I think that's to some degree the AI, what is the consequence of multiple voices buying into this game. But I think there's a degree of EI here, which is emotional intelligence, because they just feel like spaces you want to be around, irrespective of whether you scale them differently. I think it's very real. And in terms of that construction that you're looking at, I mean, we all love the laser-cut wood with the brown edges. And I mean, in a Toyo sense, if you just develop that, and then you put this very sophisticated sort of structure on the outside, you've got this hybrid between something very luxurious in terms of light penetration, feeling, projection, everything, and then this sort of glamour of the unfinished outside. And there's something unexpected for me in this. That it's not ragingly out there, but the more I look at it, I don't get tired of what I could find in there. Yeah.
Thank you very much for the presentation. I just want to ask one kind of simple question to start with. So you keep referring to this as a game, and I was just wondering who are the game players? Who is playing this game exactly? Because I don't think this was very clear in your presentation.
So the players we are thinking about is that co-working, co-living, and public. So the public is referenced as municipalities. So they are the three main players that enter the game. But when they have purchased some lines and voxels, they can like rent the voxels to the end users. Yeah.
So the municipality is a game player, from what you just said.
Sorry.
So the council is the main player of this game. This is what I understood.
A player.
Sorry, a player.
The council and the developers for co-work and co-living.
Right. Okay. So I think like I mean, going back to Philippe's point, I think at that kind of very first stage, you do need to put a lot of specificity into what these or who these parties are and what they are actually trying to work out from the game exactly. Because I can tell you, or I mean, logically speaking, like if you were a developer playing this, I don't think you would really find it a very enjoyable game because it would all have to do with areas and costs and, you know, like, and square meters basically. And as a developer, I would be trying to get something very specific out of this gameplay, which would be exactly that cost and areas. Whereas as a user, I would be looking something very different. And as an architect, I would also be looking at something different. I think at the moment, what you've done in the project is you collapse these three categories together into one kind of like a flat hierarchy, so to speak. And it's interesting that, you know, you're using some of these elements and you're saying that the user, whoever that might be, will decide on where the column goes. Like I can have a column in the middle of the space, I can have it at the sides. But of course, this is not possible because if you're a user and taking structural decisions for this building, then this becomes very complicated. It's not very kind of like workable. So I think, you know, like what I'm trying to get at with this is that you need to allow the different types of users to only be able to take a restricted set of decisions. So a user cannot take structural decisions. The developer probably cannot either. The architect might be able to do that. And the user would be looking at something completely different to all of the other kind of people playing this. So I think this is in a way something that would put more specificity into this whole thing. And then the other is also, because there's all of this idea of flexibility in the process, I do think that somehow it's a bit of a paradox and contradiction to do all of this and then press kind of stop, and then it all stops, it gets built, and that's it. So because that kind of loses the whole point of flexibility and of actually, once this gets built, to be able to readjust and keep kind of readjusting because the market changes. And therefore, I need to put different programs there. I need to do different things in the end. So the moment that you press stop, I think it becomes a bit problematic in the sense that the spaces might be obsolete after 5 years. And therefore, all of these processes like a bit unnecessary. But I do think at the same time, again, that there are very intelligent things into the project. And the fact that you actually try to make this whole scenario work, I think is very positive. And design-wise, there are very positive aspects as well. So, yeah thank you and congratulations.
Because in the spirit of time, I think it's important to kind of bookmark this one. But I think there are a couple of things that have been brought up that I think need to be strongly considered. The notion of time, the notion of game, who has agency and for what purpose. Novelty in gameplay is what generally makes games successful. Fix this kind of gameplay into a certain morphology would have different criteria, right? It's evaluation criteria that we've been bringing up. Whatever the kind of orthodoxies that kind of underpin, I think, the decision making, I think that those things need to be made very explicit. Because I think it should be more than a planning tool. It should be more than an intelligent planning tool. It needs to build on the discussions of iteration and the generative aspects of testing different sites and constraints. That's not an easy thing to do. It becomes even more complex when you say that it's participatory. Participatory for me, you know, is going to mean slightly something different. You're trying not to flatline the hierarchies, you're trying to change the motivation of what our built environment is. So if you're going to do that, the rules of the game is not what you want, not what any one of us wants. It's the kind of collective intelligence that is being brought out from this kind of shared interface. And that's not really being discussed. Like, if it's the council, then it's called a council estate, and it's decision-making based on that. If it's developers, we know that world too. You're trying to give back a certain kind of power to people to be able to somehow claim space, but that also makes certain assumptions that those people will be the same people playing the game as living that life. In a city like London, where there's a lot of fluidity of movement of where people are living, that also are contingencies of somehow thinking that the game has to evolve beyond planning. And that just means that the rules of the game changes. And then even as the structure is evolving, there are some other conditions that enter in, which is the living conditions that I think that we've been speaking about in different forms already today. So I'm just stating that because I don't think it's a decision that you have to take, but it's an opportunity to see this in different ways. We may all have different opinions, and I'm always feel a little warm inside to see our staff be so eager to comment. And I would really love our guests to comment a little bit more, mostly because I think we've had a lot of these conversations. I think the product of these things are evolving, and I think you've made a good contribution to the studio. But you guys are also dealing with a third challenge, which is how do you make a system that actually achieves those things? So Philippe's points, I think, are very relevant. And I think the reality of those things is that that's where a lot of our intelligence comes into play, not only as systems designers, but how things come together, what flexibility really means, because right now it's quite too open to interpretation. And I think that conversation is going to be evolving. The question is how. And that's a question for the studio and for us as a program. But for you guys, good job. Thank you. Move the models. Next up, and we have one more before lunch. Thanks.
Hi everyone, we are team Metaflexion from Studio Schumacher, and today here we are Shardul, Kirti, Joey, Sammy, and Damon. The metaverse offers a wide range of opportunities in various areas, including remote work and collaboration, social connections and communities, education, and training. For this project, first, we carried out a few case studies of 4 popular contemporary metaverses and analyzed based on the main features, user interaction with virtual worlds, tokenomics, and their virtual world designs. Based on these studies, we found that most current metaverses are associated with rigid and uniformly shaped virtual land parcels, low-fidelity 2D worlds which still operate on web-based conditions, and empty and barren virtual worlds. In our thesis framework, our main agenda is to propose the use of parametric urbanism and fluid dynamics as design systems and artificial intelligence as co-pilot to create dynamic and adaptive virtual worlds which respond to collective decisions made by the virtual community. To further break down, Metaflexion consists of 4 main aspects: the human or non-human agents and their underlying social aspects, the design of the virtual in-world objects, possible ways of interacting and modifying surrounding space, and metadata or relationships between the entities of the virtual world. We went on to classify our user types into 4 main types, which are landowners, land tenants, employees, event attendees, and metaverse tourists, each with their individual personality and behavior and collective community consensus behavior. Based on the social transaction theory, all the user activities are classified into transaction, social, and cultural activities. These 3 main zones of our metaverse are represented by the primary colors, later feed into the fluid simulation to give rise to dynamic and intermixing fluid zones. To create more meaningful metaverse experiences, we designed an intelligent agent, Fluxa, who will now introduce herself.
Hello, I am Fluxa, an iBot designed to help people in Metaflexion. I am designed to have several modes. In social companion mode, I can help you make social connections, find like-minded people, suggest activities to do together, and give personal advice. In recommender mode, I'm here to help you find personalized content and experiences. Finally, in productivity mode, I'm here to help you maximize your time and automate menial tasks to help you reach your goals. In content creation mode, I'm here to provide tips and tricks for creating content that will engage your audience and gain popularity.
Fluxa is based on a Whisper AI model by OpenAI and ChatGPT, and it uses fast speech by Meta and audio to lip sync by MetaHuman SDK.
Hello, I am Fluxa.
In addition to this, in Metaflexion, we propose the use of virtual touch, where you touch virtual objects, use hand gestures to actuate and activate space around you, use spatial sound to get a sense of where you're of the presence, and also activate space or agents with your voice as input. Now looking at the tokenomics and governance of our metaverse, the economy mainly consists of two streams: assets generated either by users, the platform, or other virtual worlds. And in tokens, we have two types: economic tokens, which power all transactions, and a reward token, which act like a credibility system by incentivizing productive behavior in the metaverse. These reward tokens have a quantitative aspect assessed by the DAO and a qualitative aspect assessed by other users, which combine to provide credibility to the user's action and impact in the metaverse. Based on which zone these are shelled out, they have different meanings. For instance, in transaction zone, influx is allotted based on the volume of transactions and voted on by the employees or the visitors. In social zone, influx is gained by the audience footfall and voted by the attendees and the audience. And similarly, in cultural zone, the influx is gained by the creator economy generated, and the vote is by the attendees and the audience. And on the governance level, we mainly have three levels. The first one is the metaverse level, where various stakeholders can decide upon the future expansion, the urban fabric heights, or the ratio of transaction, social, cultural zones. In district level, parcel owners can negotiate on the size, shape, porosity, or sharing conditions. On the plot level, parcel owners and tenants can negotiate on sharing space and customizing the facade. Now let's enter our metaverse. When a user logs in, he first lands in the entrance lobby. When the user logs in, first he gets to create a virtual identity for himself in the entrance lobby, and later he can go and choose the spawn point of where they would like to spawn in the metaverse. So for virtual identity creation, we have two types. The first one is to use your real identity. The second one is to use AI to create anonymous identity, which also prevents identity theft while creating high-fidelity, hyper-realistic avatars. This is the workflow of how we create a real identity by scanning our face with a phone. And for creating anonymous identity, we use interface GAN over style GAN to have semantic control over facial features and provide user customization. Here are some catalogs of some results using these AI models. Now for fashion generation, we have tried using prompt-based AI diffusion models where users could prompt what they would like to wear and then pass them through GANs, which would process them into 3D meshes. So here is a catalog of different fashion items generated for different occasions using this process. And on the right, we see the interface of how a user would experience this in the metaverse. Here's another catalog for workwear or party outfits.
Coming on to the urban master plan, as mentioned earlier, we have three different zones in the city, mainly transaction, social, and cultural. In order to get more coherent and intermixing zones in the city, we simulated fluids on the site to derive our urban pattern. These fluids are adapted to the landscape topology. From the fluid simulation, we executed vectors. From that, we get vector field lines, which gives us our cities subcenters, which are interpreted as the public spaces in the city. Following that, we have the primary network of our city. After the primary network generation, we After the primary network generation, we simulated turbulence into the field curves in order to reinforce the fluid character of the city. These values of turbulence are based on RGB values of the local region. Setting our primary network in place, we rotate these field lines at an angle of 45 degrees in order to further subdivide the network. This gives us a secondary pattern and also our parcels. The size of the parcels depends on the RGB values, with cultural parcels the largest and the transaction parcels relatively the smallest. That's the city view. That's the urban layout of Central Plaza and open spaces. The building heights are derived from three major factors, namely value of fluid color saturation, value of vector field saturation, and distance from the parcel, distance of parcel from the local subcenters. We have three basic building typologies corresponding to three zones in the city, and these typologies can morph between one another depending on the color of fluids that is present in that parcel. The twist of the building depends on the saturation of the color. We provide our building buyers with an opportunity to customize the facade depending with either horizontal or vertical differentiation of the facade and everything in between. Here is a catalog for design outcomes. Furthermore, the user can also customize the building exoskeleton depending on what he likes. After adding this, Metaflexion does provide an opportunity to a group of developers to create a sense of district with a family of similar building facades developed out of the customization. After the group of developers have formed a district, they can further negotiate within the district and have connections between buildings. They have three major conditions to do so, namely connectivity, isolation, and porosity. Here is a render for the district. That's how it's seen in the metaverse, and that's another close-up shot of buildings combined and negotiated between them. Doing a fluid simulation on the urban scale, we decided to do a simulation on lower scales in order to have a harmonious design language throughout the building. This slide shows fluid simulations among all the open spaces in Metaflexion.
The transportation system of our metaverse is three-dimensional and divided into three levels. Walking can reach any location. Flying can only happen in the canals. Vehicle travel on the upper roads, which are divided into public and private. And the teleportation are also divided into public and private and take place in different areas. And this gives users the freedom of choice. And our vehicle units meet basic transport needs and also allow for small activities. Private units are paid for, but users can customize the interior and exteriors to suit their needs. And our units are intelligent and can be adapted to different numbers of people and different space requirements by moving the y-axis and x-axis. The public units are funded by organizations, companies, or museums who promote them through VR, 3D projection, and hologram. Users can choose their own activities of interest to experience during their journey. Based on crowd analysis, the seat stations are placed in the city through the 300 meters traffic circle, and they will link almost to of transport. Users can choose their own interface to display a 3D map to get their location and the route of their destination. The user gets information about the different modes of transport and selects by using the station system, and the navigation system is displayed in the first-person view, and the can choose to turn it off or on. Coming to
Coming to the public spaces, we have Central Plaza as the first. We simulated fluid at a smaller level, as discussed earlier, to have a harmonious design language. Then we converted the fluid simulation into simological curves to get the zoning of the plaza. The plaza consists of an NFT gallery, conference center, design museum, and a landmark tower to mark the center of Metaflexion. And this also acts as an orientation device for the users in the metaverse. Here is a render of Central Plaza, how it sits in the city. The landscape of Central Plaza is derived from vector field lines simulation and is dynamic in nature. Semiologically, there are 4 main patterns in the landscape used for different uses. The landscape below the landmark tower is dynamic and changes according to the needs of the landscape below the landmark tower is dynamic and changes according to the needs of the user. Depending on what the user needs, it changes to the form. It has 3 main functions: public events, private events, and semi-public events. Coming to the NFT gallery, we simulated vector field lines with varying point charges and spin forces. These depict the main display and interaction points in the gallery. These will be the areas where most popular NFTs will be displayed. They change over a time depending on the popular NFTs in the market. Here is an exploded ISO view of NFT gallery. We have categorized the NFTs into 3 main types: 2D NFTs, 3D NFTs, and sound NFTs. Here is a video of 2D NFTs. When the person gets closer to the screen, it becomes bigger and zooms in to show a better view. That's the sound NFT display. The particles are responding to sounds. And that's the overall view of the gallery.
We define conference center in our metaverse as a place where visitors can customize meeting spaces layouts. And metaverse automatically shape the room size and amounts by sensing the number of people. The interaction of informal space at ground floor and the formal one at the first floor show meeting spaces can be changed from no matter type, size, or amount according to users' willing. Video shows the process of informal space customization. 3 options, including public presentation, semi-open discussion, and private meeting can be held in every default block of this space. At first floor, attendees and orators are both enter meeting space by some browsing devices. Attendees have right to select interaction mode to attend a meeting, and the orators can change stage layouts to present a better conference. SimLogic, we generated our second plaza as well as the Sentient Plaza. This is Waterfront Plaza, and from simulation lines and into the real space, and we define Waterfront Plaza as the place where people join concerts and fashion show and meet celebrities in our metaverse. Users come to Waterfront, first go to the browsing hall and browse concerts and fashion show events and get an access to them. This is the first stage. We generated 2 stages and bringing different songs vibe. So performers have options to choose a more proper stage to fit a song's vibe. First stage is more about helping audience better focus on music itself, and to the audiovisual visualizer responding to the real-time sound offers a better vibe. The second stage is more about immersive experience. So audience comments will become some flowers or plants appear at stage and other fancy effects to decorate the stage. So till then, a show is not only presented just by a performer, but also audiences. This is how Avatar entered the waterfront browsing hall and votes for the coming soon video and browse events and go to the concert space. As a concert is a space contains a large amount of people, we tested 3 modes to better manage the crowd in public spaces in our metaverse to resolve the conflict between socializing and the distinction from high intensity of crowd. If visitor in a normal mode, passengers' avatar show gradually when users' avatar approach. In exploring mode, passengers fade away when the users approach. In associating mode, passengers glow when users approach. Collective decision, it decides on the final choices in odd situation according to users waiting in public spaces. The countdown time will be triggered when the first person as an organizer to trigger the countdown time, and other visitors vote for options within the time limits. They'll choose the high votes option and generate the space.
Here we move on to the 2 options that Metaflexion provide for users to generate their own content. To achieve that, the user can first go to the land marketplace to immersively browse the parcel value, zone ratio, and some possibility of those customization of default typology. Option 1 is that user can apply their request to DAO and automatically get a combination of units, could be further customized, etc., like location. And here illustrate a scenario of cultural run as example that the real retail experience in Metaverse. With 3 different sizes of typical retail units, the user could customize the material, shape of vehicle, and further display the result in detail and experience the driving. The second option is to build from zero by using configurator. So based on the default typology, a certain number of voxels will be generated to fit with the surrounding buildings. Then developer could customize the function of voxel, but within the restriction of zone ratio. After that, user could insert void voxel to create a breathing space throughout the building. In this step, according to the user's capacity of creation, AI body, which is Fluxia, will offer some recommendation. After the void space generated, exoskeleton will be generated automatically. This exoskeleton is used for not only exoshell, but also for the circulation in the tower. Following the 3 zones, this configurator also provides 3 types of modular, which is the shell modular for control, blocks for transaction, and branch modular for social. We also offer the shared condition of a group of developers. They can join the auction and offer the bid. After winning, the developer can start configuring their own space by asset pocket. Then the developers can publish this aggregation to earn their tokens. Here's the catalog of assets could be used in transaction blocks to establish an office scenario and etc., like co-working, conference space. And subsequently, this asset could be used in cultural shell units and social branch units to help build a social party or a movie launch event. After that, these three basic units has its corresponding intelligent behavior can help the developer to build a more coherent and adaptive space experience. In this example of configuring tower, the low rise is for cultural. In this case, the movie launch is the implement of the intelligent behavior. And here shows the shell units usage of canopy, entrance lobby, and public lounge, and the product display, etc. So the the cultural intelligent units is for a coherent narrative, the movie storyline. First, attendees can ramble around to see the character story, and then the screen will goes to form the film screening mode, and eventually the screen could spreading out to allow the audience to experience the scene immersively. Second scenario is the office shared by two different companies. In this case, co-working and conference space are the intelligent units. This shows the interior of this office and how you enter the display room to discuss with your teammates. So intelligent behavior in transaction block is the ceiling and the floor could change pattern to switch between private working, workshop, and group working space, which will make the office space more flexible. And we also build up VR prototype by using hand gesture, because we believe this will help the interaction more intuitive and more coherent. You can change the space or organization and also teleport to different scenario. And this third scenario is social party hosted by a metaverse company. So the ground floor is sort of a small product exhibition, which is a mixing occasion of using cultural and social units. And subsequently, the intelligent behavior in social units is the dynamic platform could move and rotate to extend to have a novel experience and multiple function party, for example, like fashion runaway, dancing pool, exclusive lounge. This shows a day in metaverse, like choosing your spawn point, enter the attend the cultural event.
Thank you.
Thank you.
Thank you so much.
It's working. I'm working. Okay, I can give you that. Now that's like it's witnessing the birth of a new era, really. I mean, to navigate the metaverse, which is again, that's inevitable. It's important that the dialogue starts from these kind of platforms. I think it's fine that being explored within other spheres of sort of art and luxury. But I think this whole understanding is going to come out of this architectural realm, absolutely. Because the complexity that you deal with as students, obviously you're being taught, but to be able to assimilate that layering of abstract complexity is really, we mustn't underestimate that. But I do feel, obviously, it relates so well to what Patrick and the Zaha Hadid office is looking at, and that, for me, as a sort of semi-outsider, I'm astonished by this idea that what you show is where we go. You've got to do that. You've got to speculate, and I'm finding the real world a little bit dull these days. So I'm in big time. I could walk around with VR goggles on all day and smoke a joint maybe. But I think what we're experiencing here, whether you want to dissect it out now or not, is it's phenomenal, really. I know that's not really much of a comment, but that's it from me.
I have to also agree. I mean, it's incredible, like an incredibly productive piece of work. I mean, you've done so many things, and I mean, I don't know what else you could have done actually to try to explore this subject. In the context of an architectural project. In the context of an architectural project, that is. But I do think, I mean, I was actually thinking some things when you were showing this movie that there are some questions for me at the same time, which, I don't know, maybe you can go on a PhD afterwards and try to explore some of these at that level. So number one would be in this kind of metaverse environment, you show floor plates, you show structure, you show cities, you show landscapes, you show vehicles. So I need to get into a vehicle to travel somewhere else. And my question would be, why do you need an exoskeleton to a building? Why do you need structure? Because, I mean, I was thinking this thing that Greg Lynn wrote about, in one of his early books, that gravity is the last frontier of architecture. And he was giving the example of sharks and moles, how they move respectively in the water and in the earth, without any kind of sense of gravity whatsoever. So, to me, I mean, this is one of the first things that you could do away with, because you don't really need it in that environment. Unless if what you're trying to say there is that you're designing all of these things in order to then this becomes almost like a petri dish for understanding space and certain principles that you then apply in a physical environment. If you don't design this with that in mind, I think there is not really kind of any reason why you would use kind of real world conventions in this world. And I think the part where you actually show that movie where somebody selects the movie that they want to watch and somehow this natural landscape is created, I think towards the end of this movie, and then you start kind of going up in space. I think to me this is the most successful moment in your project, because again you get rid of all of the conventions that we have in kind of, let's say, boring reality, and then you go into something completely speculative. So I think to be able to ask some of these questions at a later stage, about all of these conventions that we use, I think is something useful to delve on for later on. But other than that, again, incredible amount of work and very well done.
Oh,
go ahead.
Okay. I had that same question about real-world conventions in a fluid, dynamically informed environment, noticing places like places for people to sit. But why would you sit when you could swim? I noticed the perspective here is your avatar perspectives are maybe not as well informed as they could be. What would it be to be the avatar themselves traveling this landscape, this fluid landscape? What is it to be in a first-person shooter kind of mode? What is it if you rethink it all together with the fluid logics of your world, right? I find myself also thinking about the work, you're dealing with metaverse and virtual reality, but if you're looking at augmented reality work like Slurp, for instance, and the work of Shengji Wu, who he was one of our master's students, but he's done work that allows you to, with yourself in a virtual environment, to pick up color from the world around you and apply it to what you see. So I'll say that there's something interesting about the history of interactivity, that the word interaction comes from hydrostatics and from fluid dynamics, and from it has to do with the surface of two liquids coming into contact with one another. So throughout the history of interactivity for 120 years, if we want to write a long history, it's always about fluid dynamics. So I find it very interesting that this is where you started. You could now use the fluid to tear down the walls that you've built. and think this several more worlds through until you have something that looks quite a bit different, informed by the logics you started with?
I have one. Okay, so congratulations for this huge work. But let me be a bit more critical. Do you have the intention to build that project in the real world? No. Okay. No, I mean, I just wanted to double check. Because at some point, I'm still very critical and skeptical regarding this concept of metaverse as it is used by architects. Because for me, I see an unbuilt project. That's it. You know, I don't see anything regarding metaverse. I see a project which is not going to be built, like millions of projects from architects throughout history. And I see 3D modeling. But that's all I see. I don't really see architecture. I mean, I see shapes, I see, as I said, I see amazing animations, 3D modeling, concepts, etc. But the problem is that with the metaverse, and I mean, it's a general remark, you know, it's not against you or whatever. With the metaverse, as it is theorized at the moment in architecture, it gives me the feeling that I mean, just imagine that we want to do mathematical physics, and then we remove the physics. We just have mathematics, you know. And if we remove maybe the single element which makes a difference between architecture and non-architecture, which is at some point the fact that it might be built. I don't get it, you know. I mean, if you remove the potentiality of building from an architectural project, then you have 3D modeling. It's really like removing physics from mathematical physics. I really believe that we move into different categories. So this is my first remark regarding architecture in the metaverse. The second one is that, according to me, the metaverse does exist already in a much more radical way. It does not need architecture. I mean, look at the millions of servers who are spread all over the world. Look at what happens at each nanosecond at the stock exchange. You know, just like again, millions of buying and selling orders that are exchanged at every minute all over the world, etc., etc. Look at Google, look at OpenAI, and all the generations of images at Facebook with billions of images online, new images online every day. So I think the metaverse is already existing. It's all around us. And here it gives me the feeling that let's say we try to replicate the early mistake of cyber architecture, when the architects believed that they were so important and necessary in the world, while obviously it's the other way around, that the internet needs the architects. But I mean, it does not need architecture, you know. I mean, it needs technology. It needs language. It means
designers.
In a sense, no.
Of course.
It's a design in itself.
You cannot interact with the internet without an interface. And these interfaces have been designed by graphic designers.
Yeah, but not by architect in any case.
Well, but we are all designers first of all, before we have various sub-disciplines, But
why do we have this tendency? Why do we have this kind of?
It's happening.
Why do we need a city? Why do we need a city? I mean, you can't be metaverse architect without designing an unbuilt project. Basically, that's what I mean.
You can, but this has a whole series of advantages which will come through as this market explodes in front of us. And if you don't see it, there's an issue. But I wanted to come back with one other point, which is the being tied to certain conventions we understand from city life, from architectural spaces, venues, and so on, and what that means, and why this is at least an initial state, and we already see the transcendence of this. But what we're talking about is framing social interactions and if various events shift from physical co-presence into virtual co-presence and interaction, and to recognize at all, first of all these institutions and types and forms of interactions continue, and there's a kind of continuous social reality that we retransformed into a new setting, and to have any form of orientation and sense of that, we need to kind of bring over these conventions, but they will be rapidly will emerge and fall through. You can say the same thing: why do I have an avatar? Why do I use my body? Why am I a strange kind of amoeba? And the world is a strange, non-graphical chaos of flux. But the question is, how about the semiology and orientation and giving a grounding? So there's definitely a rapid transition from and working with these conventions. It's interesting that the current metaverse is way more grounded in the banalities of the contemporary physical translation. So we at least translating our own unbuilt work and see the potential and then animate that. So that would be my response. But
yeah, maybe. First of all, thank you for the presentation. Amazing work. I will give maybe another challenge to maybe to the studio. The problem now is a bit that the metaverse is just used as entertainment, as a consumption, as a leisure, where we spend maybe just 2 hours, 3 hours. And I think the challenge will be to really think, what does it mean to be in the metaverse for working? Like, what does it mean if I spend 10 hours in the metaverse because I'm working? So it's not just about going to the metaverse to have a meeting. I think we need to move beyond that and really think, what does it mean to just work, to be like physically in a space, but digitally connected. So actually gravity is important in a digital space, because you really need to match the gravity of the physical body. Like, we can't have everything just floating. I mean, yes, it can be fun if it's just purely like an entertainment space, but if it's a metaverse, it's really a space where we spend time. I think you need to have this kind of similarity of the physical space. It can't just be completely different, because then it just becomes like a game, that's it. So I do really appreciate the work. I think maybe to really look at, for example, athletes, how they work. So look at the kind of the profession that they are actually working a lot in the metaverse, not just purely as entertainment, but really physically in order to kind of challenge and work. So you say like athletes, pilots, everything that is also working with kind of simulation, and really understand how the physical body can live in the metaverse for hours and not just purely for like a little bit of entertainment. So I think you are in the right moment. I think you just need a challenge to really question it and make it actually possible.
Yeah, I would echo that experience enters the cognitive affective system through the body. You can't jettison the body, and it's just going to be creating a body again on this side. So you've got to have some relation there. But the question I would be most interested in, if you were going to do deep dives, what things would you choose to do the deep dives in? I could tell you a few that I would be interested in. I find these atmospheres absolutely relentless, and one of the reasons is because I'm not fond of the materials or the texture. So I would like to know what, if somebody's going to stay in there for a few hours, what kind of materials and textures do they want around them? And it's easy enough to create, and we could differentially experiment with all of that quite straightforwardly. I'd like to know what are the real activities that are the high-value activities for everybody. So I made a list of these things, and I was thinking, well, retailing, socializing, you mentioned entertainment, but the televangelists in America, they have this enormous amount of worship, and people who watch TV for hours on this stuff. There's a market there for televangelism or any kind of worship. There's going to be classrooms, there's going to be fantasy. People are going to want to parade around with image making. All of these are opportunities to create venues where that sort of thing happens. So you fixate on the kind of activity that people want. Why are they going there? Well, a certain sort of activity I can do there. So how do you facilitate that activity? And those are the deep dives I would be doing. I mean, I've got a list more, but tourism. You know, I naturally want to do some tourism, and you go there in Metaverse because I can go off to Bali for a minute or something. And that's my relaxation of some of the physical constraints. They're geographical, they're spatial,
We talked about sentience earlier, and we've talked about sensation. And if you were to take this a step further, you could look at the role of haptics and how it would make somebody literally feel. Not what they watch and not what they simulate, but what they actually begin to feel. You know, at this point, there's 50 years of research into that kind of interaction in virtual reality, but it would be really interesting to see how that becomes an architectural design question for the user.
I mean, I think that the conversation is always beautifully animate. And I also like the spirit of, let's say, difference. But I don't want Philippe's points to somehow be glossed over. Philippe puts an interesting challenge. It's not a challenge to the students. It's about how these things evolve. The metaverse as inherited with that slogan, is absolutely the most banal thing on the planet. That is ever more reason why to work on it. So the reasons and the motivation behind it, I think, is really important. But nobody is kind of like parading around thinking that Mark Zuckerberg and choose my avatar and all of that stuff is the future. Because I don't think that that's actually what's at stake in being discussed here. I think the questions about time is also important, and the questions about escapism. Because the reality of all of these things is that I'm still sitting in my apartment with my laptop. If I want to escape in a book or if I want to escape in the screen, I think the reality of interaction and experience is a really, really important thing. And I think it's something that kind of escapes language. I don't think language is helping us. That's why the demonstrations, all of those kind of things that make it much more sensorial and much more bodily in a very different way, which is part of the brief which I would like to see pushed further in next iterations, is this whole concept of the cyber-physical. Because we're still talking about, like, are we going to build this? Is the metaverse replacing things? Is this everything that we want? To be honest with you, be really careful that you get what you want. I think that that is really like setting up the problem, which is not a collective future. It's really more about my opinion matters, and what I want is what I want. And it doesn't set up the kind of terms of engagement that I think we need. So I think as a platform, I think one of the questions should be is like, how are we challenging the metaverse to be something more than entertainment? To be something more than 5 minutes or 15 minutes, or if you have the dexterity, an hour with a goggle set on. Because those technologies will shape and change, and the AR version of this is different than the goggle version. And all of those things are at play. So I think as a first kind of scratch into this deep dive of what the metaverse could be, I think it's very commendable what you guys have done. But I think it's also important to take everything that Philippe said as also a conversation to be had. Because I think your decisions in that, I think, set you up for very different conversations. Rooms like this 20, 25 years ago were also having conversations about virtuality. They used to call it hypersurface. They used to call it all these things. And at that time, that discussion was like, we wanted to build it. So maybe that's not exactly what the motivation was, or was the other camp have never had an intention of building it, had nothing to do but quasi-theory being brought into a conversation of architecting and whatever language people wanted to use at the time. There's something different going on now, because I think society has also had certain desires to be interested in this. The reasons that are motivating that may be different for a company and market than from people. I really would still side with people, because at the end of the day, they are the people that are going to be interfacing and having these experiences and potentially make this model viable or not. I don't think it's outside of the system of everything that we know. So I think the issue is to remove that kind of veneer and to really start to make some claims of the intentionality of your metaverse, because it's not singular. Your metaverse can exist amongst metaverses. That's an interesting thing to do, but I think how do you test your assumptions on stuff? I still think that there's something to be gained by having everyday users try to do everyday tasks in your world and to be able to sort of take a value judgment on that. So anyway, I think it's a really good start to the conversation. I don't think it's going to be solved. There is no answer, but there are definitely better ways of asking questions, and I think that that's how we're going to leave it at now, because something like food, I know, but I'm going to say this, we're really bad with time. Time has one consequence, and it's only food, and I have no problem in streamlining to 8 o'clock. I thought that this would be like the appetizer for obviously more engaged conversations between Patrick and Philippe and all of us.
No, let me go back to an historical example, just for the student. I assume you know the New York, the virtual stock exchange, the project, this famous project by Asymptote architects, you know, Annie Rashid and Liz Anne Couture. You know that project? No. I mean, some of you don't know it. You know, very interesting, by the way. I mean, what happens with this project? Are traders working in the virtual stock exchange project or environment by Asymptote? No, none of them. They don't even take the decisions anymore because they have been replaced by algorithms. So, I mean, now we can go for lunch.
Thank you.
When a new center is voted to be chosen, the system generator displays the building voxels to be generated on different tower levels. Similarly, if 2 venue centers are chosen, the tower generated is different. These are also depending upon the voxels that the developers choose to bid for their spaces. After placing the centers, there is a conceptual tower growth depending on the costs and choices of the players. In this example, a 2-center grid is generated, and developers choose functions around the building grids. This is a DAO view page which shows the spatial aggregation through developer bidding. Similarly, there can be numerous simulations happening in the online world which can generate the different values of mixes. Different simulations can be evaluated by DAO, community, authorities, and the developers themselves, and the best one can be chosen. This is a 1-center development.
To reach crowd consensus and provide a better experience, we construct an online decentralized platform where users can socialize, collaborate, invest in space, and program creation for multi-parties and multi-purpose. The online environment we set up creates a digital twin of the New London plan that connects all the scattered hubs and allows users who are physically separated to freely gather together and have access to public events in different hubs. A cryptocurrency system is implanted in the platform for users to interact with their crypto wallets using the decentralized web browsers and buy our cryptocurrency to propose their business plans and make investments. After entering the platform, the landing plaza is the first destination user will reach. It's the core of the hub and is always meant to be an experience that welcomes users to the platform, providing a stepping-off point for the rest of the virtual world. The ongoing proposals, space sharing offers, and social events, and menus of published spaces are shown on the main screen for users to browse. The pool in the center is an open space for collaboration and socialization, where the most frequent conversation between users will happen here. By clicking the social events display screen, users will know the upcoming live activities inside the hub. The left-hand side is a proposal space, where users can find the ongoing proposals proposed by the collectives or individuals seeking investments. By subscribing and utilizing investment as votes, users can take part in collective governance of the community, living neighborhood, and urban regeneration. When users are interested in making investment for proposals, they can request a private chat with the initiator for further details in the separate area. And individual investors could also seek for partners to share the space, which will help minimize the cost and fully utilize the space to make a profit. Across the whole negotiation process, when the required fund of a proposal is met, the state of a proposal will shift to be under construction, and the construction mode should be activated, which allow individual investors and collectives to physicalize the space. This multiplayer construction mode enables negotiation to happen within the same collective and between different collectives. It's developed based on the module system, which contains all kinds of voxel designs provided by architects, has various types, and is rich in spaces, such as corner voxel, double voxel spaces, double height spaces, and circulation with different functions. The system highly increases the flexibility to change the configuration dynamically with the user selection. To begin with, users can build up the overall function clusters and structure of the building based on their proposal and preferences. The whole process is determined by the choices of users through negotiating between stakeholders to reach a consensus so that a win-win situation is achieved. And meanwhile, architects involved in the platform are linking the space chosen by users, refining the circulation of the building. So when the overall structure and facade are done, the result of generation will reach the balance between professionally generated content and user-generated content. Then users can start to modify the detail of the space. Along the process, the system opens the portal for users to upload their customized furniture to the crowd. These assets could be made private for personal use or public for profit. With the supportive functions, users have the freedom to define the furniture and where the furniture should be placed and the scale added. And when the space is published, it will be physicalized and turned into NFTs, which will hold values for physical space and virtual space that users can sell or rent out. Since the physical construction process will take months and even years to finish, before achieving the physicalization of the spaces, users could always join vigorous public activities online and enjoy public events together day and night. When being in an event, the user can toggle to the first-person mode for more immersive experience. The implemented techniques will help visualize the avatars of virtual users to enjoy the event along with the physical visitors on site. Users can also have access to the published spaces, socialize and host public events on the cyber-physical platform for collaboration and networking. For daily working scenarios, users can easily upload and visualize their products for any discussion. And socially, users are able to create and customize their digital identities and avatars without physical constraints. The interactive screens and projections distributed through user-generated furniture also enrich the possibilities of user behaviors and scenarios on site. and all the functions within the space, from small bars, shops, exhibitions in the living aspect, to the working scenarios such as offices and conference rooms, provide different types of social activities and experiences for both physical and virtual presence. So in general, users can freely navigate, meet, and negotiate their business proposals with others through different layers. And above all, this mode is replicable to be used in another tower, other site, and different hubs in London.
So the spatial tech part of our thesis include creating spaces such as esports tournament arena, even spaces for gamers and NFT gallery for artists. It also provides supporting functions such as retail spaces, offices, and leisure areas.
For physicalizing these spaces, of course, we use two different fabrication systems which actually make customizing the spaces more possible than ever. One system is suitable for overall structural integrity, and the other system is capable of providing open spaces. So we chose 3D printing, particularly 3D concrete printing, and on the right, we have fabric formwork systems. So we did a series of tests and experiments using 3D printing in order to understand what kind of geometries can be designed regarding their support system, their amount of curvature, and as well their contour position. We got an understanding that one of the base geometries that can be designed with this system is actually an arch system. And in an arch system, since it's divided by 4, we can then summarize the column can be a kit of parts. So we can have a system of kit of parts that is entirely 3D printed. In order to visualize these 3D printed columns, which as a result combine into one floor slab, which occupies one voxel, they have a variation of support systems, which changes from the base to the top of the column itself. Additionally, it is very important to note that the segmentation of each of these slab systems should be always at all times perpendicular to the force flows that travel all the way to the ground. Therefore, as a result, we conclude that we have a base genotype of an arch system, which can have a derivative of one phenotype and a second phenotype, and all these systems are possible through 3D printing.
For the 3D concrete printed tower structure radiating out from the central arena, we designed a fan wall structural module of 13 × 13 meter. This structural module is customizable and users can choose and build upon from the provided kit of parts. The aggregation procedure starts from users choosing selected number of voxels, which are then replaced by skeletal structure along with an architect designed central circulation core. The next step is followed by choosing interior activities as per the user's choice. Here we can see the growth of the tower clustering vertically with the central circulation core based on the actions of player. As per the space requirements, the players can choose single light, double light spaces, projecting balconies, and so on from the provided kit of parts. The interior activity assets for the players to choose from includes cyber-physical spaces such as gaming stations, workshop spaces, meeting shells, mini tournament areas, and practice areas. The users can choose preferred configuration as per their space requirements and needs, like individual or group gaming or according to their voxel shapes. Other than the gaming areas, there are also supporting functions including resting areas, bunk bed spaces, reception, lawn spaces, bar, cafe, etc. This interior is one of the generated outcomes showing the lawn space overlooking the workshop rooms. The workshop rooms for the esports players are cyber-physical, provided with large LED screens where players from one center can connect virtually to the other centers. Another view showing group gaming stations and practice areas. Other than practicing area and mini tournament spaces, the hub hosts large arena area for diverse activities such as music concerts, esports gaming tournaments, and other large activities. Here we can see different arena configurations based on the scale of the event. This is one of the full arena configuration that can host up to 1,500 physical audience. It is surrounded by large immersive LED screens where spectators can see the gameplay and where virtual audience can join.
Other than computer gaming, the arena can also host holographic projections of avatars or players in a battle setup. This arena can also flexibly host other large activities such as cyber-physical musical concerts with immersive LED screens that can flexibly configure according to the scale of the event.
Additionally, we have spaces that are related to art functions, and one of these spaces, of course, is the exhibition space for art, such as NFT art. So we have art displays that display 2D forms of art, and additionally, we have audio forms of art. Therefore, we have types of 2D art displays, which can be for different dimensions of an artwork. They can either be square-sized, portrait size, or landscape size. Additionally, we have forms of audiovisual art displays, and these, as a result, can as well be configured to one another. Additionally, as a larger addition to the previous art models, we as well have larger displays, which can occupy more voxels. We can as well configure and aggregate some of these displays to one another. And of course, one of the important functions of art galleries is the auction hall. Here's an example of how all these configurations, we see that the for display of 2D arts is at the core with a 3D art display, and as well some other options for smaller artwork pieces. Of course, these can always be configured and customized by the user and based on the needs of the creator of the gallery. This is as an example of the interior facing one of the 4 displays of the 2D art. We can see both displays for 3D art and as well as cyber forms. And of course, that the user can navigate through the artwork, through the displays in front of them, and read information about it. Additionally, as some functions related to esports, which as well could be a hybrid between retail functions and as well leisure related, is the NFT Game Asset Store. NFT Game Asset Store is a small function related to esports. This is a space where NFT game assets become sold. They can be tested on large displays by the players themselves or by esports fans as a result. And at the end, there's another function. Per user need, they can as well create their own avatar, scan it, and customize it for themselves. And these can all be purchased through NFTs. As well, we can have different displays for retail functions. This is one configuration for the NFT Game Asset Store. And as a result, as these occupy in total 6 voxels, this is how the outer exterior will become. This is the interior of the NFT Game Asset Store, so we see the NFT game assets that are being displayed. And as a result, on the back, we as well see the NFT test display to visualize these assets. Of course, we have office spaces as well, and we have public offices, private offices, as well as private meeting rooms and public meeting rooms of a larger dimension. Here's an example of a small office with a large meeting room, which have both our private and public desks. This is from an interior view of one of these private office spots. So as we said, we have 2 different fabrication systems. We have fabric formwork, and then we have 3D printing. The base structure, the core structure, is at all times 3D printing. However, for the coverage of the interiors, we use fabric formwork systems, such as this image. These fabric formwork systems can either be used as tensile fabric pieces or can be casted in concrete, and we have used them evidently in all our interiors. Thank you. So for example, this is the example of the base support system for the column, and as we see, it starts from 4. And as it goes up all the way to the arches, it becomes a singular support system. This is, for example, one segment of one of the column pieces. It's very heavy.
Is there another one?
Yeah, thank you for your presentation and for making my black trousers now white. How do I explain that? I'm open to solutions. But nice presentation. I see the students are not laughing, so they're not taking it quite seriously. So, yeah, I was just talking to Patrick about this unfolding potential of using 3D printing at scale, you know, and what are the current limitations of it. And I work a lot with 3D printing companies in very different materials and different scales. And what's fascinating there is the progressive ones, instead of accepting the limitations, they come up with very ingenious ways of getting around it, you know. We were just saying that there's a limit to the sort of tilt angle when you print. But certain companies, they just rotate the print, so they get a greater angle. So what I'm interested in here is not so much the content, but just the way you're approaching 3D printing as a viable construction material or process. And so, and with that, I would encourage you to go really deep, you know, what you can embed outside, what you can embed inside. How do you mix materials? I mean, you have an evolutionary kind of a stacking up of structure, which obviously has a metamorphosis of weight. And of course, there are other materials that you can print too. So, you know, I never forget Jean Nouvel years ago. He proposed something called the Tour Sans Fin in Paris, in La Défense. And I never forgot it because I thought it started with granite, and I think it ended up with glass. And that's what defined the structure. And I think there's something missing just from a designer point of view. I think at the moment I look at it and it's got a slightly post-apocalyptic feel, which, you know, is fair enough. But I think if you got into a material stroke process morphology, you get much more out of this. I'm not really going to comment about the content because I think it's fairly well defined what you're trying to do. And I like the forum and I like a lot of those aspects. But just from a physical point of view, I'm going to pass this on to Patrick, who's also wearing black.
Great. So congratulations for this amazing amount of work. I think you have done really an impressive work exploring many different things. The metaverse part is quite well defined. Everything is rather precise. I would say maybe it's lacking complexity at some point. We have this module here, these modules, but they are extremely similar. I even wonder for some of them if 3D printing is the most relevant techniques of fabrication. Because at least when I see this prototype, half of it could be done with just like standard techniques. You know, you have developable shape or at least ruled surfaces. So in terms of pure geometry and fabrication, there might be some more interesting techniques. But at the same time, we could also say that 3D printing is mature. It goes really fast, and ultimately we will just do everything in 3D printing, and we won't care if the geometry could have been done with some other techniques, you know. And I think it's already happening. And because of that, I would say maybe the distinction between what you do in 3D printing and what you do with tensile, with the fabric formwork. I see this difference as a bit artificial, I have to say. I mean, I have no proof that what is done with the fabric formwork couldn't have been done with 3D printing. So I don't really understand this very strict separation between the two techniques, because according to me at least, we can't identify this in the final result. You know, it's not like something that's really obvious, and you don't have the feeling of a necessity for this fabrication. I mean, for these two different fabrication techniques. On the other hand, yes, I congratulate you because you have made some interesting physical experiments. The 3D printing are quite convincing, especially here on the right. You also try to 3D print with clay. I assume it's clay, even if it could have been tinted concrete as well. So, but yes, it's a very big amount of work, and yeah, quite impressive, except that it lacks complexity, at least for me.
I've seen you work across so many different scales here, and I do appreciate also that, you know, I think anybody when they're in a studio like this, in a program like this, you're trying also to get your head around and your hands around different kinds of technologies that you're interested in working in your career. And I've seen you do this in a digital sense and also in terms of the prototyping and 3D printing materials you've used. So I'm not going to render a critique for or against it, just that I appreciate that you've made evident what you've done. I want to bring up the question of voting, and we've talked about this a little bit in different projects, so I'm going to go a bit meta, not Facebook meta, but the other kind of meta here. And I found myself thinking about A/B testing, and I found myself thinking about the kind of complexity of contracts in DAOs, right? So far, your project and the other project that involved voting has been pretty simplistic. Just here, vote on what you like and it's fine. And I wonder what it might look like if we looked at different models for voting and choosing. So one thing, take or leave it, and sometimes I will say I leave this in design and development, is the concept of A/B testing, where you have two different permutations of something and someone chooses one over the other. Then that one goes ahead and you choose one over the other. Now, in an innovation standpoint, this can be really problematic because design features at a software company like Duolingo might never see the light of day if they get A/B tested out of existence, basically. On the other hand, what would happen if you A/B tested something and it went forward and went forward and went forward? Maybe it's interesting also considering that within an esports metaphor, within all of the stormtroopers that I see in everybody's simulations. But that's one thing I begin to wonder about. I also wonder about how you could make voting more complex when you consider the trickiness of DAOs and blockchain. Are there other models that begin to emerge and then that you bring to these questions of design for the built environment that you're doing? Do we start seeing at places like AA the possibility of bringing together different ways of doing that kind of selection process in design that comes from the digital, but that get taken up maybe in what gets produced in terms of structure and complexity? So I wonder if there's something that you could learn from the digital that you bring back to the physical fabrication.
No, I mean, just a very brief one on voting. Voting is a complex issue, and there's Kenneth Arrow proved the kind of impossibility theorem that there's no easy way to aggregate individual preferences into collective result, which satisfies some key intuitive rationality criteria. So we have a problem here. Right? So, but anyway, I agree with you that it's a very interesting area to be explored, and the DAO explosion of DAO discourse helps us with this. And yeah, I think it was good on that front in terms of explaining and developing the options and so on, and in developing interface, I was quite pleased by that. When it comes to tectonic system, it's interesting when maybe Shadia can ask the question whether a form like this could be 3D printed. I mean, in generally, but when it comes to Strider switch and so on, the 3D printing of concrete is compression only, but in your system it isn't quite. So it needs to be commented on, I suspect. So you need at least fibers or some other tensile elements probably to integrate it. And the segmentation is an important part of it. So in your tectonic articulation, you have this kind of white-painted, whitewashed, nearly kind of Greek island look, and it should be segmented. And when you go close, you also have the tool path. So these are nice aspects of it, which add something to it. So I think that on that front, I'm also a little bit unhappy, but I do find interesting the way it evolved from earlier versions. It's much more credible as something which emerges contingently through many choices and has a kind of liveliness and openness of form also in the towers. And I do like that something happens similar to what we had earlier when these modules are chosen. You're not talking about it, but this doesn't decompose into easy modules. But then something else happens. Maybe it seems to me that some kind of this cantilever then imposes some kind of nearly structuration. I'm not sure if that's part of it, nearly as if there was a kind of topology optimized a structure which is then embedded. I do like that. That's part of this whole kind of parametric modulus and so do find it interesting, but we haven't highlighted that on that aspect.
Maybe just.
I think it would just look significantly different if you did what Patrick was saying, right? Meaning you break it up. Again, you use the car analogy. It's designed as an amorphous singular object, and then it's divided up, and it makes it actually a much more legible object. So very beautiful for it. And so I wouldn't have any fear of the rawness of the condition. I mean, you could do that very quickly, even as a quick step, just to look at that idea, and you keep the architecture as you have it, and it would just give you something a lot more sophisticated, I think.
Yeah, I think just sort of building on, let's say, some of the conversations that we had over lunch, which was kind of our toning it down and then ramping it back up again. There's an issue about where tension resides in the work. And I think that there's one of those things, like in the conversations that we have between what's real, what's virtual, what is kind of, in a sense, probabilistically versioning something versus the selection process. I think the things that are very pertinent to your studio is the fact that sometimes these are paradoxically opposed to each other. And I think that that's where architecture somehow embraces that paradox instead of trying to streamline over that. Part of that is production, obviously, and materialization. Part of it is, I think, maybe more global mechanisms for decision-making. I think that goes to Molly's point about voting. And I think part of it is about your own intentionality, right? So the different kinds of ways of bringing this idea forward, I think, your studio, I think, has to kind of deal with the rawness of this kind of materialization and pixelization of every kind of G-code kind of plot of clay or print versus the digitization in that world, which is almost like instantaneous. And that world doesn't necessarily resolve itself. So I think one of the things that I think is important for the studio is it's not a planning tool. Throw it out the door. Because that means that at the end it reinforces a blueprint. That doesn't mean that it doesn't have strategic decision making. And I think the same goes with the production process. I think that you got a lot of comments which are coming from very different perspectives. I mean, the design is the thing that kind of holds all of those conversations together. And I think that that's an important tool for you. But the question is like, what's the next steps for you? How do you see this being part of the ways that you're going to ask and problematize architecture? Because to an outside audience, maybe even some of the audience that's listening to this conversation, they will have a tough time looking at the difference between is this a metaverse project? Is this this project? Is this a mobility project? Is this an infrastructural project? And I think that this is an interesting space for the program to be in, because in some ways, we have to somehow work through that. Those kind of conventions of like, this isn't a fabrication studio, this is something else. This isn't, just a parametric urbanism studio, this is something else. You're going to have to invent new terms of communicating this kind of work. And I think the presentation has been good, and I think the work has been rigorous. I think the issues of its production, I still feel, is in your domain. And I think it's something that's very important for the studio to push forward, because those constraints should be embedded in the architecture of that interface that allows those decisions to happen or not. And one of the things that I would just really have liked to see more is versioning. How do you push this to a degree, both locally and on a global level, where you really have to set up conditions that are negotiated that don't necessarily resolve themselves? Or at least maybe not resolve themselves in the way that you would anticipate. And then value judgment can kind of be explored in different potential use cases, because I think still we get to pick and choose the testing scenarios, which makes us feel in control of the system. But if you push it to a logical conclusion, you will have very different motivation behind using your tools. And that will potentially give you very different ways of negotiating a form of architecture. And what I like about this project is it is real on one level, but it still remains in the domain of virtual and leaves a lot to my imagination or anyone else's. So Patrick's point about the resolution of the different material processes are important because they also start to give communication value to the actual spaces. And those two different methodologies between printing and soft-cast formwork play, I think, a very vital role to kind of deal with this kind of nondescript material declaration of the renderings and the reality of its material contingency. I think those things need to be utilized more, because I think that that's part of your repertoire, that's part of the things that allows this to be somehow taken beyond just, let's say, a strategy for space making in the city into the domain of thinking about how these things could actually be a new form of production, new form of materialization. And time has been a discussion topic, and I think we all could agree that all of the studios are working with some form of time-based mediums, but architecture is really slow. And its resistance is interesting in that paradoxical conversation. So as you guys are kind of thinking about your project after this and post-DRL life, I think it's important to not see these things as series of different steps, some applied, some not applied. Like, let's say you would put it in a book and start to really problematize actually what the future demands of, let's say, even practice are going to be. I think we've had a very interesting conversation over lunch, and I'm sure that's going to exhibit itself in different ways. But from your terms, from your perspective and your lens, how you see this work relative to the others, how you see this conversation relative to the ones that we've had leading up to it, I think it's important. That's where the complexity resides. It's beyond, let's say, a 20-minute presentation, and this is a form. So I think as we move forward, I think the things is really iterate and somehow evaluate on the terms that you're able to help design, let's say, and prototype these tools that allow other people to take their decisions and focus on their motivations. But anyway, I think maybe...
Yeah. So I just want to pick up a theme that both you, Patrick, and Molly were speaking about. So voting is a kind of static structure. Even iterative voting is a static structure. And yes, indeed, there are logical limits on the adequacy, if you have a preference, getting all the preferences optimized. But the opportunity of political resolution in DAOs, those are quite different. So there is what you were saying, negotiation. Now, if you take negotiation, people are giving, and they're weighing, they're giving, but they're getting. And so there's a very different structure, that negotiated thing, which takes it out of the context of voting. Add what you said about versioning, and now suddenly there's the opportunity for thinking about how to weight different versions over iterative consequences, negotiate, I'll swap this one for that one. And I think you can get a completely different move, a different trajectory toward a design resolution because of collective involvement with different political and decision-making methods. So this is very positive and very opportune for you because it's a revision to the classical design process, even one that would involve crowdsourcing. It's different because the crowds don't talk to each other. But now they can. Anyway, that's all.
I think, yeah, like...
you move from voting, literature on voting theory, you have to move on now to literature on bargaining theory.
I think that's an important point to highlight, like that. I mean, I agree with like Patrick and Ross on the various lack of tectonic resolution on the the white images. Whilst there is that potential to take whatever the game process delivers, to take it and refine it further and resolve the paradoxes, as Theo mentioned. But one thing to, I think, highlight like is it's what does the gaming system deliver is a discovery engine. Like it could, in a way, it's a replacement for the so-called generative AI, right? Which is or at least a competing part, like where AI is a singular black box, whereas here it is something like a participatory process could deliver a certain level of intelligence in consensus, and also potentially how this thing can be financed. Having said that, like, so that is not clearly articulated in the presentation, whereby everything is given equal weight. So something to reflect and to consider what are your achievements. Like I do quite like these aggregations here, like very interesting because they reveal like this generative capacity, but like at the same time, if that it also it came out of a gaming process or a participatory process, which I think is very interesting. Like, but like you're not highlighting that aspect. Like, and so perhaps in your book, like you can reflect on this two-stage process. One is to discover, and then like kind of finally resolve it in how it'll be physically realized, right? Like, and so in that sense, the gaming representation could be less materially related, could be more spatially related, and so it doesn't need to have that finality which currently it seems to be showing. So maybe highlight that there is another refinement process that could be applied on top of whatever the game delivers.
It's just resolution and consensus is not always a positive thing, because sometimes that somehow normalizes difference. The only reason I'm saying that is that could also be exhibited in the section, not just in the plan. Right? It could be in the decisions that you guys are making to somehow enable conflict. Not conflict like you can resolve it, but conflict in terms of differences that are made meaningful but are not necessarily normalized. And that's where all of this kind of stuff goes beyond production and the social into something much more complex. I'm very time-keeping kind of character at the moment, so I think that this is a really good conversation and it's going to continue. Thank you.
Thanks.
Hi guys, welcome so much. And we are from Peer Studio, and our project name is Hydrospectre. And basically, the studio focuses on the nomadic living unit in a future of limited resources and amphibious environment, and large-scale interventions envisage the concept of soft infrastructure as a dynamic, distribute, and self-sufficient strategy for human habitation. And our team is looking at the surface and the variable housing unit in the water. And in the sea, people are able to carry out nomadic activities on a large scale and giving people more freedom to choose where they live. So the first part of the cities. In the past 30 years, the population of the world is increasing rapidly, and which leads to a series of problems such as the shortage of land resources and energy. And some Asian countries with high population density, such as Japan, has just tried various strategies to solve the urban problems and caused by land shortage and population growth, and have chosen to reclaim land from the sea. However, land reclamation also have many disadvantages, and such as the damage to the ecological environment and the water environment. So we, on top of the water, to create land. So we start thinking, instead of just filling in land on the top of the water to create land, and why not just make people living in the water? by building some movable soft infrastructures and in the water. And the conditions on the surface of the sea are known to change in different ways at different times and can even extremely dangerous and uninhabitable. So from a safety point of view, we have to have a housing unit have the ability to implement multiple environments. And so we choose Japan as a site and began to study the climate and population of the Tokyo area. And Japan's urban conflict series, the land area is insufficient and the metropolitan Tokyo population is dense. And Japan also faces frequently natural disasters such as the tsunamis, earthquake, and typhoons. And combined with the above problems, we began to think about the possibilities of building a piece of soft infrastructures in Japan's waters. At the beginning, we inferred the Tokyo Bay, and however, due to the large area of reclaimed land and the laying of waterway, it's not easy for people to live in the Tokyo Bay for a long time, so we choose the Sagami Bay, which is closest to Tokyo Bay. And Sagami Bay is close to Yokohama as well, and which is a satellite city of Tokyo. And the constructions of Sagami Bay here can play a role in increasing the population pressure of Tokyo. And the figure on the right shows the analyzed diagram of the air temperature, wind speed, and wave height of the Sagami Bay. So we can conclude that the water temperature environment of Sagami Bay is relatively stable and suitable for the habitation. And since we need to study the surroundings resources and supporting facilities of Sagami Bay, and these infrastructures provided the potential for the supply of some resources for marine life and for cultural communication. And just we studied a lot of references. Some of them are very huge and some of them are flexible and floating on the water. So our project needs to satisfy two aspects, the ability to transform and move freely. So first of all, the transforming architectural design can make buildings have more functions, intensification, and in addition, in order to better adapt to the environment, mobility is an important factor. And due to the location of the project in the ocean, we select a number of marine creatures to study the habit, and among which is the sleeping state of the sperm whales aspect of our interest. And the sperm whale float vertically in the water while they are asleep, so they can return to the surface for air as soon as they wake up.
Yes, so the second part, we go to the design drivers. First is the human skills that we know that design needs to be deformed. Since our design needs to be deformable, we need to know about the relationship between the human activities and the size they need. So we did a series of studies on the human skills. And here shows that the figure shows the minimal space required for daily activities as a person. And then it's an average family of 3 in this second diagram. And on this third, the diagram shows the minimal space required for 5 people and can increase with that, just like a whole space unfolding like the petal of a flower. And of course, we know that the minimal spaces are not really friendly to the user, so we're trying to find a way to expand them. And we try to extend the space along the axis and transforming the space into a larger size. Similar with when there's 3 users in the space, they each squeeze the space and towards the end, scratching the small space into the extreme large size, and it makes a petal-like space. And to make the space deformation, we're first focused on the scissor structure, which can expandably offer the possibility of the extending of the space. However, we found another problem that if the structure, the change of our strategy becomes the facade were too enormous. For example, the sharp change in volume before and after the expansion, and it will make the problem when it's interlocking with each other and to make the cluster. So we change our strategy into the fold and non-foldable. And we have therefore adjusted our strategy towards some deployable space by folding in a space that are less used or only used at particular times through the flow of the life and the frequency of their use. This allows the space to accommodate with a large number of people at the same time.
And then the next design driver is that we try to make our unit suitable for the different environments. So we make a research about the overseas environment, and we found that the overseas environment is very nice for for living. It have enough oxygen, enough sunlight, enough outdoor space, but it have one problem, is that this environment is very easy to influenced by the weather. So, but the down sea level environment is, although it don't have enough oxygen, don't have enough sunlight, but it's very stable. It's not very easy to influence by the weather, like typhoon or something. Next driver is self-sufficiency, and we make a research about the wind power and the cage farming, and we add this technology into our design about our unit and make it have a system to make them self-sufficiency enough and get the resource they need. So then come to our unit part. Including to what I told before, the overseas environment is not, it's very easy to change. So we got our mode about our unit. First, the first state is above water, and in this state we have two shapes. The first is fully unfold, and next is no unfold. This part has a different volume of the space that can be used. And when the weather changed and we need to go downstairs, we should close our paddle and deep down. What we did that is that we, in our, at first we have an airbag and make our unit can be forward over the sea level. And when we need to deep down, the airbag becomes smaller and come down quickly. This is our basic unit look like. Our basic unit, including three main parts. The first part is a core. The core is a minimal space that have the most necessary function for survival. So we make it smaller because we want to save more energy and more resource. So our furniture in this part have ability of transformation and can make a space used in different conditions. And it also have a bathroom and the working space. And the next part is the paddle. The paddle is a space that mainly including to the social activities, and the furniture there is also can be changed, can be transformed to make the space different, and people can do different things in this part. And third part is including to some power system and energy storage and the solar panel. That's why I told before we should close our paddle first and then deep down. That's why this simulation show why we did that is that when we in the open shape, it's very easy to shake by the wave. But if we close the paddle and it becomes smaller, it will be more stable and more safety, and the wave will influence it not very easily. And this is a video.
Yes, and this video shows the units how to going down. Yeah. And we 3D print the initial structure of the unit and connect the airbag under this. And this test result shows the monomer could float on the water stably while maintaining the balance when there's some weight on the bottom to restrain it. And we want to this airbag can be make our furniture or our surface can be moved, so it has the inflation mechanism. And we test the effect of different plane crease on the inflation effect. After the test, we find the shorter in the y direction, the smaller of the angle will form after inflation. And we also test the inflatable push scissor with the acrylic and LDPE materials. And we also use the Crane Digital to simulate the different spatial forms we can quickly predict their folding and unfolding effect, and which can use for design our room and
room shape. And after the series of tests, we can find that the most suitable shape of our pedals. And in this way, we settled on the crease and fit the living space deformation, this process that we can simulate by inflation at the living space from the submerged folding state to the unfold state. And this is the experience of the whole pedal. And when the unit is unfolded, they will connect by the tube, and we use the origami structure as the prototype test different creases. And this is the interface of the unit, and then we use it to create the cluster. And this is the 1:40 model, and it can open the windows and rotate along the track. And this is the side view of the pedal open and pedal close to the core. And we also do the 1:20 ratio section models, and there's many parts to interlock. And so we design many interlock for them. Yeah, and this is the render for R2. Shows the unit to move on the water. Yeah.
Yes. And for the interior space, we first provide a view to the sea. So we provide a lot of platforms for people to use. And this is the diagram of what people are doing and using spatial tracing when they are using the cores and the petals. And in the section, when the small wings are spread out, it will increase the overall living area by 60 square meters for people to socialize on the water. And when the petal is folded up, the floater folds over to create a space that can be used, and it is connected to the core space to create a new circulation. And this is a rendering of the interior space. And due to the shrinkage and the folding of the space, the furniture is divided into movable furnitures and fixed furnitures. This diagram shows the use status of movable furnitures in different stages and the space formed. And here's the three examples of movable furnitures. And this is the physical model of the section. We show the skeleton, space, furnitures, and the equipment by different materials and colors. Sorry. Yes, and this is the interior rendering where we can clearly see the use of the petals and the cores. Yes, and this intro video shows the use of another petal and a three-tiered platform. So based on the connection mode, we have designed a specific interlocking mode. First, part of the shell will fold up to form the roof as the joint, and after that, the remaining shell will expand downward to become the public space at the connection. In order to ensure that the connection is not completely outdoor, we use the retractable membrane structure to show this part. And this is the dynamic process of a retractable member structure and interlocked with each other units. And this is the two renderings. Shows that when two units are connected in this way.
And yes, to the collective behavior parts. First, we study up the residential cities just around the Tokyo to see the select the Nankono district of Tokyo as a core circle, and Kawasaki and also Yokohama as a reference subject in the urban circles along the coastline. And we analyze the different sides of the cities and to show the typology of the clusters, and to analyze that how our cluster may look like. That compared with the Sagami Bay, we found that the pattern of Sagami Bay with the scale of the block and the ratio of the public spaces, and each 10 to 15 units from the block and contains one public spaces. So
for the cluster, we have 4 special units with a different function, and these 2 big guys which can connect up to 12 units together, and the smaller one is up to 6. And they are the ocean farm and social platform, bridging platform, and the charging unit. And the way of connection, it will change with the change of the number of the units. For example, when the number is very low, they just connect by themselves, and the units become more and more. They can use another platform to connect together and get enough food, get enough power, and get some big public area and to enjoy their life. Sorry. And this is the first model. We try to study how our units connect together. And this is a rendering for different number cluster. And this is an animation to show how our special unit connect together with a basic unit. It's how our the whole cluster looks like.
So to analyze the mobility logic, first we simulate the behavior of these waves, and to find out how it can affect on our unit. So we divide the water flow into 3 stages. And when it's low, the spaces well separated and have enjoyed a large space for the private spaces, and we get medium, or get close to each other than the lower one, and the flow rate get rather high, they will dive into the water to prevent from the damage. And here is the different stage of the cluster we show. And here we divide the different driven of the mobility logic into the sightseeing attraction, and also the sea weather oriented. Like from the November to April, that's most people go sightseeing and enjoy the natural environment, and from the May to October, when there's a frequency and residential tragedy of local typhoon, we set exclusion of the point to simulate how the cluster will move. And here is show the video of that when the storm comes to Sagami Bay, how the cluster will look like. Most of the unit will dive into the water and to follow its wind. And it will just like a group of sleeping whales in the ocean. Yeah, and here is the model we make for the cluster, and all the units will divide into 3 levels: above water, in the middle of the water, and downside water. And here is the overall looking of our Sagami Bay. Thank you so much.
One, two. I seem to always get to start. Can I ask where you're all from as a unit? Where are you all from? Are you mixed? Are you Japanese?
No, we are Chinese, sorry.
All Chinese?
Yeah, all Chinese.
That's fantastic. You're faking that. I was completely fooled there. Do you need to walk and talk about the models, or are we not doing that?
Just one.
Sure. So the first model is that we made to use the crease to show how these petals unfolded when we make an envelope close inner space. That we can show that we can lock this kind of panel with our structure. And here is the very beginning tiles that we made that it dive into the water, and when we inflated this air bag, it can just go above, float it above the water to go outside.
As we watch the presentation, just maybe use this.
Yeah.
Let's talk about the project.
Okay. Okay, so here is the transparency one to show both the inner space and the outer space. And we can see that our petals here.
And then you can separate.
And can separate itself.
We can sew
the inner space here.
Yeah, the inner space.
I see it's a core in the middle side and also 3 petals, and for the 3 expansionable living space on the outer side. This is another half of it. Yeah, and this model we made is mainly to test the technology and the mechanism of the folding and unfolding, to test out the wheel here to make it rotated along the trail. And this one is that we actually to come to the inner space atmosphere and to show that how actually the furniture folded and unfolded will affect the people living there, to see that if it's work or not. And here is the 1 to 20 scales models that we made for different layers to show that how the machine, the space for the machine, and also the space maybe for the trajectory. Yeah, and also in the middle of the space is for the living spaces here. Yeah, the side model. And you'll see that all the units will rise into different heights, and it just to simulate that when the units will expansion above the water and they get close and to fold itself and dive into the water. Yeah. Here's to show the different kinds. Yeah.
I'm not going to have any conversation.
Okay.
Study models.
Yeah.
Anything else you want to add?
Okay.
Talk about the project.
Okay.
No, just from my perspective, that's one of the most poetic presentations I've ever seen. I think start to finish, the references, the natural references, but also the art in the presentation is very beautiful. It's got a high definition, a high resolution. I mean, I've been doing projects for years, but this is so complete. I mean, this is the work of probably 20 people. It's really so accomplished, and I will not be critical in any way about anything that you're doing here. I'm sorry, you have to get somebody else to do that, because I'm really sold. I'm an industrial designer by trade, and the way things have worked out, gosh, I mean, you've got to stick together as a Japanese team. Yeah, great. I got nothing else to say. I just want to say how great it is, because it's just really well done. My God.
Yeah, I agree. It's a very beautiful project. I have just one very basic technical question. When you are diving, and when the three floating modules are in fact not floating anymore, but they are put vertical, how do you access them?
That has been worked out, by the way, yeah.
Yes, actually we access them just when the unit is above the water from the petal. Then you can see that the petal actually, the front part of the petal can open itself up. And when it's get close and dive into the water, there is the door at the, I'll show you there.
Can you show us? Yeah.
Yeah, you can still occupy it when the floor flips over. That's quite a nice detail.
Here is the one of the petal, and here is the flipping wall.
Oh, okay. So we go through this door. Oh, this.
Designed in this direction.
Yeah.
This doors, and there has a trail, and it can just follow this way, and when it's rotated.
Okay. So from this level.
Yes, from this level. Both from
To
this
that
level
one.
and to
Yes, yes. Okay, perfect. Okay, great. So yes, that's amazing. That's beautiful. Again, I don't have much more to say. I just want to congratulate you for that. Yeah, beautiful project.
By the way, I love the visualization when the thing kind of starts sinking down and you see it through the reflection, and then you suddenly underwater and so on. These are very beautiful moments. I think it's very well designed. And I think similar to the previous project, I thought that the generating some kind of village or collective structure and having additional spaces to plug onto. I mean, it's a nice differentiation again with more utilitarian, the fish farm. Sorry, my phone is. And but I think there was still you paid so much attention to the individual unit, same like the previous, and somehow it's a bit abstract, and we don't get into how you occupy them. You go, the interiors you fully explored. We know how you go to outer space and you appear. But on the collective spaces, I think we left with imagining something, and I would wish to see more. The same attention, I mean, in the division of labor of the team at some point split off into developing. Also, make the character full. I know there are 3-4 different types of getting together. How does it happen and what it's like? Is it all outdoor? There was one indoor, which I didn't fully understand. So it's been a bit kind of an area which I think is quite important, because these are not some of the poetry is that you kind of together submerge and you together re-emerge and open up. And I did like when the guy come up to the top and is just standing there, but then you also want to communicate and share these shared spaces to explore them more would be really nice.
Just a very quick addition. Maybe one thing that could have been added would be the possibility to move in an horizontal direction while you are diving. And I don't know if it's possible here. I don't think so.
It seems that it's a completely passive system.
Yeah. So
it begs a question whether is there an active side of navigation to it, I guess.
Because if you can move in an horizontal way when you are diving, then you can imagine that you dive at slightly different depths, and you can really reconstitute a system of three-dimensional traffic, and then you can avoid this kind of traffic jam here. that you have on this image. Because think of the planes. I mean, the planes, when they cross in space, one goes a bit up, one goes a bit down, and they really cross in a fully three-dimensional way, which is not what happens on the road, and which is also not what happens usually on the sea. But if you are undersea, then you can really recuperate this third dimension, and this could be a very interesting development.
I have a question for you. I'm just curious about the turning points in your project. As you were designing, what was one point where you realized, yes, this is the right direction for the project to go, and what's the point where it didn't work? Because everything here is really neatly articulated and we understand some of these early versions. So what didn't work and what led you a different direction as a result?
Actually, we have made a lot of, Yes, actually, we made a lot of physical models and do a lot of try here. And here's the one I forgot to introduce. It's a very beginning one. That's at very first we think we can make a thing like the Rubik's Cube, and they can fully rotate all the room in this cube. But actually, we found that if when we both use the floor and the roof and all the wall there, it seems like we use all the space, but actually the furniture on it and also blocks the use of the users. Yeah. So then we want to just simplify our strategies. Then first to reduce the concept of Rubik's Cube, that no people actually need to rotate everything in his house. So it just to turn to that something like a flip. Just use two sides of the walls, and then we turn into something like a title, the flowers, and when it's blooming, it turns into this side, and when it's closed, we use this bottom side, just use these two floors to contribute to our inner spaces. And here is the logic of how we develop first from a sphere. But the sphere is a little bit restrict to its shape. If we want to change its shape in every angle, it will make too flexible to change. So we made something maybe in a vertical way here, a streamline. But a streamline is, with the Rubik's Cube concept, it's still too complex to finish. So then to simplify to the final one, I think. Yeah, sorry.
But I have a very brief question in terms of the extension, that pin or dagger down. I mean, I understand intuitively certain extension down is good for balancing, but shouldn't there be a weight or what is that? Can you motivate that or?
I was going to add to that, I think...
Maybe pianos. This one here, I'm talking about this sharp...
Yeah. Yeah. That a lot of the transformation happens through air, through inflation, deflation, and I wonder whether there's opportunity to, given that you're interfacing water, to actually be using volumes of water, and as you say, weights to balance and to actually actuate some of the transformations that you require by shifting liquid through your structure. Because you're interfacing, you don't have to, in addition, add the element of air.
I was done. Yeah.
I think you guys have come a long way, and I think you deserve all the praise. Because I think it's been a long path for you. You've tried many, many iterations to pick up on all these points. And this, I think, is the one that has kind of come full circle for you. The sphere is still there. It's the node that's rotating. I think it builds and pushes like Greg's kind of prototype house, with the rotation and so forth. So I think that there are many aspects on the unitary piece that I think you guys have developed a lot. I think Patrick mentions the collective aspect, And the collective aspect, I think, has a lot of work to really be something that's a viable part. And I think there's an intentionality there, but there has to be a certain kind of critique. When you have something that's like a piece of total design and it's quite complex, then replicating it and connecting it together just kind of amplifies the problems that you inbuilt in the unitary. And so these pieces that are transforming, they have to somehow also transform with the idea of population and other aspects, different activities that are not furniture driven. And I think that that's very important. So I think as you guys think about how this thing could evolve forward, or even how you guys also think about what you're doing, I think, you know, the compliments that you got from Ross are very meaningful, coming from somebody who has spent a life trying to deal with the kind of industrial design aspect of making. And I think that that's a sensibility that I think is an important part of your studio. I think I've expressed that many, many times. And I think the beauty of it is that the models actually start to demonstrate some of that stuff for you. So the one thing that's not so demonstratable is all of those failures. I don't see that as a bad part. I think that's where the research lies. So even bringing some of those older models and all of those older iterations starts to communicate that this isn't just, you know, you're good designers and this came seamlessly. Actually, we had a history of failures, but because of that, we got something novel, and I think that's where the poetry comes across. So I think from my side, you know, I'm thankful to see that from your side, because there was a commitment to it. And I think that that's just something that, you know, is something that you should be even more empowered and enabled to continue to do that, moving forward, as a group of Chinese students who are now Chinese professionals going out into the world. And I think I agree with Russ completely. You should try to do things together. And then the next steps about performance and materiality and all that crazy stuff that kind of comes and burdens all of us is going to creep in. And that's a good thing for it to happen, okay? So good job.
Maybe just a quick comment from one of your tutors. I have to congratulate you. I mean, picking up on the last comment from Theo, has been really a long journey, and you have been really able to, I think, address, you know, like some of the topics we discussed as a brief in a very intelligent way. And also the choice of the site, I have to say, was not given, and you found, you know, the right ecology where to deploy something that actually was in the process of the research in a very kind of meaningful and sensible way. So the poetics are very strong, and it's really, I mean, it's amazing to hear like Ross commenting on your project, and because you know, he's really like one of the best designers you can see in the panorama of the design today. So I think it's great to see how, you know, what kind of achievement you've been able to, you know, to show us today. So thank you so much.
Thank you.
Good afternoon. We are Team 3 from Patrick's studio, and our project name is Metaverse. So we will start our presentation now. The first part is for our proposal. In existing city, the expression of urban intention is always be restricted. People who live in cities tend to have a one-sided and broken sense of the city. In Metaverse, the city will have a lot of flexibility to break away from historical constraints. The general public perception of the Metaverse city will be distinct. We are exploring how Metaverse city forms strong and new urban images based on Kevin Lynch's researches. We compared with the real city with Metaverse to focus on what's the difference between them. And in our particles is important. It can be a language of our metaverse, and which can help people to have a stronger perception of our city. particles can come in different colors and shapes, have different functions. It can carry digital information as required by the functions. And it also can assemble into spaces, and moving particles can guide people to explore digital space. This part is for our city pattern.
The imageverse doesn't have to take the real geographical conditions into account, so we extracted and made a collage of terrains in Morocco to provide the users with different choices of landscapes. And this is the bird view of our terrain. By analyzing the slope, roughness, and the viewshed, we selected the appropriate settlement points according to Free Otto's theories.
As for our city pattern, we found there are some similarities between the occupation of a city and the particle movements. So, and also the particle can better interact with the site and occupy space more flexibility. So we make the particles move in different directions. We choose several urban centers in our city based on slope and landscape conditions. We use particle motion to simulate urban occupations. We have particles move in different directions. At the same time, the movements of particles can avoid obstacles in the site. We track the motion of the particles and use the trajectory to translate to our roads and blocks. And also for our second road system, we use some concentric circles to create these systems. Also, we control the density of buildings in plots and get our buildings. Next, okay, this is.
So, okay, this is the user customization system. We think users need a way of observing and customizing content within the platform rather than rely on a third-party platform. And so we provide a user customization system. Next, okay, I will show you how users can customize their buildings on Metaverse. There are different forms on different parcel, but the volume ratio is the same, which is controlled within a certain range due to the limitation of the user's virtual equipment and maybe the carrying capacity of the platform. The user then selects a parcel according to his budget and needs. Then after the block volume is determined, the system will provide users with specific details about the design of the building construction. The building facade is made of solid geometry and particles. Solid geometry can be changed based on the function. And next. And the particle also has three functions. Firstly, density of the particles change according to the degree of the privacy of the function. Secondly, because there is a flight system in our city, the building has a grounding point, so user can fly from indoor to outdoor through the movement of the particles. Thirdly, multiple buildings can be connected by particle, like generating the bridge, so user can customize the facade according to these characteristics. At the same time, the particle of the building facade, it is also defined by function, which is also for the integrity of the city and the navigability. The form of the particle serving business is a cube, and the color is a blue, and there are features of another three function. This is a configurator to provide the interior furniture design of the building. The building is divided into regular blocks. Then the user can select the units based on the number of the people to fill in this box. This is a display of the
the units can be divided into a dynamic and fixed shape. This is a dynamic unit, which means that users can change the shape of the units according to their needs. This is a display of the dynamic units with a different function, and these units can be selected when the required space and the number of the users are large. This is a display of the ceiling system in Unreal. User choose the. Okay, next. This is a display of the ceiling system in Unreal. User can choose a suitable puzzle to build according to the city information and maybe their budget. So this is the interior of the working space. Something you can fly in the atrium and to look at the different function space.
As for our central public buildings, firstly, we do some particle simulations, and we choose some results that can be used for can form our spaces. In this part, we try to combine the particle geometry and the solid geometries together, and they have different colors, which means they have different functions. They are be suitable for different functions. This is some experiments of the particle geometry and solid geometries. And also we make the particles move in vertical space. For our central plaza, we have some public buildings. We do some simulations. The different colors means different functions. And also we make the central of the plaza, we make the tower by make particles moving in vertical directions. As for this is for our plaza, we combine the particle geometry and solid geometry together to create new space. In plaza, we have 3 different spaces. The gathering space is for people to communication, and the art space is for some digital showings, and the leather space is for exhibitions. In first place is the agro in our plaza. This is for people to share their ideas freely, and also people can join some flying activities in the tower. In the central place, people can share their ideas and post their lives in particles. These particles can be some screens that it can show some digital informations. And there also are some moving particles that can lead people to explore the space. The second place is the concert hall. In this space, we try to make a test of particles with the voice. The different movements of the particles can fit for different music. And also we try to use different materials to create different atmospheres. This is the spaces. Let's join the concert hall. And the third place is for exhibition. People can choose different place to shoot to enjoy the immersive exhibitions. Okay, that is for Plaza. Okay, next is the section on the central public buildings. As these buildings are a combination of particle and solid geometry, the particles that continue from the plaza constrain part of the building's morphology, while the rest of it is controlled by magnetic lines. So the first is the NFT gallery. It is on the southeast side of the plaza. And the main function are displaying the NFTs and promoting NFT trades. As about the solid geometry, we analyzed the magnetic lines and extracted different prototypes to indicate different spaces. Prototype A is enclosures. They are more enveloped and private spaces. Prototype B is fragments. These are small spaces scattered throughout the interior of the building. Prototype C is arc space, which are large open spaces suitable for various big events. Prototype D is linear space, which is directional traffic space. This is the interior space of NFT gallery. The more special spaces in the metaverse gallery are the free trading room and the card collecting hall. The free trading room is a place for users to exchange NFTs. Both parties can provide an offer. After negotiating an agreement, the transaction will be completed. A record of this transaction will also be uploaded to the blockchain. The card collecting is an important part of NFT trade and therefore also occupies a large space in the gallery. Card collecting hall is a through-height space that allows the activities on the ground floor to fully attract the attention of the crowd. Okay. The next is the particle geometry. We found that the particle geometry can also serve as facade and temporary facilities. We have replaced part of the building facade with particles, and by control the gradation of the particles to meet different needs. Some part of the gallery can raise to create a more open, permeable ground floor space. And this is the particles acting as temporary facilities, and it can also be called out to form a specific facility according to special needs from the users.
Okay, this is a design museum. Because of time, we can just quick go through it. And also in the metaverse, we also want to have more flexible space in the metaverse. So such as the exhibition.
To understand surrealism, you have to understand Paris.
And also the virtual particles can be regarded as a kind of temporary building material in the museum to construct some temporary exhibition space. And also the particles in the entrance space could provide a shelter and guidance.
The next part is about conference center in the metaverse represent the
behavior of gathering and discussing group of large, medium, and small users. The conference is an opportunity to stimulate discussion among users. We use field lines to simulate and generate the aggregation and the influence of different space, and we extract spatial forms from field line and divide space through the aggregation of different forms. We try to, in space division of the building, there are 3 types of large conference space for 200 and 300 people. Medium meeting space for 3 to 5 people, and free chat space for 2 to 3 people. We try to think semiologically to let users understand the use of each meeting room. First, we categorize the meeting, including blue for work meeting, pink for commercial meeting, and yellow for cultural meeting. Then the dotted strip of light represent that space has been reserved. While straight strip of light represent the space is being used. When users see this information, they quickly understand what meeting is happening. When users entering the lobby, we can check the meeting are happening on the screen. And when the user walk to meeting area, we will see that the light strip and the glass are transforming into each other, which means that the meeting has just started. And the role of the particle here is the medium between the two objects. At the same time, we can easily distinguish the meeting that is happening from the light strip.
Okay, it's just a subcenter from our city, and it is along the seaside, and it is the interior of the commercial center. As for our landscape, we make the particle movements to guide people to take part in the activities in landscapes. Yes.
So we also have a small space for users to create their avatars. Next. So here is a lobby space where users, we want to give users a full impression of the city at the very beginning. So people will see the floating model of the whole city at first sight, and generally know that the city is multi-center structure and so on. And because of the lobby is that high, so also allows users to have a bird view of the entire city center. And we also prove some user interface. Maybe we can show in the next video. And also we have a recommendation system. Because data is more easier to access in the metaverse, so we have with the recommendation system, users will be able to select the features they are interested in, and the data for the suggested location will then show through the heat map and offer a direct link. And we also provide an activity map. The user can view the holograms and information hovering above the city when the event map is active, letting them know where the events are happening.
We divide the user's behavior into metaverse into 2 categories. The first is that the user knows this destination, and the other is that the user don't know his destination. And we think it's event that drive users to move. And when users know they want to join events, they can choose to fly, car, and teleport. For users who don't know the destination, they can mark a point in the map and then determine their own walking route according to the pathway or reselect the target point. We refer to traffic signs to identify each event. Each symbol has 3 elements shape. 3 elements: shape, color, graphic. Yellow and a rectangle represent work events. Blue triangles represent commercial events, and pink circles represent cultural events. And we bring those events into map so that users can clearly know what events are happening where. When we are in working mode, we can mark a point in the map, and this will appear on upper compass bar. And it will also display the distance between the users and object. Users can explore the road according to the road network displayed by the minimap at the same time. When we are in car mode, we select the current location to activate the car mode. And when we have decided to participate in the events, we can drag the car into some position to ride. Because of air traffic, we can see the field of view at different heights. In fly mode, we can mark the event after selecting select date. And even if we are in the air, we can clearly find the destination. Oh, sorry. This part is about teleportation. Yeah. And when users teleport in there, the element will disappear. So in fly mode, we can mark the events after selecting, and if we are in the air, we can clearly find the destination. And in fly mode, we can experience a different perspective than the real world to observe the city. If you want to find the detailed information of any events, the users can open the Explore button to select the events of which one you want. Okay, that's it.
I very much like the visual language that you've used, and I suspect that many of the people here are going to get into some of the choices you've made. I'm going to ask some rather critical questions on some of what you said here. And given that you're presenting late in the day, we're picking up on conversations we've been having throughout the day. And I have this question that starts with, what is an immersive exhibition in an immersion, right? So you are in an immersive environment. This is anyone using the metaverse is in an immersion. So what is it to be in an immersion? And what is it to seek information or inhabit information when you're with an immersion? What is it to be within a data visualization and interact with that data visualization when you're not just screen-bound like this or like this? You could be around it. And we've been asking these questions for decades in architecture and computation. Just a couple of blocks from here, Cedric Price had an idea for Oxford Corner House. There's a Primark store over on Oxford Street, and that was going to be the site of this multi-floor, 2,000-person information environment in 1965. And there were telex machines that would have cameras and information that people could walk through. But why? What information would there be that you would be getting and that you would be getting? So I have these questions about what it is when we're within the information that the information becomes. And then I find myself thinking about what it means for something like NFTs, because it's a very important part, and this is a metaverse that really celebrates the NFT, but I don't understand why it doesn't provide, and the particle flows, why it doesn't provide a means for creating NFTs that might be experienced differently than we think of NFTs right now at this moment. And this is at some point in the future. So in some sense, I think you're very successful in presenting a new universe, a beguiling universe, a beautiful universe, and yet very much stuck in Web 2.0 methods and interfaces and semiologies, where I think you might be successful taking the world you've created and changing those semiologies for us.
Yeah. Yeah, good question. So
there was a lot in there. I'm sorry.
A lot of things, but I think information is very important in our metaverse. The particle can bring it in this platform. when users want to share the information, the other can join this and can know.
But what's the information that they're sharing?
Oh, yeah.
Like what?
It's just like Instagram or Twitter. You can.
Well, that's a lot of different kinds. Oh, I'm going to get so mad.
Yeah.
I mean, has anybody here seen the TV show The Prisoner from the 1960s? What do we want? Information. You won't get it. By hook or by crook, we will. But information is information media. Is it? Yeah. I mean, information is what you give to someone else, and it's encrypted or decrypted by something along the way. What really is it? Because when you consider what the information is, then you have a means of what semiology might be, you have a means of what media might be, and you have a means of what experience might be. And I think that's actually, without answering that question, you are kind of stalled.
Yeah. From our perspective, we think the metaverse is based on a platform, just like just like Web 2, but what is more special in our metaverse is we want to create a friendship system. Like when we have a navigation system, and like my friend, which place does she like? Which place does she want to go? And she will create a map of herself. And when I have confusion about where should I go, I can just choose different friendship and choose the map they created and went in to see what place will make me interested in. Yeah.
I'm going to pass the mic to someone else because I'm hogging it, but I think that's an interesting idea of what happens with mental models being shared in a different kind of platform. And that's where you begin to get to when you apply the structure in the world that you've created to some of what you're containing within it.
Yeah.
Thanks.
Thank you.
Somebody take this from me.
I've got one. So I guess one way to come at, is this actually working? Okay. So one way to come at some of these hard questions is to ask what are the activities, particularly social activities, which people want to engage in. This is all maybe because we're in third person. I mean, it's a fake first person, so we don't get. But if you refocus your architects, so of course you have to create the environments in which people are going to act. But what are they going to do in there? So if you fixate on a collection of activities, and you define what are the kinds of activities. So you look at, for instance, the social interaction between a retailer and the person buying. What does that look like? How do the features, the affordances of the space, how do the features, the structure of the space, how does it facilitate that activity? And now you go, and then they have to buy it, and what's that activity? Like Apple Store, very good, because the way they handle the retailing purchase part, they come to you, they do it right. Okay, so that's a big deal. Now, all these different activities that people engage in, now that you've got an environment, what does the social interaction look like? That makes it special, that makes me want to go there, because presumably without people, people aren't going to spend a whole lot of time in the metaverse. So it's about people. People are about social interaction. Under what types of activity landscapes? What kind of things do they need in order to do these different, if it's a dance, for instance, suppose they're going to dance, do I get to define my partner, or do I have to take someone there? If it's do I personally control the music? For me, all of the kinds of details of the scripting would be, you don't have to do much of it, but just once or twice, I think will open up whole, worlds to explore.
I think at the present moment, since we're in an architectural institution, we should be focusing more on the impact of the physical space on how we perceive. I'm seeing something really profound here again, where it's the use of light, and if you want to have a full immersion, I think the use of a pixelated light environment generated from light as opposed to physical material is something that is very new. And its impact there, when you just see an image of the city, suddenly the city is incredibly fresh and engaging. And then, of course, you've got to go from the macro to the micro, and you know, that's a huge effort. That's a huge job. But what I'm seeing at the moment is addressing of some of the questions that were posed before about how you would physically feel. And when I do look at these, I'm looking at images through my own eyes. So I would visit, as Zaha always used to talk about, something otherworldly. I mean, to get something otherworldly in an age when there's just so much creativity and so much going on, it's a very difficult thing to step that up. And I think you've done that with this intensity of information, which don't underestimate the human being's ability to absorb complexity. We just haven't got there. We haven't gone anywhere near it yet in our ability to assimilate information. So that's my reaction to that, without going into detail as to how you download or engage with information, because that could just be a blink of the eye or a gesture. I mean, that can come, but it's too early, I think.
Fantastic job with these images, with these spaces, the dynamism, their layeredness, their depths, you know, and still we have a sense of orientation. All people are still vertical, and the dynamism is wonderful. And I would say, in terms of information, really what we're trying to display through our design, urban design, architectural design, is what are the offerings, where's what, who is gathering where for what purposes, these institutions, and that's, in a way, this, I would criticize the kind of graphic semiology overlay. It should be all spatialized. Take out all writings, take out all icons, and substitute them with three-dimensional characterful pulsations and character. You know, they can take over these same functional roles, where the city becomes its own map, its own description, because these things are designed deep, with, let's say, deep semiology, not appliqué semiology. And I sense that here. It's not. And in terms of the activities, of course, we have conference centers with various types of. We have workspaces which we're showing. We have NFT gallery. We're engaging with objects and whole swarms of objects. Like NFTs comes in groups of 10,000 these days, etc. So we do have that, concerts and so on. So what David is demanding is kind of hinted at, is there, is posited as different programming conditions. So, but yeah, I think where we have to kind of, in a way, the aesthetic is not complete enough, and it has internal diversity, but sometimes it kind of pulls us back into the world of cookie cutter, candy color, graphic world which we've escaped. And I congratulate you. I feel like Ross, I mean, wow, some of these things you're pulling off are really, really profoundly inspiring. But then there's a lot of these kind of pullbacks, which need to be edited out, 100% edited out.
But the functionality is substitute.
Can I ask something very quick? Just the question of haptics. Just the question of haptics. If you're within the metaverse, if you are somehow using a headset and handset, as you move through space, you can get nudged one way or the other. And then I begin to wonder, you know, thinking of the mental model or the mental map of your friend trying to get you connected to where they are. Can you feel your way there? Do you need to see it, or can you feel it? You nudge this way and it vibrates too much. You go this way and it's a freer flow. Your friend has their own signature through haptics that you begin to feel. So do you begin to have a kind of architectural experience that isn't visual as well?
It's like a magnetic field of gravitation.
Precisely.
Something is moving here, it's radiates, there's kind of attenuation, gradients, and then sound. I mean, there were very small, minor glimpses, but I think sound's going to be very, very important in the metaverse, as in the way the sound which is generated, the activity sounds emanates, but also other sound. It's like with all of the interfaces have now sound layers, which is very important. It's really moving from silent movie to full talkie with music underlaid.
Yeah, if you had sound and then you just had light and you had matter, etc., you're gonna get some architecture.
No, but he means acoustic atmospheres, that because there's auditory scene recognition. So part of what you can get through for navigation is you know where something is. You hear the sound. Where's the kitchen? Oh, well, I can hear it. So there's auditory scene recognition, and it's a big field of study, how people know what is where through sound. But
So we need the soundtrack for all of that.
no, you have to generate it.
Yes, no.
Yeah, I mean, I'm going to suggest a couple of things. If you do take the sound seriously, what's interesting about that is that it may necessitate that you deny the visual. You know, the one thing that's interesting about your particle world, it's like watching kids when they go out to see their first experience with snow. You start to see kids running around trying to eat snowflakes, but they are mesmerized about being in this kind of like little blizzard. It's like being inside one of those glass snow cone kind of things, whatever. And I think like that's the part where it becomes interesting, when you start to have a bit of mystery. I think the issue of information is, does it enable something? Does it really give agency to experience? Is that experience meaningful because it can become operational? And I think that those kind of things are kind of important. Like the issue of if it's real or virtual, I think right now, I mean, it could be a conversation, but I think the reality is that we're already so hybrid that we have to somehow engage and challenge some aspects of language. I'm going to keep saying this because I think we need new terms of engagement. I spent 2 days with Vito Acconci before he passed away. And he's an interesting character because I hear the word activities, and I remember he said something to the effect that he hated art, but he was an artist, known as an artist. Because he basically thought that the art never really had the impact. He thought of himself as somebody who wanted to generate exercises or activities. He saw it as in the world, situated, and that's why he actually migrated and started to consider himself an architect. Now here is somebody who is, you know, masterfully one of the conceptual artists, performance artists, moved through very different mediums in terms of using body, in terms of using space, in terms of using language. None of them really sufficed. So the reality of the metaverse, I think, is not singular. And I think maybe it's about shifting the attention from one sensorial apparatus to another. And I think that that's going to happen because there is a visual exhaustion in such an intense visual environment. There is a bodily affect that happens of just being in the metaverse. Switching off that and shifting it into a soundscape may be actually important, but not just like a soundtrack. And I'm saying that also because if you look at, there's been a lot of experiments in the, yes guys, I know. But you also have to kind of keep a little bit in mind, like there's been a lot of new media experiments over the last 30 years. There were attempts to make kind of interactive films with different narratives and you construct your own stories. There were always challenges about that because they somehow solely necessitated narrative to be the thing that somehow bound together the structure of experience. There's the potential for actually not having that linear structure, regardless if we have 2 or 3 different paths of storytelling. And I think here, for example, what I like about your project is at some moment you're dissolving those kind of barriers so that we could speak more about atmosphere. It's something personal to me, but I think that those kind of things, I think you have to highlight more. So I agree with Patrick about removing certain kind of conventions, textual conventions, icon-driven conventions, but also like the NFT conversation for me, it's much more interesting when you see that as a form of contract, not so interesting to me when you see it as a couple of thumbnails that are floating around in digital ether. I'm saying that because I think these things are evolving, and they are evolving with different kind of contingency to it. And I think that that is a space that people don't actually have any answers, but I don't think that you're supposed to have one. if you're trying to market something so strongly, you're not giving the opportunity for other people to make it their own. And I think that that's where you guys have to be striking the balance between curating, constructing, developing, but then also giving over and allowing things to emerge. So the particle system to me is like the weather system. Nobody controls the weather, everybody's affected by it. So if you could think about all of the affects of other people's interactions, not just your friend interacting with you, because that's basically what the whole social media structure is right now. My taste, my interest, what I want, who I want, and to be honest with you, it's really boring. The interesting thing about the physical world is that you have other things conflicting with you, and that's how you kind of get exposed. And I think you guys can develop a metaverse that has more complexity with that, in a much more non-linear way, more synesthetic, more exploratory. So I think you should be commended for it. I think the things that differentiate you from other teams is really that the particle has become a thing. But I don't think it needs to be like a piece of data that somehow has to be operationalized. It has to be something that you guys start to construct it, to have kind of multiple registers. And I don't know what that's going to be, but I can tell you it's going to have to be more interesting. You have to be more of a kid in a snowstorm.
I like that. One question I've got is why we're not talking about program. Has the notion of program fallen out of architecture in the time that I've been in academic administration? Because I find myself...
Only architecture has fallen out of conversation with architects.
This explains everything. But no, seriously, I really do come back to the questions of program that Summerson was speaking about in 1957. And maybe I'm the deeply digital person who's always saying what's old is new and what's new is old. But the question of program being a unity, maybe here we're trying in the conversations here to say atmosphere is the unity. But I do wonder about this question of function, information, narrative, storytelling, any number of other particles. Is this what we're calling it, or are we calling it...
I think the things that you mentioned, like which I think would be an interesting thought experiment for the students. How are they different to, let's say, Cedric's idea of information, experience, how architecture plays into that? I'm just stating that because I think like there was a certain idea of how that world was supposed to work and challenge the notion of information and architecture and activity, and that generation to me is much more meaningful because they didn't have the access to technology, so it was very free-form.
I think we all are working, we're all grappling with what technology, and I think in these cases what finance means, because I know that the question of markets or blockchain or NFTs, if we talk about contracts, if we talk about the asymptote work with the New York Stock Exchange, these are representations and simulacra of financial metaphors or financial immersions.
In parametrism, we've redefined program as parametrically variable event scenarios, okay? And that's the way this is also understood here and becomes visualized. That's what I also said. Instead of labeling up drawings, you bring in agent processes which form in different patterns, different configurations, and that's what you're framing. So that's happening here. I mean, and I think I wouldn't overemphasize, I do like market processes and I believe in the free market, and there's a new world out there where the metaverse allows us to entrepreneurially to create new interaction scenarios away from a lot of politics. But ultimately it's about end user experience, about use value, about activities, the programming, and to make that accessible. So if we have a huge new diversity of programs, it means types of events with various parametrically differentiated different audiences, how do you make them accessible? And that's why you either have a scroll down menu, or you pre-know them, or you have keywords, or you browse a space in which you use all your senses and intuitions
and have this kind of, let's say, dynamic spatio-visual morphological semiology instead of an icon semiology. So that's what's the vision of that project is. But it's not about selling things, not about economics at that point. It's really about generating that usefully, of having productive, meaning communicative lives to the fullest, and participating as much as we can, learning as much as we can. And but here is not about, the initial cyberspace was about, like a library, information, navigating. That could be part of it, so the exhibition parts of that, NFT kind of worlds navigating, but most of it is about finding each other, finding events, finding like-minded people, finding all the offerings in which I can participate in a real-time communication. I think that's what Web3 is largely about, and what's make a difference from Web2, which is more about the except for the social, it's updating on Zoom and Facebook and so on, and making it more real time. And although, yeah, that's what I think this is becoming.
I think we leave it there. I think if anything, some of these larger companies and corporations should be afraid of you, because with no resources, in Georgian Terrace, you've got 5 kids putting together a vision for what the metaverse could be, and I think convincing. And the more convinced you are about sort of constructing alternative models, the more disruptive you'll be, because the tech sector is falling apart right now, and they are hungry to figure out new ways of thinking about things. And I think that's part of your job, to kind of think about where you guys are going to situate yourself in the next iteration of kind of entrepreneurial kind of exploration or architectural, however we want to define it these days. We're going to leave it there. We got 2 more teams, so help us take down your panels. Thanks.
Thank you. We are Halokinesis from Studio Spiropolis. I'm Maya. I'm Kay.
I'm Seth.
I'm Edge. I'm CY.
Halokinesis is an architectural endeavor which examines salt crystalline environmental phenomena in the service of sustaining life on this planet. The idiosyncratic self-binding nature of crystalline growth means that there is a distinct difference in shapes presented in accordance with their environmental growth. Salt, an essential and abundant element on Earth, is known for its ubiquitous flavoring and preservation while also denoted as a balancing agent. Our halokinesis relies on time to achieve strength and formations. Salt tectonics, halokinesis, and crystallization are typically referred to as existing within the geological timescale within the history of Earth. The elemental is focused on salt, a commodity around the world, by appropriating the origins of salt production processes, both natural and artificial, as the focus of our experimental manifestations. Salinity varies across the globe, presenting itself through a variety of landscapes. The oceans contain a virtually inexhaustible supply of salt, situating our projects within an endless container. The spicule provided an inherent design capacity for interlocking, allowing for fluidity, a dynamic, ever-changing, and adaptable system. We explored iterations of the inherent design, applying agency while still maintaining its natural chaotic behavior. We identified the structure as an underlying secondary vessel for salt growth, as an irrepressible and self-binding element with its own chaotic nature. Investigating salt's effect revealed coral as requiring a salinity rebalance within its local ecosystem. Coral reefs are vital, acting as an urban area and supporting over 1/4 of all marine species. Currents throughout the ocean provide a means of movement, causing detriments in areas susceptible to exterior forces. The environmental impacts of freshwater runoff was explicit within coral reefs, being vulnerable to increasing extreme weather conditions and climate change. Salinity deficiencies proved coral as inhospitable environments for symbiosis. We explored providing a deployable rehabilitation system utilizing salt with spicules as its vessel to temporarily relieve stress on vulnerable coral ecosystems. In order to create a stable salt structure, we need to impose a phase change of the element. Crystallization occurs when warm water breaks down salt particles Na and Cl. These particles restructure in a crystallized formation and continuously grow in a stabilized warm environment. Salt crystals come in different forms, including the mined state of magnesium sulfate, the artificial state of sodium acetate, and the naturally sourced state of sodium chloride. Each crystal presents different geometrical growth formations characterized by their atomic structure and ionic phase change. Simulating two-dimensional idiosyncratic crystals, we set up a cellular model with an initial state of a seeding point, ultimately defined by the makeup of atoms. Edge-to-edge neighbor conditions form growth fractal patterns catalyzed by specific beta and epsilon inputs. Halokinesis is defined as the movement of salt in salt bodies, similar to the movement of water. It is the study of subsurface flows of salt as well as emplacement structure and tectonics of salt bodies. Another term used to refer to the study of salt bodies and their structural formation is salt tectonics. While salt flows influence geological tectonics through the creation of structural traps and reservoir distributions, it also serves as a basis to fluid migration around the world. These structures are categorized into tectonic typologies defined as canopy, sheet, wall, teardrop, stalk, and anticline. Each salt tectonic typology is defined by certain environmental inputs in a given region of the world. Mainly, the subsurface pressure and density of the Earth catalyze a variation of formations, creating unique shapes and surface penetration. The effect: simulating this phenomena, we inputted initial and surface state pressures, as well as rock densities, which defined generic cylindrical tectonic. The effect of halokinetic structures on the Earth's crust leaves impressions which are marked by the pushing of local tectonic plates, creating a fracture which is filled in by salt flow. Ultimately, these tectonic typologies yield a wide variety of results dependent upon its local region. However, the ultimate properties remain the same. Those properties are determined by the stability of the halokinesis as well as the potency of the salt. Salt tectonics typically penetrate the Earth's crust at a depth of negative 8,000 meters and continue to find the most ideal open cracks to permeate through. The typologies of salt tectonics are mirrored by the topological typologies of tectonic plates. Due to the occurrence of these halokinetic structures at the tectonic plates, their penetration is amassed at water body regions, which furthers a crystallized above surface formation, which we see as salt flats, salt lakes, brine pools, and more. Over millions of years, these geological formations have produced an abundance of salt, later to be discovered by anthropocentric necessities and harvested for use. Analyzing these source points in salt tectonics is critical to understanding how to engage with large-scale salt formations and utilize the inputs of pressure and density into necessary outputs that will be employed in the project.
Our halokinesis relies on time coupled with responsive scaffold growing crystals to achieve strengths and formations. The first tests we did were 2D and 3D grids made out of powder-free plastic filament. We also tested 3D grids with different types of strings and yarns and wools. From these models, we learned about the self-binding properties of salt crystals, the hardness and stiffness it provides, how it works better under compression, and that salt crystals grow more in the intersections. After the previous explorations, we understood the growth parameters of salt crystals, which are high salinity levels, high temperature, stable water level, and scaffold with intersection. By applying a control variables approach, we have attempted to examine the importance of different variables to then gain a detailed understanding of the properties on the different types of salt. As our scaffold, we chose spicules. These are small skeletal elements of most sponges. The meshing of many of them serves as a skeleton which provides a structural support. They can have a collective behavior, and the shape itself generates porosity when aggregated. Most spicules in themselves have a very stable centrosymmetric form, which in our project would give the structure a better performance on holding different shapes after aggregation. When exploring this structural element, we studied possible mutations and classifications. To continue the exploration of the spicules, we tested several other possibilities outside the natural shape of the sponges, iterating the number of axes and end mutations to test segregation. We learned that when numerous spicules are entangled with each other, they form an interlocking structure that is robust. Solution-related parameters mainly affect the speed of crystallization, while then later affects the form of the crystal structure. We tested sodium acetate, sodium chloride, and Epsom salt solutions on metal, plastic filament, acrylic, and plywood. Our conclusions were that salt crystals grow onto all the materials, but more onto the ones with greater porosity. We tested all three solutions onto these materials to test the self-binding properties of salt when aggregating the spicules. To build our models, we tested formations of spicules with magnetic fields. We realized it does not work because spicules have an inexact formation, and that is the beauty of the aggregation of them, that still interlocks at different levels while being stable but inexact. We did structural tests as a selection criteria comparing different types of spicules and how the shape affects the strength of the formation when loaded.
For this crystallization experiment, we used magnesium sulfate as our phase change crystal. We were able to form a cave-like structure with a compressive capacity due to the self-binding nature of both the spicule and the salt. We then explored a bridge-like structure by organizing the spicules in an arching formation. The magnesium sulfate crystal catalyzed a strengthening agent, allowing for the arch to withstand itself. Here we replicated the formation of salt tectonic typology, the wall. This provided proof for a vertical efficiency of the crystallized spicule scaffold. This one was the strongest of the 3 small tank experiments due to the use of naturally stored sodium chloride and the density of the spicules. Our first exploration within the boundaries of a large tank provided proof of scalability of our formations. To provide a binding point for the crystal seeding, we scored the acrylic, furthering its supratemporal growth. Using sodium chloride, we organized 300 spicules, which ultimately crystallized and bound together at various intersections. This experiment was where we began to understand that crystallization grows fastest above the water surface. Within this large tank formation, we used a more porous material, being plywood, which absorbed the solution, initiating seeding at a rapid rate, inciting increased growth. This formation utilized a 3D geometry spicule, which allowed for more surface area for crystallization. Over 12 weeks, the crystallization above the water surface grew to over 200% of its original surface. Over a period of a few days to a week, we were able to visibly observe the crystallization and growth of the salt onto the scaffold. As more water evaporated from applied heat, more growth would occur. After various explorations of spicule research and tests, our optimization has come down to shape, resulting in the amount of arms necessary for salt to grow onto. After simulating the crystallization of a pyramid, cube, and dodecahedron, we realized the dodecahedron has the most surface area to grow salt, meaning an increase in seeding opportunities. Further optimizing the spicule, the end mutation of arms was key to catalyzing and locking and interlocking of the spicule within a system. While keeping the integrity of the interlocking, the testing of a single bifurcated arm and the crystallization to surface area ratio has given us insight into which end mutation was most optimal for a spicule. The first iteration began with simplified 2D geometry, intersecting at its perpendicular. This proved useful for initial crystallization experiments on the self-binding nature of the spicule and salt. The spicule is upgraded to be generated from a 3D geometry with attached arms at each node of the form. This allowed for more surface area in terms of crystallization seeding points. Applying agency became integral to the spicule design, meaning catalyzing and incorporation of pneumatic elements within the behavioral formation. Ultimately, the reasoning for the spicule was to incite and create better performing growth vessel. Providing meshing to the spicular surface allowed for a porosity that is necessary for the penetration of saline solution as well as coral growth. The less dense the mesh iterates, the more salt can penetrate the agent and propagates to its maximal potential. Due to the evaporative properties of the surface level water, salt grows and solidifies faster above the surface level and slower in saline water. This informs the harvesting input of our salt crystallization system. The final spicule is composed of a core which contains sensors and mechanisms for behavioral organizations. The spicule includes 16 bifurcated arms, 4 buoyant pneumatics, and 50-50 ratio mesh surface.
We built a prototype as a control system for the behavior of the spicule. With this prototype, we wanted to explore the properties of an individual spicule as an agent to then test the communication between them. For some situations, there are variable inflations. The spicule showed different stages of inflation based on the interaction between them. Based on those behaviors, we began to prototype interaction and response. Each spicule is equipped with an ultrasonic sensor which detects neighbors for it to sense the other spicule when aggregated. The output is shown with white light when it's not sensing another agent and red light when it is. This activates an air pump and an air bulb inside of it, depending on the input of the sensor. The bulb will keep the air in or it will release it depending on the edge condition that the sensor is perceiving. So the pneumatic arm has a greater inflation or not. When designing a system for the pneumatic arm, the idea was for them to unfold and grip. We tested the deformation, muscle, and inflation through different number of ribs, shapes, and thicknesses. With several physical tests, we tried different spines and cavities with inflation, with various positions to achieve the function, buoyancy, and inflation we were looking for, emphasizing the grip between them. These are some isolated studies of the location of the 4 pneumatic arms in the spicule and how the orientation provides different results. What we learned from the previous studies was then tested on our spicule prototype, which is inflating according to the input of the sensor. Here are 2 spicules communicating to get a better understanding of interaction between them for the different situations.
Our halokinesis relies on an artificial cycle coupled with natural processes generated through necessity and constantly responsive to environments. We identified 3 main stages within the cycle: harvest, migration, and protection. Harvest deals with crystallization of the speckle agents in higher salinity zones. Migration then is the process of transporting salt structures through current dynamics and self-propulsion. Protection employs formational agency in low salinity coral reef zones, adapting to coral structures as barriers and dispersing salt. The process is cyclical, allowing for the agents to detect their next location to begin the system again. Within our system, agents detect high salinity regions where they can crystallize through the initial state of seeding points. Warm temperatures and surface level evaporation cause a growth of the salt on our scaffold, eventually solidifying into salt tectonic. We mapped the salinity levels around the globe and discovered regions of high salinity where we can determine ideal harvesting locations. Salinity levels throughout the year are different, which informs our time parameters. Analyzing a water column was necessary in understanding ideal zones. These ideal zones consist of the overlap between stabilizations of temperature, salinity, and density, meaning the change of inputs between 0 to 200 meters does not vary too much. We identified sites of higher salinity nearby intended areas of coral rehabilitation. These higher salinity zones consist of saline or brackish water, mostly existing in coastal zones, and include salt marshes, estuaries, coastal lagoons, and atolls. Ocean currents are extremely important parameters to explore in the oceanic environment. We simulated the behaviors of passive agents with a static current field, meaning that currents are not changing over time in this instance. We found that the agents will generally form linear or circular clusters. In reality, though, the oceanic environment is variable in terms of weather condition changes, temperature, air pressure, and more. Therefore, we simulated floating agents within this dynamic current field, finding that they will generally stick to larger circular clusters, emulating ocean current gyres. The rest of the simulation run throughout our project are in this type of current field, ultimately setting up the dynamic nature of our agents with the project. Within the harvest stage of the cycle, we isolated behaviors such as cohesion between agents, buoyancy, and steering as necessary in salt harvesting and formation. This is important because in a harvesting state, the structures will inhabit the water surface for the most part. On the agent scale, we explored different inflation ratios within the pneumatic arms. These ratios are in relation to the bifurcated passive arms of the spicules and are calculated based on output behaviors. For example, negative buoyancy refers to an agent whose pneumatic arms could not hold its own weight and therefore cannot rise to the surface. This is an important ratio, though, as we need the ability to move down and up within the water column. We extracted the necessary ratios for our system's behaviors. The pneumatics isolated inflation ratios are translated into the 4 different phases of a spicule's behavior. Further, to avoid the solidification from crystallization, a pneumatic can continuously pump air in and out. Each spicule holds the capacity to engage in all phases. For phase 3, the pneumatic inflates with air and releases the air out the back, ultimately propelling the spicule and its counterparts. It can then refill at the surface of the water. We explored the self-propulsion behavior, isolating path type and agent count in relation to passive spicules. We explored harvest phasing in situ. The harvest stage is unique to the rest of the cycle as it employs non-crystallized individual spicules to transform from individual to colony. The 10-time inflation is able to carry the weight of its own spicule. The 20 times inflation is able to carry itself and a peer spicule. And the 30-time inflation is able to carry itself as well as peer crystallized spicules. Further, as the prototype described, the red indicates passive or deflated, and the white indicates active or inflated.
Simulations were run in the area of 100 by 100 kilometers, and the sphere showing is a representation of 100 agents, while white and red represents the phase of inflation and deflation. We developed formulas to calculate the buoyancy of the agent with 2 variables of mass and inflation phasings. The first rule we set for the harvesting was when the agents are sensing more than 30 neighbors, they will deflate and vice versa. The activated agent will provide buoyancy to hold itself and the mass of its neighbors. Since the crystallization process initialized at the intersection point, we introduced another behavior, which is cohesion. That means all the agents are moving towards their neighbors in their own search radius to create clusters. This behavior will maximize the seeding point as they're traveling on the ocean, which leads to an accelerated salt harvesting. Another essential behavior is high salinity seeking. Agents are equipped with salinity sensor, which enable them to be aware of this value in a certain radius and move to where it's higher. With ocean current acting like with ocean current acting as a macroscopic searching force, cooperating with the self-proportion force of salinity seeking, they are able to create meaningful harvesting formations. We ran variations of simulation with all the agents' behavior of harvesting. Result shows the significant influence of the dynamic ocean environment to the agent movement. But with our rule set, the formation can keep the center area relatively stable for the salt to grow. We conducted physical tests by recreating the result of the simulation with actual inflated and deflated agents and crystallized them. We discovered with time passing and crystal grow heavier, it will reach a point where the pneumatic on the original agents are not strong enough to hold the mass and the whole piece will sink. So we went back to digital simulations to look at this problem in a 3D way and introduced another rule. When an agent in its search radius, the majority of neighbors are underwater, it will autonomously change its neighbor rule by which the agent decides its own pneumatic facing, which means collectively speaking, when the formation is sinking by the mass of salt, more agent will inflate to provide buoyancy. This strategy gave the system the capacity to self-regulate in order to stay on the top of the ocean. We run high population simulations with these rules and in relation to time as a parameter for salt growth to optimize the harvest formation. Calculating with the formula we developed, the time of harvesting on the surface would be around 30 weeks, which can be translated to a ratio of volume between agents and salt, which is 1:4. Agent senses and moves independently, but with colliding interlocking property, neighbor communication and cohesion, cluster movement with collective intelligence start to appear. The agents on the edge, because they have less neighbors, are more likely to inflate and hold the whole formation. This strategy will release the space taken by the pneumatic for salt to grow and also speed up the harvesting process. After harvesting, the agent will migrate, carrying the salt crystal from the high salinity location to the coral reef area. They will be able to read environmental data, making decisions on movement on their own. We use the result from the harvesting to spawn the agent for the migration simulation. The agents are equipped with the intelligence of sensing vertical distance to the seafloor and move towards with smaller, because the coral reefs grow near the coastal area where the water is shallow. The color sensor will scan the seafloor. Since the terrain, healthy and bleached corals differs in color, we set up rules for them to move to white color, which represents the bleached corals. Since sensors has limitations on radius, in some scenarios, the formation might speed up, but all of these salt iceberg will reach its own destination, which is decided by the collective movement. Again, the result varies from the dynamic environment the agents are facing. With the rule set, agents are able to self-regulate and get to the low salinity area where we regenerate the bleached corals. Steering behavior also creates hydrodynamic rotation, which enable the cluster to ride the current and reduce the energy consumption in this long-distance migration. While traveling, agents on the edge might detach due to the water erosion, but that's in the nature of our system. With intelligence and actuator in every automatic agent, they will make decisions to move on its own responsively to the environment.
We mapped coral bleaching around the globe to determine our areas of need. These regions will be determined for our protection stage of the cycle. Bleaching varies during different durations of the year. There are many environmental factors contributing to coral bleaching. However, a key variable more recently acknowledged and experimented is salinity. When environmental events such as monsoons, hurricanes, and typhoons occur, a sudden influx of fresh water causes salinity to decrease from an average of 35 parts per million to as little as 10. These events typically occur in coral habitats. This sudden change is shocking to coral, creating imbalances and ultimately cause the symbiotic organism, zooxanthellae, that provide coral 90% of its food and its color to leave the coral host. This causes the phenomena we know as bleaching. Bleaching does not mean death, and if conditions return to normal quick enough, the zooxanthellae will return. But if not, coral is left as merely a skeleton, later covered by algae. Coral classifications are based off locational characteristics, including land adjacent, offshore, and even isolated in the ocean. It was necessary to identify these classifications to better orient and organize our formational systems. We identified the spicule as a vessel for growth, so we extended that to coral growth as well. During protection formational agency, passive spicules will drop to the seafloor, allowing coral more opportunities for growth and polyps to attach. A major input to coral growth is decided upon the direction of sunlight in the ocean. Coral needs sunlight to grow, and its photosynthetic properties are an input we are including for the organization of our salt dispersal system. Regarding our coral protection sites, we isolated 2 main areas of need as examples for our rehabilitation proposal, including the Caribbean and the South Pacific. Each site was chosen based off its distinguishing coral and land characteristics that are meant to represent typologies of scenarios. These sites explore coral colonies within an oceanic island reefs and continental reefs, isolated as fringing patch, barrier, and platform classifications. The topographic situations of coral colonies and parameters such as temperature, humidity, and salinity influence coral configurations and our formational rehabilitation.
After migration, we started looking to the protection of coral. So our agents will self-organize as an ever-changing formation that balance the salinity level and reduce the harmful influence caused by rapid climate change. Learning from the salt tectonics, we basically translate the pressure and density into buoyancy and cohesion force. With information from the neighbors, agents would behave collectively and forming an autonomous cluster. Here we tried several simple geometry as initial configuration to simulate the general formation, from lines to triangle, rectangle, circle. Basically, when we added the sides, finally using a circle as image seed, we can see a mushroom column structure emerging, which also exists in nature. On the basis of our neighbor rule and vertical movement, we try to understand how our system works by itself with Arduino parts. We built up a 10 population setup. Each of them has data input from their neighbors and make decision of rising or falling according to their neighbor situation. The robots in the middle drop first as they have more neighbors, but finally the group will find a balance by themselves since they would have less neighbors when they drop and vice versa. After that, we try to introduce the environmental input that our agent could get locally from the site. The first would be the getting data from the terrain. Agents will use several ultrasonic sonic sensors to get a local height map. And as the color getting redder, that means the topography is more depressed at a location. And agents would apply different neighbor rule when are floating on top of those white dots, which represent the anchor position as the most depressed ones. So those positions would be better to hold the passive agents in position. And the system would drop this passive ones to create columns at those places. By using color sensors to detect the bleaching degree of corals from blue to red, the color getting warmer represents the coral colonies are more endangered. Meanwhile, corals that have been detected would be attractors for agents to move towards, but also as repeller when agents are getting too close to them. Here's the high population simulation at an island in Caribbean Sea where the coral surrounds the island. And as a barrier, we can see obviously from the front view, our agent is analyzing the terrain and self-regulating to change phase in order to drop the passive spicules to the bottom for coral to grow on. The yellow ones represent the passive agents that have 1/5 of the whole population. From the top view, it's clear that agents are moving closer to the blue part, which is the healthy coral, and keep certain distance from the red ones in order to not breaking any branches of those since they are already endangered. Afterwards, we took one frozen moment when the ever-changing formation reached the balance and generated the mesh of this formation with salt growing on them. The phase-changing process here shows how the reconfiguration happened, even with salt growing on the spicle. The pneumatic parts inflate and deflate, which gives the agent an opportunity to unlock and interlock freely. And then we did 3 more simulations on 3 very different sites. The system is adapting to the topography and coral situations, applying same behavior, but ended with very different formations as an environmental forces change. For example, for the first one on the left, which is in South Pacific with 12,000 population of agents, distance between the 2 coral colonies is only 1.2 kilometers, which leads to a floating landscape as infrastructure that connecting these 2 sites. We try to print this model to see the formation clearly, because we can see the column structure connecting the top and bottom formed by passive agents. And from the top view, we can also see how the dynamic current field influenced the system's self-organization. After getting to formation, the passive agents would sink to the bottom of the sea and disperse salt to balance the local salinity level at the level that coral grows to regenerate the coral and also providing shelters for sea creatures thriving to live in. So here is like we're showing the section part of our formation. We can see obviously since the salt is dispersed underwater, there's a difference on the porosity from the top to the bottom. Here's the 4 sites we choose in South Pacific, Panama, and Caribbean Sea. We can see it's not paying.
Just talk, it's fine.
Yeah, the system is adapting to the environment and also trying to strengthen certain functions of the coral reefs that they are already offering to the ecosystem. With our system actively getting involved into the global salt cycle, we hope to see the reviving in local coral ecosystem after several generations of agents working together, adapting, reacting, and influencing the environment. Thank you.
Thank you. So here on the end is the first model I want to just point out. Right behind Stefan, right behind here is 250 count spicule formation. The important thing to note is that the materiality of the scaffold is scaled, but the material of the salt is not scaled, so it's 1-to-1 scale. Here is the 2 prototypes of the spicules. These are 1/5 scale of the real size. They include sensors and Arduino parts in order to understand and react to each other and inflate in each arm. Over here is the time scale of how long it would take for just a single arm of this scale to crystallize. So in 10 days, this is the amount of crystallization that occurs, especially because of the meshing of the arm. Over here, we have an example of the crystallized salt tectonic made out of the spicules. That was important for us to understand how we can recreate natural geological formation of the salt. This was our large tank formation before we did that one. We took it out of the tank to see if it would actually be able to hold its structure, and there are parts of it that retains its own shape. And then finally, the last thing I want to point out is these 2 models over here. They just show that there's an opening below the spicules and the salt, which when you push against it a little bit, there is still some sort of compressive behavior to the salt and the spicule, which was important for us to know. Thank you.
Here I go again. I'm not touching anything wearing this black. Well, I do have some practical questions. But first, I think the models and the whole research is beautiful. I think it's really, really intelligent, beautifully presented, and also what you said was very clear. Now, the thing for me is, you know, I've got lots of questions for myself, like, you know, if coral grows in particular regions, why is there a salt deficiency suddenly? What is that caused by?
So those regions are areas that incur a lot of tropical weather, such as monsoons and all that. So all that fresh water decreases the salinity locally in that area where the coral is.
Is it through kind of evaporation or just being dispersed?
Just by dispersing more water, by bringing in an influx of so much water.
Yeah, but that's not a new thing, is it? I mean, that's been going on for millions of years. So why suddenly the problem?
Well, it's a lot of climate change.
This is El Nino, the heating up.
Yes.
And what does that do? Does that then evaporate the salt? Or?
It creates a equilibrium within the water. So that means the amount of salt within a water body is decreased. The ratio, basically. Saturation, yes.
Which is I just find it strange that nature does not naturally compensate for something so important for the whole ecosystem. So, you know, would nature let those reefs diminish? Would they allow that? Would nature allow that? You know, without some other force coming in as a compensation. So it's just a... Right, so sudden. Yeah.
And then you get this, and the
it's sort of catastrophic, yeah.
So, yeah. Some are adapting and they're coming back.
So why are there parts of what look like the mid-Pacific, mid-Atlantic or whatever, why do they have such high salinity? Do you know?
Yeah, I think that's related to the weathers also, to the climate. And yes, and the salt tectonic, which we mentioned, is the natural ways of salt movements in the Earth.
But does that create some benefits for those regions of the ocean?
Well, the North Pacific is called the ocean desert because the salinity level there is so much higher than the other part. And we were actually looking at those areas for harvesting, but then we moved to another site, but the ocean desert means there's less creature there because the salinity level is not suitable for creatures to live.
Okay, now the big question is, I don't understand how they get from these regions very specifically to, you know, zones, specific zones. How do they, where's the embedded intelligence that it's not just a drift, is it? It's otherwise that would happen naturally to some extent. So how are these agents, how are they, I missed that, I couldn't, sorry.
So basically the harvest part and the coral, the region where coral is bleaching, they're not like too far away. So actually the first we're kind of releasing all the agent and they're going to find the higher salinity part continuously and they're going to exchange information in order to find a locally higher salinity level point. And after that, they're going to come back to the coastal area where most of the corals use the self-propulsion, basically pumping air.
Naturally.
Yeah, and after that, they're going to scan the terrain in order to go to the part that's like the water level is getting lower and lower, basically going to the coastal area, and use the color sensor to sense the coral.
Okay, and what is the material of the, is it a 3D printed skeleton that you're using?
Yeah, we're thinking about to use plastic, things like the salt is kind of preserving the plastic, and also since all the salt is going to create kind of a creep on top of the speckle, and the microplastics is also not going to be released to the ocean.
Some of those regions where you have high salinity, they also have huge pools of plastic pollution.
Yeah.
So
why are you not filtering it out of the ocean?
Well, part of it is that, part of it is that when the crystals are harvested, the salt crystals are harvested onto the spicule itself, there's the salt actually like enforces and contains everything that's within it. And so we found that, like, for example, with metal, salt corrodes metal, which it releases back into the ocean. And same with wood, it degrades wood, so it would also release back into the ocean. But with our studies, we found that actually PLA, it stays like in its original form, and it doesn't release any microplastics
I can
from it.
understand that you're encapsulating whatever
Yeah.
the host material is. So in a way, something that we could find negative, i.e. a polymer, it doesn't make any difference. But I'm just suggesting that, you know, you create a closed loop system where you harvest the polymer and then you print from that polymer the speckles. So the whole thing is just a you know, it's a loop, which would make you good guys, you know, in the movie, you know. So it's just a thought. Anyway, I don't want to hog the microphone, but it's a fascinating and very thorough, you know, almost scientific project for me. I really you've learned a lot. It's probably made you really interesting people to have dinner with.
Just salt.
With a lot of salt on it.
Yeah.
All over the place.
Yeah.
So I agree that it was just a lovely scientific presentation. It was a lovely scientific presentation as well as all the interesting design solutions you're offering. To get from A to B, I mean, first there has to be some power to get there. And I'm just wondering why you don't use a beacon. Because if it has to talk to all the other guys or girls, why not do away with that? It's going to have the power to talk. So why don't you just drop a beacon where it's needed?
We want a decentralized system, and with the beacon, the agent needs to be able to aware the exact location of himself and also his destination, which is the beacon. So that is more like more advanced intelligence that we are putting into the agent. Now agents are only sensing the salinity level in a certain radius, so it's dumber, but it's decentralized.
I think it just needs to take the 25 samples over the course of a day, and it can compute where the location is. It could compute a vector.
Yeah. Also, as we keep mentioning in the presentation, the dynamic environment of the ocean. So the high salinity area doesn't stays at one place. It's related to all everything in the planet.
I worry that they won't find their way. At least the first ones, the forerunners. Yeah. There's going to be a lot out there looking in every which way. Mm-hmm. It's a big ocean, and sooner or later, you're hoping if you have enough of them, they're going to creep and then stigmergy their way to the destination. Mm-hmm. But I'm skeptical.
Okay, we need to try them.
This is okay, we're safe, I hope. All right. This is one of my favorite projects I've seen in I don't even know how long. So thank you for the beauty and the provocation and holy shit, the sheer amount of work you did. I mean, everybody here is I should say that everything that we've seen today is just of such a high quality, but it's really exciting to see this groundbreaking project. And for some of the things we've talked about, in the design research lab over the years about agents, about mobility, about responsiveness, you've provided some really interesting ways for us to talk through this, for Ross to ask some fundamental questions about oceans, and for David to argue with you a little bit about are the agents going to find their way or not, which is kind of a fundamental thing that we all wonder about when we're designing with agents. And there's something else you picked up here, which is architects for the last 60 years or so, going back to Christopher Alexander as one example, have tried to model ultra-stability in systems. So the way a spicule might turn on the one next to it and so on is the light bulb example he gives on Notes on the Synthesis of Form, which is a cybernetic model. And it's interesting to see it pop up here in this different kind of model. So it's Yeah, I don't know that I have a question per se, but it just is, I've appreciated that you've put into the dialogue here today and tomorrow some new ways to talk about how agents interact upon the real world in different kinds of ways with different materials and different dynamics.
Thank you. Thank you.
Thanks a lot for the project. I have a question, and please correct me if I'm wrong, but the whole function of the project is ultimately to capture some salt in a certain part of the world and bring it where there is some coral bleaching,
Yes.
and you release the salt, and that's it, right? I mean, that's the whole function of the project.
Yes, and also like the natural erosion of the currents will start dissolving the water the salt out of the formation.
Because, I mean, if it's a matter of bringing salt into coral reef, I believe there could be some much easier way or, you know, because think of the amount of energy you spend, for example, to 3D print the support and then to fabricate all the inflatable things and all of that. I mean, if I would be extremely pragmatic, you know, I would just take a plane and release some salt in the concerned area, a bit like what we do when we fight against fires, you know. I mean, we just take some water and we drop it from a plane on a forest. So I really wonder why are we going towards such a complexity? You know, for me, that's the limit of the project. It's well done, it's well engineered, and there's many extremely interesting things and an amazing amount of work. But the limit of the project is that it brings, at least according to me, a kind of unnecessary complexity and an unnecessary cost, including environmental cost, because in order to correct something which is dysfunctional at the moment in nature, you produce a very large quantity of stuff, or I don't know how to call it, which requires energy, which requires, I mean, many, I mean, you know, many chemicals and all of that. So it's some time, and I believe for the success of such projects, you need to go towards the easiest way. And everything you bring, you need to confront it to the easy way, let's say. And if it's not easier, in most cases it's going to fail, you know. And my feeling is that that's a parameter you didn't pay enough attention to.
Can I respond?
We actually got this question before.
Yeah. So I want to make it clear, like this project is not only to regenerate coral by increasing salinity level. It's a research on how we can use that salt as an element, and how we as architects what we can do to make response to this element. And also, let's say what we're proposing here is ever changing. It's everything is simultaneously. So and the time scale we're talking about is not like 1 month or 1 year. It's geological time. It's very long time. So if we only...
But I mean, I have to support the team, and I mean, by the way, fabulous work, and just as a side, just quickly bring that in, the video rendering is amazing. The simulation, the power simulation is unbelievable, and so on and so forth. And what we need to understand, of course, yes, you could make that comparison on a very pragmatic level, maybe on an economic level at this point, but this is about the dream of these kind of self-regulating systems like organic systems, bottom-up agent systems. And I think when they started, they probably didn't know yet that they wanted to solve the coral reef problem. So this is building up systems, building its capacity, exploring materiality, exploring spicules, etc., etc. And then finding use cases, etc. That's how this comes about. But I think in the end, look, we can't make this calculation because you have to fly aircraft with heavy loads, you have to carve salt from somewhere, you have to, you have human labor, continuously. Probably you're right at the moment in an economic comparison, but this is about a vision of another kind of symbiosis between artificial and man-made and organic and nature generally. So that's what it's about. It's not about that comparison.
I don't contest the vision, but I think the quantification would have been extremely useful.
Yeah, I think we listen to everybody, but at the end of the day,
can we add something there?
No. I was just asked quite a big question on CBS. They said, technology has got us into this mess. Can it get us out? I didn't hesitate. I said yes. Okay, because we need human ingenuity. We need to intervene. We are absolutely manipulators, the great manipulators. We're in the Anthropocene of all the natural world. And even if this system was something of a delivery system to enhance nutrition or whatever. I remember years ago I met Craig Venter, who mapped the human genome, right? And I said, gosh, that's an incredible achievement. What are you doing next? He says, I'm going off on my yacht. And I said, oh, you... I said, you need a break after all of that. And he said, no, it's not that. He said, I'm going to look into the oceans because I think it's full of DNA. And after that, I'm going to look into the air. Wow. So maybe the building blocks of life are out there. And I mean, I think what you're doing with the coral reefs is something that's a very high-profile thing. But I think there's other scales of that. As long as you produce a free, closed-loop system, then I'm behind you. If, like Philippe was saying, if you're intervening in ways which are illogical because they add to the problem, then I'm not going to back it. But I think pushing that you being responsible for the birth, life, and death of a bioentity, since we're on we're a biosphere, and there's not enough people talking about it. This shift from the mechanical to the biological. So it doesn't matter what it does at the moment. I think the fact that you made such an effort to work out a system, which with a little bit of help, you could really get to work.
It may be valid. I mean, I'm sure you know that the rate at which something dissolves is a function of the surface area to the volume. So if you, this is not working. So if you were to just calculate how much bigger your crystals are, or how much the bigger the composite is on your big structure, and compare it to the kind of salt one would shovel out the window of an airplane, yeah. I'm sure that you'll find that by the time the salt reaches the coral, it's almost half dissolved. Yeah. So whereas these things should linger, you could calculate it.
Another point is also that salt that would be just taken out from the airplane is human extracted. Yeah. Whereas what we're trying to do is a natural process. Yeah. And two-thirds of salt is harvested from like unsustainable regions. And while most of the salt exists in the ocean, only I think 5% of the salt is harvested from ocean that we use.
And it's extremely unhealthy for humans also
Yeah.
to harvest salt. So if these would need human labor, that would be very unhealthy to harvest salt and just like take it with a plane, you know?
What about the energy that's produced from sodium? I mean, you're presenting the project with these ways of illumination. But there's an energy
Yeah.
Because
we did that test.
Yes,
Yeah.
we did the test. Yeah, we did a test of how to convert the heat emission by the crystallization and convert it to the current, like the electric current.
We turned on lights.
Well, but yeah.
We turned on some lights with some
But we think the focus of this project is not about how to harvest.
Yeah.
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 Yes. Yes.
Of course.
Guys, if I can make this work. I'm going to keep talking, and this is going to work at some point, Bert. I'm the soft-spoken one, but I got a lot to say sometimes.
It's working.
Thanks. I feel like I'm getting like the motivational cheerleading to kind of get me. Yes, thank you. Listen, I think there's a lot of things that are scratching the surface, and I think the project has certain possibilities. I mean, Philippe's comments, I think, are also partially because you said this is about salt and corals and ecologies, and the whole concept of at least what we're trying to do with this elemental idea is to take phenomena, take this kind of elemental aspect of a different kind of way of thinking about the environment and to see it as a form of technology. To do that is to acknowledge that these things are everywhere, and at the same time to intervene means working with things. And now to the degree that this is needing to be blinky lights, agent, how many active agents, how many passive agents, I think all of those things, I think that there should be a metrics to that. There should be an optimization for that. To Philippe's point, I think it's important to be able to sort of say, well, actually, if I took an airplane and I dropped some salt, it's not like peppering my dish, because at the scale of the ocean, we have to think about quantities and the fact of where these things are and the resources to move them. So if that's not coming across clear, that's an invitation for you to make that more explicit. The same thing to David's point about some of these things may get lost. There was a guy, Rodney Brooks, who basically said, some will live, some will die, the job will get done. This is like agency thinking in terms of, it's not so much that this thing has to be exact. You talked about the inexact nature of a spicule, but the process itself is real time. It's probabilistic. It's like a weather system. The problems are very much data that is really being described from satellite imagery. Your agents don't have to be dumb. They have to be intelligent and collective. And simplifying things, I think, makes it more viable and credible and also scalable. So I think the issues are a lot. I think you're just starting to get into that. I think it's a subject matter that needs attention, and it challenges the idea that architecture has to be a building and sees it as a kind of infrastructure, which is something different from roads and highways. So working with nature, seeing that as part of the agenda, which is not greenwashing, which is not pretending like we know everything, but using the experiments to give you information, I think is important. And Patrick's point is also important. This is process-oriented. If we knew the brief from the beginning, this is different. And that's why this isn't a conclusion. So this is congratulatory on the one hand, but the hard work remains. I'm stating that because I think that that's very important. Like, design research should not begin and end in these walls. Now, the question about how this thing kind of evolves outside is not literally trying to build your project, but maybe it's literally trying to build your project. I have no idea, but I know it actually necessitates some creative thinking as well. So anyway, I think we have one more project to go. I think you guys got a lot of conversation. Did I inspire? I inspired you to talk. You see?
I will say I hate jumping in as I kind of pop in and out of a day that's obviously had its own rhythm of conversation. So it always feels awkward to step in halfway through a really good debate. I think one thing that has been mentioned about this project is there's an aspect of delight that comes through, the idea of these lights twinkling through the ocean, finding their way. But I think one important aspect of the criticism that you're receiving is that there will be moments of failure, and actually the kind of the imminent kind of presence of failure, I think, actually is a strength to the project. And if anything, it would be something to explore further. The agents that get lost, the things that sink and are never found again, the places where they over-salinate somewhere accidentally. I think that these things also allow the project to gain a layer of wit that also comes out of the hyper-focus of the subject matter. And what I really enjoyed is an acknowledgement of, I suppose, the vastness of the things that you haven't answered, which has allowed you to actually develop a level of sophistication that's really enjoyable, as well as being really a lot of work. So I've enjoyed it tremendously. It's a wonderful moment to come in, and thank you very much.
Thank you. Thank you.
Good evening. We are Team Phoenix, and this is Yili, Defange, Yasheng, and Yuhan, and I'm Jim. So our team is focused on densification of London through demolition and reuse. London arises from ashes. As London continues to grow, buildings are being demolished and replaced with new development to meet the needs of ascending populations. However, London cannot keep up with its development. The rate of demolition is not keeping pace with the space they are built up for. To address this issue, we propose a densification strategy that focuses on demolition and reuse of existing structures. Many buildings are being crushed down before their material expiration. Concrete, the most common construction material worldwide, is also the major source of construction waste and carbon dioxide emissions. However, concrete can continue to absorb carbon dioxide after 100 years. In the process of densification, 9.7 million tons of construction waste produced in the city. It is estimated that the waste can be reused in creating as much as 4 million square meters of spaces. So our team will investigate how to take this into an opportunities. Instead of powdering concrete, which consumes a considerable amount of energy, our project will involve cutting concrete into cores and reuse them in the new construction. Concrete can only cut into certain ways. Therefore, we'll use the fabrication method. We'll use curved crease folding, which provide a very unique property of creating 2D shapes made of concrete cores and can fold up into 3D shapes. So this is our proposal of our preferred structure, which can come flat to the side and fold into 3D spaces. Also, we use paper as a processing material to steel. We will explore different spatial properties through paper folding, and it allows for highly customization of the space. Through a combination of concrete structure and a highly customized space, we can accompany different activities at the site. Demolition and reuse are complicated issues. Therefore, we propose a gamified platform. Mass customization and negotiation is become possible. Our site is located near London Bank site, which benefit from tourist attractions such as modern and also St. Paul's cathedrals. Overall, we identify an opportunity to unlock the underestimated value of concrete. Through a gamified platform and the use of curved crease folding fabrication method, we can activate London riverfront.
The site is located at the center of St. Paul Cathedral, the Borough Market, the London Eye. After connected the city of London and the South Bank by Millennium Bridge, enabling the Tate Modern Museum draw lots of tourists and local people to gather around. However, there are not much activity available near the riverfront. Therefore, to take this opportunity, we decide to densify the area by converting this area into a mixed culture and retail district. The site contains luxury apartments, some bad condition housing buildings, and the Simpson House. Based on the analysis, the proposing site has a potential to be a cultural district mixed with retail, culture, residential, and hotels, and then the grid will be generated based on the inputs of the site, such as ground connection, green spaces, river, and bridges. With different game starting points, we will have the different outcomes as well. In order to understand more about how to use the demolishing and reused materials to our system, we did a case study. Simpson House is a giant old concrete cluster, which is used as data center and not designed for common programs, which can be as example how to set up a criteria of building assessment across London to structurally demolish and reuse them to bring in new developments and opportunities. Also, majority buildings being demolished in a 2-kilometer radius around our site are concrete modernist and brutalist buildings built around the 1970s and the 1980s. We studied the buildings as to understand the material availabilities. Dividing the buildings in 5 categories, we found components of facade and structure were best for reuse as they can have the highest input, embodied energy, and the longest lifespan. Other either had small lifespans or were already being reclaimed. Being modernist and brutalist, the majority demolished buildings were constructed with large amounts of concrete, making them our primary reuse element. By using this method, we can assess and find these buildings to use them as material banks. To better reuse the components structurally, each panel will be given a unique material ID stating their material type, original location, size, and reuse history. The first step will be allocate material from material bank. Through the bank, various materials can come together. The next step is to assemble the structure. Panels can come flat to the site and fold into 3D forms. Before we start the game directly, we rethink about the previous attempts we did to achieve this thesis. One is using curved crease folding as a mode for concrete casting, and the other is using it as a structural node. However, both of the attempts didn't have the property to be a valid modular, which can be developed in our game. We summarize the learnings and conclude a few properties for the spatial modular which can be used to generate reasonable space while using the concrete slabs, which are a compressive shape that can be made out of concrete slabs, stackable and expandable.
In order to reuse the concrete slabs, we studied the demolition procedure. Present demolition practices include surveying the building, stripping the building to its structure, demolishing of the structure through brute force, and dumping and downcycling the rubble. Instead of demolishing and downcycling procedures, our project proposed a top-down structural deconstruction of concrete frame buildings to extract structural components such as shear walls, slabs, precast walls to produce a stock of reusable concrete material in form of planar quads. This stock of material is then reconditioned where necessary, assembled and actuated to create relevant spatial modules. We studied various geometric parameters of the form such as crease position, subdivision pattern, and subdivision size. Crease positions that gave us arch span ratios between 1:7 and 1:12 provided the most compression-friendly forms. Arched and linear subdivision patterns allowed for easy load transfer from top to the base. Subdivision widths between 1 meter and 1.5 meter per piece in a 15 by 15 module provided the least local stresses and could be transported and drilled with available machinery. Based on these parameters, we created a catalog of possible geometric variations of the form. Through a local finite element analysis simulation, we divided the deconstructed material stock into 3 categories based on thickness, use life, condition to be allotted to different parts of the geometries. We used mixed integer linear programming, a cutting optimizing algorithm to find the best combination of material stock with respect to the geometry. Each cutting possibility is evaluated based on an objective function of impact value. Impact value is calculated based on the environmental impact for processes such as transport, deconstruction, reconditioning, production, fabrication, and assembly. Lowest impact and lowest waste cutting combinations are selected. This process is then repeated for each piece of the material stock to find the best variant. Once optimum cutting pattern is found, the impact for one piece is compared to the impact if the piece was made with virgin or new material. Wherever the impact of the reused piece exceeds that of the new material, the piece is substituted with the new material. Based on this process, we negotiate between percentage of reused stock and new material required to create our geometry. The process is then computed for all the possible geometric variations to find one which suits the material stock most optimally. Option A2, B2, C2 is the best fit for the present material stock with lowest impact, using 78% reused material and 22% new material. Process panels with hinges attached come to the side flat packed for assembly. For the 3D modules to act as a fixed frame that could be actuated from a flat sheet, we designed steel hinges as joineries between slabs. These hinges were designed to allow rotation till the necessary angle and then would angle stop and angle lock. These angles are calculated by simulating the curve crease folding movement. For actuation, we found that if certain points in the flat form were pulled up, the weight from the rest of the pieces would allow the entire form to be found, therefore using gravity to our advantage. This model was a 1:6 scale model. For the stacking process, the geometry requires increasing thickness at the base, tie rods at either position 1 or 2, and fixed frame joints that can angle lock and angle stop. We propose to set up a concrete processing plant for the reconditioning of the pieces after deconstruction before they are taken to the building site for assembly. The plant contains an unloading station, hinge assembly dock, before being loaded for transportation. It takes a hinge material quantification station, scanning, material ID station, cutting station, drilling station, hinge assembly dock, before being loaded for transportation. It takes 6 to 8 hours to process one 7 by 7 meter slab from start to finish before a plant with 3 belts can process material for one module in 1 day, thus cutting the fabrication time drastically. We also propose to use demolish facade bricks, crush them and use them as recycle aggregates in concrete walls. We propose to use demolished facade bricks, crush them and use them as recycle aggregates in concrete walls. Partial replacement of stone aggregate in concrete gave us the best strength. The formwork used through curve crease folding and is also reusable.
We experienced with paper to create very unique spaces for different activities. However, we found out that its vertical stability was a very big challenge. Later, we found that if we fold 2 curves along the edge, the walls on the side will be straight and create more reasonable spaces. Using different type of structure, we can design multiple spaces. We can design multiple spaces to cater to different user groups, ranging from studio to a 2-bedroom flats. Additionally, a user can have the options to customize the facade, roof, balcony of their homes. Also, they will also have the options to purchase additional air rights, which will be explained in the game part later. During this customization process, we'll encourage the use of reused materials.
And this is the workflow of our fabrication, and the tectonism is designed in a way that the load can be transferred to the ground in an efficient way. Our structure model is tied based on the site condition, like river, tide, bridge, and garden, and so on. For example, there will be a balcony on the river side, an arch window facing the bridge to respond to the different scenarios. And as mentioned before, the stackability is our main consideration. Here are some aggregation simulations show that the adaptive ability of structure module.
For massive production, we chose to insert pre-designed activity blocks into one or several structure units. And here shows 3 different types of activity assets. From left to right are made of joined voxels, activity block occupying the entire structure unit, and the size of activity block larger than one structure unit. For the first type is to reach the balance between the massive production and the customizable. We designed the voxel size at, for the first type is to reach the balance between massive production and customizable. We design voxel size activities like an alphabet that use as smaller blocks insert into each user customized activity unit. Here shows the voxel database developers can choose from, like receptions, sittings, display screens, gardens, etc. And on the bottom are the culture and commercial developers choosing voxels to form their modules, picture galleries on the right, and closed shops on the left. And the voxels can adapt to each different situations, like adding a circulation pass or adapt to each other. Let's look back to the previous gallery and closed shop. The chosen voxels then adapt to the users or structural needs, like adding circulations and meet the structural slabs of ceiling or the rearrangements of sittings or shelves. And Apart from user-chosen voxels from database, there are some preset activity blocks provided by the designer, like a default setting. These are the 4 examples of DRL classroom, picture gallery, food hall, and electronic product shop. And for each preset activity unit, when placed in different locations, they will rearrange voxels locations or replace some of them based on the location inputs. And here are the phenotypes of the electronic product shop. It will have a big display screen when the module is placed facing Tate, and more sitting areas when facing the river, and a circulation path near the bridge.
The second type is the activity block occupying one entire module horizontally. This is the double height climbing module used curved folding steel wall. And this is the interior view of it. Designer also provides default setting as well. Here shows gym, dancing, studio, and cinema. And this is the large activity of skating occupying 8 grids. Due to its large scale, we define it as an anchor module. It will be one of the center circulation as well, and some restaurant and bars next to the skating rink. And this is the interior view of it.
This is the short-term residential activities. Start from the bedroom units. Users can choose their size and interior layouts, like adding a clock room or a small library. And designers also provide some other living units in different sizes as well. And this is the aggregation of short-term residential modules from very small to large size.
After the spatial technology foundation, we started to simulate the game. Players can choose the roles based on their needs, and then player can browsing the surroundings of the site to have a better understanding of surroundings to help them make better decisions, which can also supply some basic site information such as location, traffic, program distribution, and etc. Then the system will calculate the land value for each plot. It is based on size and location. The closer to the Tate and the river, the more expensive the land will be. And the modular cost will be the combination of land value and the base price. We also estimate the potential profit based on the location, visibility, and the traffic to understand how player will choose different strategies. Since there are some emerging urban contexts near the site, players need to follow the skyline to respond to the context. To restrict the height of the buildings, the rule is to more high you build, the more expensive the module will be. We also separate the site into 3 zones, and each zone will have different multiplier for building up. To simulate the game, the player will be given a certain number of tokens to place, and we can also set different starting points to mimic the strategy of players. We also generate the second iteration of grade with same rules, so the players can choose different grade to create different outcomes. Therefore, players will have different choices to place their units. These 8 different outcomes help us understand how these factors affect the aggregation generated by players. Users will select the clusters within the site. To start the game, players need to place anchor modular on the selected cluster. And the anchor modular will be the center of the site, which will affect the strategy of each player. And the price will go up when it wants to level up. Also, after choose the anchor activities, they can start to place modulars, and the modular will be based on the role they selected. Also, they can choose whether to use recycled materials such as reused concrete slabs. If they choose to use these concrete slabs, they can get carbon offsets, so the price of modular will be less than the regular ones. While placing the modulars, there are also some restrictions. If player choose to have specific rights, such as air rights and the view rights, enabling players to create unique exterior spaces, and the rights will cost less than buying new modulars. So player will be encouraged creating interesting spaces instead of stacking rigidly. At the same time, they can also customize the terrace for their modulars, and the cost will depend on the size of the extension. After the process of placing, the player can start to connect with others' terrace if they want to. And after the modular are placed, player can start units customization. They are able to choose presets of activities as mentioned before, or custom their own. If there is conflict with other player, they can also negotiate with them to make change easily. Within the unit customization, the process is easy and able to create a vivid visual experience of the space to help them make better decisions about their customization. The video shows an example of customizing a bookstore and a restaurant. After the customization, the player can experience the space they created virtually, and then they can go back to unit customization if need to. With the platform, the players can create different outcomes based on strategy they used, and also allowing non-expert users to create their own spatial environment. The following, and they can create different outcomes. And Phoenix promotes a gamified platform implemented with special technology. It gives an interactive way to encourage engaging the process of demolition and reuse, incentivizing participants to customize spatial environment with reused materials. This is Phoenix and building tomorrow by buildings of yesterday. Thank you very much. Yeah.
To introduce the model.
So actually we started our exploration with the concrete casting by using the CCF as a mold, and we're trying to make a modular to fit in our games. And these are another attempts, which are the nodes. We're trying to use the CCF combined with concrete slabs as well. And then the grade, we actually started with the game, and after we get the outputs from the game, we starting to test the modular, if the modular fit into the, yeah, of course, okay. So actually we're going to test out if these modular can fit in our game, and those are our explorations. And also we starting to, these modulars we're trying to use, although they look so very simple, but these slabs, we're trying to put them together is very tricky, and so we need to figure out the way how to actually fold them. Because when you are folding concrete, you have to think about the hinges and the connections between them. And we tested how actually the hinges can work for the concrete folding. And so we test out the different options of hinges, and this is one big test we're doing, and with angle lock and other experimentation. And also this is one of our tests by using the cast concrete and using the hinges to fold them. But the hinges are not well connected, and also there is no tension cable inside the model, so it's very hard to actually fold them. But we actually figure it out, and we're making it happen to combine the hinges and the geometry, and yep.
Thank you.
Okay, thanks. I start. It's a very nice project. I think the global challenges it addresses are absolutely key at the moment. So I want to congratulate you for this. I have a couple of questions. Some of them like technical ones. It seems to me that if you want to build this ultimately, as it is at the moment, you need a framework. Tell me if I'm wrong, but I don't see how you can avoid using a framework. Having both the tension cables plus the folding, you need some support. That's... yeah, it depends on the weight. Do you know the weight of that, if you can lift it with a crane? It's all like 30 centimeters thick concrete blocks, so it might be a bit difficult. But another thing is that how do you bring the concrete elements to your factory? How do you destroy the existing building? Yeah, but I mean, how you cut the concrete slabs on site? Because I mean, cutting the concrete slabs in a factory, it's easy, of course. I mean, we are cutting stones for like 2,000 years, so it's not really a big deal.
So for
the difficulty is to do it in the building.
Yeah, so for cutting the concrete slabs in the building, the two things in this. One, it's a top-down approach. Obviously, it's going to take some more time. But what we are proposing is a 7 by 7 meter slab, which is we won't cut bigger pieces even if there are. So the transportation becomes easier, and also the cutting time can be regularized. And obviously the cutting process will have to be top-down. So when we'll remove the top slab, and then we'll have cranes as subsidiary movements to hold it and remove it. It will take a lot of time, but because of the fast fabrication procedure, that's where we are trying to reduce the time. And the second question about the actuation, I think the time-lapse video was a little too fast, but because of the weight of the pieces, we can actuate them in different sections also. So we don't need to actuate all together, because once the hinges lock into place, it acts as a fixed frame, so it can stay in places. The tension cable can be passed after all the pieces are coming together. That's why the locking and stopping mechanism, that first it stops when the actuation at a certain angle, and then you lock it, and once it locks, it stays in that shape, and it becomes more manageable as components.
Okay. Yeah, thanks.
I think, the presentation did do justice to all the exploratory investigation that is done. Just to do some justice to all the investigative research they've done before, which they've somehow skipped. So the two aspects, like how is this funded, right? Like, it's not so much like how we will cut the pieces out of the current building. How do we incentivize it? And that's where like part of the inclusion of this in the kind of gaming system, which they didn't fully clarify. So that's one. And then the second is like all of these shapes, like they're kind of coming from curved crease origami, which they keep calling CCF. And the unique property of that set of geometries is that it can be formed with planar quads, meaning flat pieces of concrete that can be folded. There's a bunch of research on string actuation, like where to place the string in order to fold this shape and all of that, which again, they're not fully articulated in this presentation. But so that, I think like that's really the merit of that part of the research, is like these shapes are not arbitrary. They're like very deliberately made from, or they're chosen curved origami shape so that they can be formed out of flat concrete pieces with some idea of how to actuate them into shape. I mean, of course, it remains to be fully tested as to whether like you need a crane or you need, you need like pneumatic pistons and so on. But at least like the few prototypes they've tried, like the one that is sitting here, and then the animation that they showed, like they try to use gravity to their own advantage. So yeah, just to put it in context because they seem particularly nervous today. So.
I think the curve falling flat shells are kind of convincing. I'm not sure if it is sufficient because it's relatively flat. But I do believe that through the curvature you get into a portal frame condition. So, and obviously it also needs the stiffening of the hinges in the planes. But in the corners, it's just the curves which rigidify the form into a portal frame, which I find very smart. And it's also I like the kind of strange clumsiness of it all because it is coming out of the process of the material of the techniques used. So it gives it a very strong characterful identity.
So if I could just add, in the model which actually gravity wasn't on our side today, so in that model we could actually really see how the hinges would stop and lock. We can see we have kept a test piece so we can show that there's an angle system which stops the hinges, so the angle will stop at this angle once it's actuated. It cannot. So finding the form is just not visual, it's calculated. And then in this case, as you see, we blocked these hinges. So that's the thing. And today gravity wasn't on our side, but we had actually kept this out in the wind and the rain for around like 2 days. But today I think it's right out.
Okay, I've been handed the microphone and I've been sat here thinking, what can I say? Because I don't want to be negative. So I just don't want to be negative. But is this a truly appropriate use of the material? Because the images you showed of all those buildings that we know, that material is not going to come out looking like this beautiful Tadoando shuttered concrete. It's going to look pretty rough. And then it's going to go through a pretty rudimentary processing. And then you've got the hinging aspect, and then you've got water penetration. You got lots of, and then you've got this incredible site. I mean, one of the best sites in the world, probably, next to the Tate Modern with the Herzog and de Meuron extension. And I keep thinking, what would Herzog and de Meuron do with that material? Because they're very inventive like that, accepting the raw and presenting it that way. And you've kind of rendered that out. And I think you probably know that under the surface, I mean, it's going to look a pretty rough building. And then I start to think, well, the volumes that you quoted in your report of recycled material, or material that could be recycled in some way, is vast. And I was thinking, well, where's the best application really? Is it roads? Is it airport runways? Where you need lots of aggregate that's not virgin material. Because this is a kind of, not a virgin site, but it's an incredibly important site. So I like the South Bank Centre kind of attitude to it. I think that's really social and democratic. So I mean, that for me outweighs anything I just said. And I do have reservations about the structure, because that's, I don't think that's an earthquake zone, is it, down there? I don't think. But, I mean, it's, looking at it, you've taken on quite a task, of what to do with these materials. And it's an unfolding problem. And we, it's like other materials. They say, we make acoustic panels for motorways. Anything that they don't know what to get rid of, that's what they kind of become. I just question the true physicality of what you would feel and experience in that. That's all.
But in that context, like, I mean, concrete is usually cycled into aggregate and end up in roads. I mean, to that extent, like, I do support the central London site, like that, like, you know, it's an appropriate siting to make, you know, make visible, like, certain aspects of recycling, which otherwise, like, you know, if you did this somewhere outside of London, like, it wouldn't really matter, right? And also, like, just to bring in aspects of circularity and sustainability as a topic of design and not just numerical, you know, life cycle analysis and, like, you know, timber good, concrete bad.
Well, and localized application of the material, because if you have to transport all that somewhere, the costs will outweigh any of the advantages, you know. So I understand where you're coming from. Yeah.
I think the thing with this project that's probably the most important is the fact that you're bringing a certain value system in terms of trying to think about utilizing this kind of materiality. The issue, if it's convincing or not, I'm not going to go into that conversation yet, but I think you do have to think about the dismantling of the building, the cutting, you know, like Matta Clark said, you know, with an eye for a scaffold, you know, as a sharp-eyed inspector, he used to say. Because in some ways, like, the art of dismantling is really the source material for your now reconstruction and redeployment. And that taxonomy and the limits of that, I think, is a very important part of the research that hasn't been fully vested in. And I think that that's where I find it a missed opportunity to do that, because I think as soon as you start to take every one of those slabs, everything that you cut, and you just had that as a series of building elements, instead of something that is visualized like you know, glass reinforced fiber panel, concrete fiber panel or something, I think it changes the way that you approach the project. It's not an issue if it stands or not, it's an issue of how do I make use of this materiality, its weight. You know, we talked about ensemble this morning with Ross just about particular problems, and you know, they find a way to kind of think about materiality and the rawness of things as something that's an attribute. So I think the validations always about curve crease folding or this or that, I think start to become slightly counterproductive in my opinion, because I really do think the merit of the project is not the proposal. The merit of the project is identifying a certain kind of strand of research which isn't about like selection of materials, it's about creative dismantling for the purposes of repurposing. That, I think, you could focus on. And I think that would have been a really useful contribution. The buildings and all of the things that you're doing from the gamification side and all of these other aspects, I think you have a good sensibility about thinking about architecture in terms of a programmatic, public space, all of these things, but I don't think we need South Bank 2.0. I do think that the site is not a validation of like, yes, we picked this site, so yes, as the architect, I assert that this is a positive thing. It doesn't really work like that. And I think the conversation somehow always lends itself to that because somehow that's what's being foregrounded. And I think you've done a very good research, but I think part of the research is also identifying that not all research ends up in a fully resolved place. So this model, which is the model that I think is the one that kind of gives you a lot of credibility, is not because it works, it's because it doesn't. But its rawness, its aesthetic, and all of those things, there's a vitality there because you chose to do it. I would have liked version 2.0. I don't think the foam, you know, like making something stand, I get it, it's important, but it cannot dominate the conversation. And then taking this tabletop strategy of weak form and compiling it, even if it can stand, it still offers an amazing amount of limitations that you can't design away from because you're not designing with the material. You're trying to force the material to do things that it wasn't really made for. And weight is one of those critical factors. So when Philippe asks you how much it weighs or if a crane can lift it, this isn't something that you can't do. This is like a day's work. I'm trying to kind of estimate average thickness of slabs. You know, this could have been very easily done, but I think when we get caught up in our own design methodology, we lose sight of those kind of basic things. What I think is important is for you to take this conversation, take all the conversations we had. It's not about reintroducing it into the book, but it's about reflecting on it. I think you're onto something. I think there are people that talk about material reclamation and using that, but unfortunately that industry is dominated with like fit outs for All Saints and stuff like that, and pubs that are looking for a look and feel. You're proposing something much more radical, and I think you should stand by its radicality, but also realize that it's not going to necessarily fit as a kit of parts, and that's where I think your gamification has to negotiate. We used that word before, and I think I really like the project for its intentionality, but I think the more that we try to squeeze it into some self-validation because we did it, I think it loses its currency, and then I think people will shy away from taking this on board as a subject. So if this is, let's call it 1.0 or 2.0, depending on how we're counting what this agenda is, it would be a really interesting thing for it to kind of continue, but it wouldn't continue with curve folding, steam bending, like that's the start. And then this introduces something different. And I think that difference matters. So I don't want to belabor any other point, but I want to validate the fact that its intentionality is worth its own credibility as a thesis argument. And I think it's a good thing for the studio because I think it also puts into question a certain orthodoxy of methodology, which we all have. Some projects break that. I think you do that based on your intentionality with your material reuse. But I think it would do yourself a favor when you're presenting this project to other people to do that little extra work. I think it'll communicate very differently, and I think you'll have a lot more people receptive. And it changes the conversation. Are you Dieste 2.0? I don't know. Are you Matta Clark? Are you this? Are you that? I have no idea. Because that first part, I think, is really what gives you the building blocks to do this kind of work. Okay?
Very briefly, I mean, I'm still puzzling over the logic of this. I mean, for me, there's something quite counterintuitive, and that makes it very beautiful and interesting. So, to have this curved folding applied in this way, with these segments, and what the hinges are, and how, when and how, which one have to be rigid, which won't, and how this stiffens up. So that's why I think it's a bit of a shame that you didn't complete a model which physically brings us home, that this stabilizes somehow, because that's when, let's say, when you look at this tensegrity model, you scratch your head, how can this work? You need to see it implemented physically, and then you bring home the magic, and then you start to get into it. So that's some of a bit of this huge polystyrene model doesn't do it, these don't do it. This is kind of a ruin. But I think there is a magic in that principle.
But the magic may not be called curve folding. The magic of calibrating elements in space with a series of hinges and, tuning this.
The curves play into it.
I believe that.
Flat, yeah.
I'm not saying that it isn't. I'm just saying that may not be the descriptor that sets this into motion. I think it's the base set geometry that sets the assumption that needs to be tested.
This is the best model which brings home some of it, but it doesn't work because it has elastic cables, so you don't. But that's I find really interesting.
I agree.
The way it sits.
I would say
loose pieces.
In the future, I think we'll just put tutors to sit underneath their student structural tests, and we will validate proof of concepts with action. No, anyway, listen, I think it's been a good conversation. I think it's been a good first day of discussion. And I think it's a good project to end on because I think it puts home a lot of things for us to think about and let's say call it round 2 tomorrow. So congratulations to the team, congratulations to the students that have presented. I'm going to bring this one home tonight so that we can go have a dinner as well and have enough stamina for tomorrow. I want to thank the critics because to be honest with you, we know that there are long days and if we sort of subject ourselves to this almost like every 3-4 weeks, it's kind of new to other people. So thank you so much for still being our friends and coming here to discuss work with us. Anyhow, for the people that are joining us tomorrow, we hope that the people here are part of the same people that are joining us tomorrow and continue the conversation. With that, I think, yeah, have a good night and we'll see you tomorrow at 10.